developer conference that's currently going on. So this is the first speaker of the session. We've got 6 hours running from now, and so you'll have myself, colleague Sean, and then my colleague Upkar kind of hosting as we go along throughout the afternoon. And we'll have various speakers. And so, like I said, the first speaker I've got is Margriet, who has been doing a talk on fairness in AI. Is that right, Margriet?
Yes, I did.
Cool.
It was an hour session, actually.
Yeah. So what was it? Was it a workshop more than a talk that you did this time?
This was kind of a little bit of a combination. I used a Jupyter notebook, talked people through trusted AI and how you can look at bias in data. And beyond that, also introduced the AI Fairness 360 tool. So it's lots of metrics and algorithms to also then do something about that kind of things.
Okay.
So
cool.
Yeah,
so
what I was doing.
What is it that got you into? Because you've done a few talks on fairness in AI and bias and that kind of thing. So what is it that kind of got you into that area in the first place?
That's kind of an interesting one because I think about over a year ago, I was asked to go to Paris to go to a Linux Foundation AI conference just as a participant and meet the other people there. And I ended up giving a talk about trusted AI.
Okay.
And so, yeah, I just got into it and quickly figured out what to talk about. And since then, just kept going, which is super interesting, a really nice relevant subject at the moment, I think, as well.
Okay.
So yeah,
cool.
That's what's going on.
Yeah. Well, no, it's good. I've just noticed in the Twitch chat, we've got someone in here, Lost Algorithm, who I think popped in when I had you on my Twitch stream a few weeks ago, which is sort of an hour before now. So I didn't do my Twitch stream today because we had this coming up. But yeah, there's a few people showing up in the Twitch channel. Oh, we've even got some spam, it seems showing up there already. So I guess that maybe means we're popular there if we got spammers coming in and saying stuff. Okay, so then, but your background is in like geology or geography, is it, if I remember rightly?
Yeah, kind of. I did a physical geography degree.
Physical geography, okay.
PhD and eco-hydrology, and worked with climate models and weather data, and so yeah, but all quite techy and lots of data, and ended up at IBM. That's the kind of the short version of a very long story.
Right. And so have you been able to kind of take some of this stuff that you've been doing with AI, into that area, into the climate modeling at the moment?
I haven't done any climate modeling at all, but I am in one of the other tracks. I've done another session today in the track 4, so where the challenge is introduced about predicting wildfires. I think there's a bit of an echo. I can hear myself, by the way.
Okay, maybe that could be myself. So sorry about that. Let me just grab some headphones here and put them on because it could be feeding back here. So yeah, you mentioned about the competition and that. So you've got 2 sessions. You've got one about fairness in AI and then one about this wildfires competition. Is that right?
Yes. So in there, I introduced the data again, another Python notebook, just playing around with the data, getting just introduced what the competition is about, which is all about predicting wildfires. It's a fun one, and it's also one where we have no idea what the result is going to be. But
right. And so you're gonna actually pop back later on this afternoon, I think. Was that right? You're gonna pop back later on to talk about that?
Yeah, I could, but I don't know. Am I?
Well, I think we've got one free slot later on. So if you wanted to come back and talk more about the competition, then you can do, or we can talk about it now.
Let's talk about it later then. Yeah. Fine.
Okay. Right. So now I've got to think of something else to ask you now then.
Yeah. So yeah, we did this thing a while ago on Twitch.
Yeah.
We tried to look at bias in UK crime data.
Yeah.
And yeah, that was an interesting one, because then I think we realized how hard it actually is to do this for real.
It is, because it was hard to actually just define things, if I remember right. Sorry, I'm just plugging in my headphones. So hopefully you can still hear me.
Yeah, totally.
Yeah. Okay.
No,
cool.
No more extras.
No more extras. Good. Okay. So yeah, we looked at crime data, didn't we? And we were looking at some of the stuff from one of the local police forces to try and kind of go through that data. And I think one of the issues we had was just trying to actually understand kind of the domain terminology of the data. I think that was one of the hardest bits, wasn't it? I think, we were looking at stop and search data.
Yeah, exactly. So it was all this data where you had lots of, you had a time, a date, and then why someone was stopped and searched, and the result, something like that, I think. And then also categories about ethnicity, age, race, gender, kind of thing. I think what we then realized was like, right, if you don't have a very defined thing you're looking at, like I did in a talk, was like, it's pretty straightforward. I have younger, I have older people, and they're not treated equally. Let's do something about it with the algorithms. But here, this was more like, oh, actually, what do I want to do?
Yeah. I mean, there were so many things we spent a lot of time trying to work out what we were trying to work out, wasn't it, really, in terms of how to frame the problem.
That's the thing.
Yeah, I think that's one of the things I find a lot with when I've been working with sort of AI is a lot of the problem, a lot of the difficulty is how to actually frame the problem you're trying to solve. So, for example, if you're trying to, you could say, okay, I want to, sort of silly example, but I want to predict the temperature tomorrow. And you could do that as like a regression problem to find out, or I want to predict the possibility of rain. And so that could be a regression problem. And you come back with, well, it's 40% likely to rain. Or you could actually say, well, what do I actually want to know? Which is, do I need an umbrella? And that can be treated, rather than regression, as a classification problem. Yes or no, I do or don't need an umbrella. So you've kind of got the same thing, but there's two different ways of solving it. And that's just in that one kind of simple example.
Yeah, totally. Yeah. So like the demos and the things we do is often, we don't even need to think about that first step so much. It just goes straight into, oh, here's a problem, go, and we make it super simple, and there we go. But yeah, it's a bit different if you're going to do something for real.
Oh yeah, exactly. So the difference between the kind of demos that we do, in which we're trying to demonstrate software and what you can do with the software, versus, like you say, in reality, trying to ensure. And I guess that's where the bias stuff comes in, isn't it? A lot of it is because you often don't necessarily see the bias in the data appear until you actually do production work and you have maybe more realistic data, because often you might be working with, say, a sample of data and you don't necessarily see that bias there.
Yeah, I think so. And also data just changes over time, obviously. So
right.
Yeah,
so
I mean, you have a model. Let's take the credit example from the talk. You train that on some data, historic data that, and then start using it in an application, and you totally might get some. You're kind of starting to influence the results by using the model that you might have de-biased, I think.
Right. Oh yeah, that's an interesting thing. So taking the example of the crime data, the stop and search data, say we use that to somehow influence, whatever, predict something that might influence government policy, then that's obviously going to affect the outcome of the policing. So whether somebody would be stopped and searched might be changed by that. We might have trained the data on a period of time before some maybe initiative or policy or public awareness campaign came in. So maybe there's some sort of public awareness campaign or something like that comes in at some point that changes people's response to, maybe in this case, being stopped by police, that might affect the outcome, perhaps.
Yeah, so in that way, I think how do you do? Is it still like allowed what you're doing with these models? And I actually don't even know the answer to that kind of thing.
Yeah.
Like, is there a law against? Well, there is in some ways, I guess, if you're trying to influence voters, for instance. Let me.
Yeah. I saw some really interesting statistics. I don't know if you saw actually recently. There's a correlation. I can't remember the name of it. Named after somebody, Berman principle or Berman rule or something, to do with the distribution of the first digit of a set of natural numbers. And it's something I tried to understand. And I couldn't quite understand how it came about. And I started reading one of the papers about it, and I still didn't understand it. But there's a higher probability of, say you have the number of counts voted in a precinct. There's a higher number that it starts with a 1 than it does than a 2 than it does with a 3, and I couldn't understand why, if you have a natural distribution of numbers, that would ever be the case. So yeah, I don't quite understand that one.
Oh, I don't even know what you mean, really.
No, okay. I think the effect of it was. I'll have to look up. What the name of the thing is. If anybody in chat knows what I'm on about, then please speak up. And maybe you know the name of the the principle. I think it's named after somebody. But we've got somebody here. Somebody has asked in the in the chat. Said, how often would you say that models should be retrained? You gave an example there of a new initiative might make a model outdated. So,
I think again, it depends. That's a brilliant answer. So, I think you just continuously have to monitor your model.
Right.
On accuracy, on bias, on whatever metric you think is important, and with that, there is a tool. Matt already where I'm going here. So there is a tool to do that.
There's a tool to do this. Yeah.
Yes.
I was going to say that, but I thought it's better you mention it. So yeah.
So yeah. With OpenScale, which is also in the IBM cloud, this automates all these kind of things.
Sorry, what's that one called?
OpenScale.
Oh, OpenScale, right? Okay, I thought you said OpenSkill. I was like, that's a new one to me. OpenScale, right? Okay, yeah.
Yeah, and I think that's also been used in track 3 in the whole course, but I'm not 100% sure.
Right.
And but the whole idea behind is to track everything you do continuously while you're using your model. And if you don't see things going down, or you just go through a certain threshold, your model just gets terribly not accurate anymore. Retrain and then redeploy, but only if it is, of course, better. Else I wouldn't. But yeah, so this is like the principle, and OpenScale automates all that around it. But
right.
Yeah.
I've just been trying to find the name of this. Lost algorithm, fantastic, thank you. The Newcomb-Benford law. So yeah, it's been referred to a lot as the Benford law for numbers, and it's supposedly something that shows that in a, I presume it has to only be in a particular case. But that the set of numbers, that the first digit of that number is a higher probability of it being a 1 than a 2. Like I said, I can't understand how that could be the case in a set of a normal distribution of numbers. But I think from what I read of the paper, it's if you have multiple normal distributions, say numbers drawn from 2 separate places that both have normal distributions, and then combined via some operation, that you can get this effect coming out on it, and that's and you kind of get this sort of curve of the distribution of numbers. So, but it's just recently popped up because a lot of people it's one of the distributions in one of the voting precincts in the US has sort of failed the test of this, and so people are saying that it could indicate that there's been fraudulent activity with those votes. Again, it's one of those things where I think naturally you could fail these tests quite easily, and so I think a lot of people are reading more into it than there actually is. And so I went and had a look. Somebody's created a Python notebook for it actually, and I went and had a look. And there's a whole bunch of issues that have been opened against it in GitHub where people are saying, well, this doesn't mean what you think it means, and whatever. So it's yeah, I guess the power of data science in these kind of environments. So yeah.
Yes, yeah, I think especially in all this trusted AI, it is important always to not just work on your own on this kind of things. So
right, that's an interesting point. Yeah,
I think because it's so easy to just get almost tunnel vision of the one thing you're trying to solve, and yeah, already introducing bias by doing that. I'm pretty sure I did that myself, even in doing research, and so like I need to get that result. I will find it.
Yeah, exactly, and it is hard. I mean, when we were looking at the crime data, it's kind of like there's a thing that's been said about the frequency of which different races are stopped and searched, right? And so you kind of want to go into the data, and you're trying to. What are you trying to do? You're trying to confirm whether what has been, say, reported in the newspapers or in the media fits the actual data, and does that bias exist? But the fact that you kind of know what has been reported when you're going to look for it, how do you not have the bias there? I mean, like you said, tools might help that, but you've kind of got the still the human bias on top of the tools.
Yeah, it's almost like it's blending in with psychology and all that kind of thing, where you always have this problem, obviously.
Yes, yeah. I bet that'd be interesting. I wonder if there's sort of a crossover there, where there's things that machine learning as a discipline can learn from things like psychology, from things like how you do, I don't know, double blind tests on a medication, for example, and things like that. That obviously they have to kind of do that extra level, and I think that's what's been interesting about the things like holomorphic encryption, the homomorphic encryption rather than homomorphic encryption, in which you're able to encrypt data, then operate on the encrypted data without seeing what the data is, which is quite interesting. So applying that to AI, you could probably you could blind the data before you even get to work with it, so you don't even know what is in. You're not even seeing the data yourself. I don't know how much that helps, though.
Yeah, but then you sometimes totally run into a different problem. If you're just taking out something, you're saying you don't know anything about the data.
Yeah.
But if you would just remove one feature or something like that, and then try building a model, that would be not the same. So scratch that.
Yeah, indeed.
But I did see some interesting master's courses. I don't know where I saw it, but all like combining data science and philosophy and that kind of things together.
Yeah.
So
okay.
Yeah. So it is a thing. Yeah.
Okay.
I can't see this Twitch. What's it called? Chat, because I forgot. I turned it off, so I had more bandwidth. So.
Yeah, I'm just actually mentioning in the Slack channel as well for the conference as well that I meant to sort of put in there that we've gone live on here as well, just to let people know if people are watching in there to kind of come along and come and have a chat about things. So
yeah, cool. No questions.
Oh, we got some. Well, we have got some questions coming up in the chat here. So, sufficiently sized PP. Okay. Where do you want or see Leap AI coming from in the foreseeable future?
You broke up. I didn't hear that.
Oh, sorry. Where do you see? I was looking at me. I was looking at you. Another thing. Where do you want to see or expect to see leaps in AI coming from in the foreseeable future?
Oh.
It's a big and open-ended question, isn't it?
It totally is. Yeah. Well, I don't know. Where does it go? bigger computers, faster models, but that's the obvious one, obviously.
Yeah.
Any ideas, Matt?
Well, yeah, like you say, sort of bigger and faster, and I guess kind of part of that is kind of pushing it out further to the edge, and sort of smarter devices being kind of smaller and more ubiquitous, I guess. I mean, we've got sufficiently sized PP. Stay in the chat, stay on the thing, because we've got a number of people speaking today as well, who'll be coming in. So there's a number of other people who might have some interesting thoughts on that as well. In about an hour's time, we have about 2 hours time, hour and a half's time. We have Ruchi Puri, who's got a fantastic talk called "Software is Eating the World. Can AI Eat Software?" And so I would recommend to come along to that. It's a really interesting talk, talking about kind of the future of AI there as well. So
next up is Romeo, or not?
Yes, yeah. Romeo is going to be talking about reinforcement learning.
So we'll have an opinion as well.
Yes, yeah, indeed. I'm looking forward to talking to him about some of the reinforcement learning stuff with FinTech as well. So Ed in the chat asks, maybe the owner of the use case can provide the data scientist with data where the features have been renamed and normalized such that they don't mean anything to the data scientist. Have you ever seen that happen, Marguerite? Is that something that happens?
Well, it kind of happens, I guess, when you hash at least some of the data, like follow the GDPR rules, things like that. So it does happen.
Right. I guess and in some ways it kind of is happening on the basis of we don't actually understand what some of those labels mean. So when we were looking at the crime data, we didn't even necessarily know what some of the labels meant. So we were trying to work out what was it? We were looking at the outcomes of a police stop and search. And I think there was 2 outcomes that were similar. There was like one was nothing happened and no action was taken or something. There was 2 that were very similar in sound that we didn't understand. So I guess if the data is completely blinded to that point, then it's very difficult for us to even kind of formulate the question.
That makes it kind of harder as well if you have no idea what you're looking at, because it is really makes sense to know what you're looking at in the data to create new features, I think.
Yeah.
So, yeah. Don't think it's an advantage to actually not know what it means anymore. But then again, then you can start maybe using AutoML tools that just do everything for you.
Yeah, I guess so. So Auto AI, IBM's Auto AI has no idea what the figures are, has it? You pass it to it, it doesn't know. But you've still got to say what the figure is you're looking to predict there at the end, which bit you're looking for. So
yeah, but it just will add new features by itself. Kind of, don't mind.
Yeah. And Lost Algorithm says, we recently introduced an ethics in machine learning course in our data science masters, which is far more interesting than I would have thought. So, yeah.
Cool.
I guess it is. I mean, it is for me. I mean, I have to say, when I first kind of came across the topic, I thought, no, that doesn't sound all that interesting. But there's so many areas that it impacts that I guess it is a really interesting area to be studying, to be looking at.
Yeah, even just technically, I find it a really interesting, different way of looking at data models.
Yeah,
it's like you're just always obsessing about accuracy sometimes. So you need to get the best model, but now how do you then also make it fair? How do you actually write an algorithm that does that and things like that?
Yeah, and I suppose you then possibly have a balance off between the two.
Yeah.
I mean, typically, you can have already kind of balances between when you're trying to do, especially if you're trying to do things like classification upon multiple classes. How do you define, what accuracy is? There's various accuracy measures, sort of accuracy in F1 and ROC and things like that. It's a case of, is less false positives better than more false negatives? There's different ways in which you can frame it. It depends upon your end use case. So if you're working on, is this medicine going to help this person? Well, there's a difference. If you give a healthy person the medicine and the outcome is it just has no effect on them, That's obviously very different than if you fail to give a sick person the medicine and as a result they die, or if you give a healthy person the medicine that they don't need and they, become ill as a result of that. I guess you get the same thing in bias as well. Look at what is the impact of the bias. If somebody doesn't get hired because their name sounds wrong according to the AI because it's learned it, then that's one thing. If it hires too many people, is that as bad? I guess it depends upon the actual use case, really, doesn't it?
Yeah, and that's exactly why you then just have to decide which metrics and algorithms to use to optimize the models and things.
Yeah.
So yeah, there's quite a lot to learn about it all.
Yeah, and there's a comment that Ed, I think it's Ed She Monster, says in the chat about not being able to create extra features. Well, actually, Lost Algorithm brought it up that you can't do the feature engineering if you don't understand the features, right? So, I mean, the classic example is the Titanic data set that is often used for Kaggle and competitions and things like that, learning about machine learning. You can use your understanding of the features to do feature engineering. So, for example, that Miss and Mademoiselle are the same thing, just in two different languages, but they both represent a younger woman or unmarried woman in this case. And, Doctor, Reverend, Professor, Lord represent nobility, which may have an effect on the outcome. So, you're able to use that information because you can see it. If those fields had been blinded, you wouldn't have been able to add your own sort of knowledge into there, I guess.
No, there's just the obvious ones. Take the logarithmic from stuff and see if it gets better, of course. But beyond that,
yeah. I mean, I guess that's what Auto AI does, right? I mean, Auto AI can't understand the features. So, and it's come up with some really impressive ones. I mean, was it with, I can't remember, it was either with you or Yamini, in which we ran it, and it was you, and it came up with some really quite, complex compound features where it had taken two of the original features and done, fairly substantial, manipulation of them, a manipulation in a good way, manipulation in a, in enhancement of those features, combination of those features. So.
Yeah, no idea when we did that though. But I remember we did that on a Crowdcast.
It was on the Crowdcast.
Linear regressions.
Yeah. Cool.
Yeah, that's unfair. That actually, Auto AI found a better, more accurate model than I did.
Yeah. I mean, that's that, and that is one of those things, isn't it? Again, it comes down to if Auto AI and machine learning, automated machine learning tools, are they going to be better or worse than humans? Because maybe they don't have the same bias as us. Maybe they do have the same biases. Is there a sort of a check and balance there that you can add in?
Definitely.
Cool. Well, okay. Well, we're coming up to a half hour. I've actually got Romeo kind of on here. So, I mean, Mike, if you want to bring Romeo on, then we can maybe just say hi, and then maybe Marguerite can pop off, unless Marguerite wants to stay on and chat as well. So, hello, Romeo.
Yeah, happy either way.
Hey, how you doing?
Hey, can you hear me?
Yeah, we can hear you. So
awesome.
You're in your car somewhere, yeah?
Yeah, as usual. So that's my office. It's calm. Nobody disturbs me.
That's a good plan. I did a video from my van once, and it is quite good. And amazingly, the acoustics are generally pretty good as well, unless you're driving.
Yeah,
obviously.
It's awesome. It's the perfect studio and living room and bed and dinner place. I love it.
Somebody said in the Twitch chat, are you hiding from the kids?
Definitely. That's. I mean, otherwise my laptop is tortured, and there's no way of getting work done. So I'm happy in my car.
Cool. Okay. So I mean, Romeo, do you want to just give us a quick sort of recap of the talk you did? So you did a talk on reinforcement learning, right?
Yeah. So I gave an introduction to deep reinforcement learning. So what I have explained there is how reinforcement learning really works. I have given some hands-on exercises and tutorials on how to implement reinforcement learning with plain native Keras and TensorFlow to actually understand the basics. And then I moved over to Ray because Ray is hiding all that complexities for you, which is good on the one side, but on the other hand, it's then a black magic thing. No? So you need to at least once have a real implementation.
Yeah.
And then I've used Ray and RLlib to create a trading bot.
I just want to say, just before you go on, I just want to say thanks a lot to Marguerite. So she was just on, and I didn't really sort of get a chance to sort of say bye before she was dropped off. So I just want to say, thanks very much to Marguerite on there. And like I said, she's going to be possibly pop back later to talk about a competition about forest fires and AI that they're working on. So pop back later on, and she'll be on later. I'll try and put the time in the chat as well in a bit as well. So, but yeah, sorry, go ahead, Romeo. You were talking about using RLlib and how RLlib kind of hides a lot of the complexity, but you also did it manually in Keras as well, didn't you?
Yeah. See the very simple plain hello world deep reinforcement learning I implemented in Keras and TensorFlow, just to get the understanding. And I have to say, I needed some time to get on-ramped in deep learning. So I did this like 3 years ago. And DeepRL is still one level more complex. So to really understand it, you need to really dive into the math. But on the other hand, you can use some pieces as a black box and just plug it in. That's what you can actually do with Ray. Because once you understood the basic concept, you can just try out different black boxes, which are kind of state of the art in the latest achievements in DeepRL for the latest challenges in 3D shooters and strategy games. And you can just try them out because the interface is the same, but the implementation slightly differs and gives you better results. But that's the cool thing in Ray. And the other thing, what you have in Ray, it's parallelizable. So you write the code once and you can just run it everywhere. So we are currently working on supporting Ray as part of the IBM Cloud natively. So stay tuned for that.
Yeah. I mean, one of the things I like, like you said, with reinforcement learning, with the things like the Gym API are great because you can just drop in different implementations and try them. I've yet to try Ray myself, but I quickly saw your demo there, and what I was amazed was how quickly it ran. Actually, in your notebook there, how quickly the training step
and
ran.
Also you mentioned the Gym API, and that's actually really cool because you are like learning all the reinforcement learning tutorials are using the OpenAI Gym API. So you are used to interact with an environment like the card pole environment. I'm also using that in my talk at the beginning, or the Atari games, and it then boils down to just implement this API for your problem, and then Ray is doing the rest for you. That's actually what I've done. I have modeled the trading problem as an environment, and Ray can interact with this environment and basically learn from the environment, and that's the way the algorithm is optimizing on the trading strategy.
Yeah, I was really interested in your example there. Your trading algorithm did very well. I've actually got a personal interest in writing sort of trading stuff and machine learning, and that's kind of almost accidentally how I ended up at IBM and interested in machine learning was through doing that sort of stuff in my sort of spare time. And it was interesting to see, what you used as a reward function for example there, because that's one of the things I found quite hard with reinforcement learning is to get the reward function correct, because I found you can scare the reinforcement algorithm if your rewards penalize too heavily. Then your algorithm will start to go, well, I'm not going to do anything because I'm going to get penalized really badly, and you almost kind of scare it away, I've found.
Yeah, I think that's the area where most of the research is concentrating on how to shape the reward function, because a lot of the environments, what I also explained in my talk, they give you a sparse reward.
Right.
And that means actually you get the reward at the end of the game if you're lucky, or after a couple of iterations. But what we actually need is constant feedback. So that's where the algorithm performs best. And a lot of research is going on in how to shape this dense reward functions. And it's not environment agnostic. So you actually have to do it on your own. And in my case, in the trader, it's pretty simple. No, you are allowed to, in each iteration, you are allowed to sell or buy assets for $100. And actually, if that was making you a profit, then I give you the reward. Otherwise, it's a negative reward. So that was relatively simple for me.
Yeah, so you were giving a small reward after every step based upon the change in portfolio value as a result of that step.
Exactly.
Yeah, because I've tried approaches like that. I've also tried, like you say, the more sparse rewards of giving a reward at the end of, say, in the case of trading, the idea you're trying to do is buy something cheap and sell it when it's, worth more. And I've tried doing things like only give the reward on the sale, because that's when you know whether you were profitable, but that depends upon when you bought. And I found it very difficult to kind of propagate that information back in time so that the algorithm learns when's a good time to buy, right? Because it knows when is a good time to sell, but the good time to sell depends upon when you bought, right?
That's true. So I'm computing the actually increase in portfolio value at each iteration, and that's the reward. I'm seeing some questions. Shall we take on those?
Yeah, so there's a question here. Out of curiosity, generally speaking, long-term or larger data sets are better, but what range and size does decently well for financial models? I guess that's...
that's a very good question. So this demo is some sort of a starter for you. And I will also work on it later. So what it currently not does is the policy network isn't LSTM. So the next try I will do is using a LSTM. And after that, the new wave of models, transformer models, is something I want to try. So if you have a transformer model, actually the data set length actually isn't playing such a role anymore. So you can just give it the whole length of the data set, because the transformer model using this attention mechanism to focus on the actual values which are important for your prediction. So given as the algorithm is at the moment, it makes a difference, but it's not something I want to use for trading now. So just iterate with me on that and use a proper transformer model, and then the data set size shouldn't matter.
Yeah. And one of the things I found as well, especially with RL, is that just the smallest change can make a big difference in how something learns. I mean, I had an issue, I think, with, I can't remember what it was now. I think it was just to do with like rounding numbers when you round up versus round down. Okay. And the rounding function was just like ever so slightly favoring one direction. And that would, and the reinforcement learning algorithm was picking up on that as being a feature and was learning from that, and that was then giving it, sending it off in a an undesirable direction, basically, because it was picking up on something really small like that as well.
That's what the community actually says when they say deep RL is highly sensitive to hyperparameters.
Right.
And I think the reason is because the policy network, while it gets trained, decides which parts of the environment it explores. And if you end up in a setting where the policy network actually loses some excitement and doesn't explore and only exploit, you are not exploring the whole environment, and that actually might get you stuck in some region of the optimization space where you never can get out anymore.
Right. Yeah. That's I've had it get stuck. I think I've mentioned to you previously, I've had an algorithm go, I'm going to learn the best way to be profitable is not to trade at all. And it reminds me of that 1980s game War Games, in which the kid breaks into a nuclear facility and starts playing tic-tac-toe, noughts and crosses with a computer to kind of avert nuclear disaster. It was a 1980s Disney film, I think it was. And, it reminds me of that. And I keep looking at it going, is this algorithm really, really sentient, and that it knows that in the end, the house always wins, and so I'm best never trading, or is it just broken?
Right? No, it's totally differently. I think if you are a long-term investor, you can't really do something wrong. So there are different scenarios you can model, and the data set I have just used, you can use, and the chances that you lose money is actually really low. So what I have done in this algorithm basically is an optimizer. No? It just finds out the optimal trading strategy, and at the end it spills out the amount of the money you could actually win if you just invested $100 each day.
Yeah.
Okay. And you see, it's a huge amount of money you can win this way. But we have also done some calculation how much money you could lose. And if you only invest $100 per day, it's very hard to actually lose a lot of money. So it's a relatively stable thing if you cut out all the emotions. No, the problem is the emotions. If you just sell everything because you are afraid, and see, it's a relatively stable thing.
That's one of the reasons why I write algorithmic trading software myself for trading stuff, is because it takes emotions out and I can leave it running. And the worst times I've kind of lost money on trading is when I've actually interrupted the algorithm and gone, no, don't do that. I've interrupted it, and then I've been wrong and it's been right. Right, and I've got to stay back and leave it.
Yeah, and I mean, it's interesting to know for everybody, because now there's a new area in trading where all the private investors are coming in, and they are highly emotional. No? So I'm fearing that they are losing money. So that's one of the reasons I wanted to democratize algorithmic trading by just explaining how relatively easy it is. And that stuff is basically stuff which Goldman Sachs and all the big traders are using, no? And just use it yourself.
I mean, the big thing that you're missing in your model, I think, is trading fees, and that's generally where I've found the loss happens. It's very easy to make something profitable, with no trading fees, and then you'll find as soon as you start adding trading fees in, because I think the trading fees often are probably calculated effectively by somebody applying a mathematical model to work out what the best fees are. So it's almost kind of goes back to the almost a bit like a generative adversarial network, in which you effectively have two AIs working against each other, right? So you've got one working for the trading house, working out what is the best fees we can charge to make the most money, and the traders on the other side with machine learning algorithms trying to work out how best to make a profit, and maybe they're working against each other. But we've got a couple of questions here. We've got Lost Algorithm asks, how did you end up with RLlib? The RL space seems pretty saturated with frameworks. Any unique points with RLlib and what sold you on it?
I have a very, very good friend who does RL only for living, and he just told me that RLlib is the most mature at the moment.
Oh, okay.
And I've done some investigation on myself, and it seems to be true. So it's very stable, and nearly every academic publication you can find is implemented in RLlib.
Okay, cool. It's one I've yet to play with. So I've used Stable Baselines, which was a fork of the Baselines, the OpenAI Baselines library, but that's only for TensorFlow 1, not TensorFlow 2. I then used, I think, TensorForce as well for TensorFlow 2, and I think I used one based on Torch, or I wrote one sort of myself with Torch. But I need to play with RL.
Way you can swap between TensorFlow, PyTorch, and TensorFlow Eager, and your implementation doesn't change. It's just one flag. It's even more fun.
Yeah. So the next speaker, I think it's the next speaker coming up. I've lost my schedule here. The next speaker coming up is David Cardew, who's talking about stacked learning models, which look quite interesting. And so stacked learning models are taking the idea for supervised learning, of taking like ensemble models a step further. So you're actually taking several ensemble models. So you're taking things like decision trees or XGBoost, and basically running them in parallel and combining them. And I'm almost wondering whether there's something you could do with RL in a similar approach, in which you have multiple RL agents. So maybe you have like one running PPO2 and one running a different algorithm, or one running DeepQN or something like that, and kind of almost like evolving from there as to what is the best approach.
Oh yeah, that's a good idea. So let me take that for my next NeurIPS submission in 2021. No, I'm really feeling that. So there was a recent publication also from Anyscale and the Ray community about hyperparameter optimization. And actually, while you are changing the hyperparameters, you are evolving and training the weights. And I feel you can share the weights of the policy network and have different parallel ways of training and update them simultaneously. And that might be the new, might emerge as the new standard. I just feel it.
Well, I mean, because doesn't AlphaGo do something effectively similar? Because isn't AlphaGo, or AlphaZero rather, AlphaZero is kind of uses a genetic algorithm, doesn't it, between the different generations of the algorithm? So could you do that with hyperparameters maybe?
Yeah, that's actually exactly what is done with hyperparameter tuning. There is a algorithm called PBT. It's I don't know what it means in long, but it's actually doing that. Now you have the hyperparameters are in a set of generations, and in each generations, some of them are copied, some of them are randomly changed, and that's that implementation we have in Ray as well.
Yeah. Okay. Because I think the reason I first heard about Ray was not in terms of RL, but I think in terms of hyperparameter optimization, because I think Ray has a hyperparameter optimizer in Ray or RLib or I can't remember which, something in there that runs in parallel. So compared to something like maybe OpTuner or HyperOpt, it seemed like it was maybe able to use parallel resources a bit easier. Although I think OpTuner can do parallel.
Yeah, in Ray it's called Tune, and that's exactly right. So everything in Ray runs in parallel. That's their promise. But we have the same thing also in Kubeflow and Kubernetes. It's called KETIP, so you can also have a look at that. And they are more or less on par in the features of the supported algorithms. The Ray Tune has some more. On the other hand, KETIP has better UX, better UI support, and multi-tenancy and user management and that stuff, and graphs and all that stuff we like.
Okay. Yeah, we've got a question in the chat about be interested to see how the models capture the effect of 2020's financial markets. I guess that's one of the big things with kind of financial modeling and machine learning is, do you include the kind of the black swan events in your model, or do you filter them out on your training?
Okay, I haven't. Interestingly, it performs really well. So if you would move them out, I expect to get even better results, but I leave that to an exercise to the reader. Or what? Yeah,
I guess, I mean, that's the thing is that you can track. I mean, I've done some bits of it, and it's like, okay, this algorithm does really well, apart from when there was this massive market crash, and then you lose everything, for example, or whatever you do really badly. So by factoring that, if you have that crash in, if you assume there's going to be another one, then you may well do equally badly. But if you factor, if you train with that crash in, you might choose a more conservative approach that doesn't do as well overall, but maybe doesn't do better generally, but does do better overall if you factor in the kind of the black swan events as well.
Who knows? Maybe even a market crash. You can also consider little crashes in your data, and if you invest then at the right time when the market crashes, you can even make a lot of plus. So yeah, don't underestimate those.
No, indeed. And I think your example, I think you're working on daily data. I think daily price data for your example that you showed. Because I've played around with daily data, with hourly data, and with sort of minutely data as well, to kind of look at different strategies about kind of getting towards not quite high frequency trading in what financial markets really call high frequency trading, but certainly trading in the minute time range rather than the hour or daily time range, to kind of see how that goes. And that's been interesting. Like I said, fees are obviously a big issue, but potentially if you can do 1,000 trades a day, and if the majority of them or more than half of them are profitable, then maybe that's better than doing one trade a day, perhaps.
Okay.
So yeah, cool. Okay, just seeing what else we've got kind of coming in the chat here. Yeah, somebody says that AlphaZero agreeing with that, with the genetic algorithms. And apparently there's plenty of RL ensemble publications already. So maybe somebody's already come up with that idea of doing that. So you're gonna have to come up with a different idea for your paper, I guess.
Yeah, I don't like academic papers anymore because it's so competitive. You need to be the first and the best.
Right.
I much more like to contribute to already existing GitHub repositories. It's much more fun.
That's what I found interesting with trying to do the AI on financial markets is I'll go looking and I'll find some financial paper from like 1980 talking about some trading strategy that has been done, manually back then, and try to see how it can work. And a lot of them, for example, are based upon traditional stock markets that will have a trading day. And so they'll have a start of trading day and end of trading day. And obviously that strategy might not work on something like a cryptocurrency trading in which you have 24/7 trading, or Forex in which you have similar kind of approach.
The fees are rather low on cryptocurrency, so it's also a different thing.
Yeah, they can well be. I've been working on an algorithm. I've been sort of doing some live coding on an algorithm that uses that's doing a pairs trading strategy between UK North Sea oil, Brent crude oil, and US, the West Texas sweet oil futures markets, because they're both underlying oil markets, but they're different. And looking at the kind of the anomalies between them, and so when they diverge, when one diverges, you have a potential to maybe go long on one and short on the other. And when they reconverge again, make a profit based on the differential between the two. And I've been trying to train an RL algorithm to kind of study that as well, which has been interesting to see.
Yeah. By the way, I've just checked out what PBT stands for. It's population-based tuning.
Okay.
And I've opened an issue in the CATIP project in GitHub and suggested that they should support PBT, and it seems that they pick this up. So we will have it available on Kubernetes and Kubeflow soon, I guess.
So is that just a better way of picking hyperparameters then? That's a better way of estimating the next set of hyperparameters?
Yeah, the thing is, I don't know if I find it in 1 minute, but it's searching through the hyperparameter optimization space in a very efficient manner. Because there's this random search and grid search and also Bayesian techniques. But this one is really, really different and better. But I don't know whether I find it.
Because I think TPE is the one I've come across before. TPE, which is Tizen parameter. I can't remember exactly what it stands for.
I think that's available in CATIP, but that's a new one. Yeah, I don't find it now in a second. But it looks like really interesting. It's like tree flowing through the optimization space, and it's really concentrating at certain branches. That means it just strips out a lot of the downstream path or downstream branches which are not promising, and that's done via this genetic algorithm. So I think that's the state of the art. And they tried it on existing data sets and existing deep RL problems, and they always had a better performance. So
so I'll try and look at it. I've been using a hyperparameter tuner, not actually for a RL algorithm as such, but for a algorithm for a project I'm working on called Quireless that synchronizes audio together and synchronizes two pieces of audio. And there's an algorithm that tries to calculate the best offset for two pieces of audio when when's the best match. And that algorithm takes a number of hyperparameters. So I've actually been using OpTuner to tune that. I might try something like RLlib because it can do the parallel running maybe a bit easier. So
yeah, we are currently working on. I don't know whether you have covered Code Engine. So we are currently working on getting Ray natively installable in Code Engine, and then you can just spin up like 1,000 cores or 50 GPUs in 1 minute, and then you can your tune algorithm, and then it gets scaled down to 0. No? It's really cool.
Oh, cool. Do you know? Does Code Engine support GPU instances on IBM Cloud? It will. Okay.
Yeah, it's currently in close to open beta. I think it's open beta. So in around January, we will announce it, and everything is coming. So I know the guys working on it, and
Cool.
By the way, they are all Germans. So Germans, if they promise something, they deliver. So stay tuned for code.
Is that the Bobingham lab?
Excuse me?
Is that the Bobingham?
Böblingen, yeah, it's BÖ, that's the over the 2 dots. Yeah.
Yeah. Okay. Apparently, I'm breaking up a little bit here. Apparently, my connection's going a little bad. So sorry for that, people.
No problem.
Yeah. Okay. Cool. We've got a few more minutes here, Romeo. Is there anything else you wanted to kind of talk about with your with your what you covered in your talk?
Yeah, so I guess there are a couple of things you can continue to work on. So what I have done is I have returned the day index back to the algorithm. So this is something, of course, you won't have in a REST scenario. So what I need to do next, or you or we together, is actually using a transformer network as a policy network. And then, of course, I only included 4 assets. I included the IBM stocks and Volkswagen, it's a German car manufacturer, the Dow Jones, and something else. I think Bitcoin, Bitcoin.
Yeah.
So it would be interesting to have kind of all the stock data, and then also have a higher resolution. No, I have only the daily values. And
right.
Actually, it's not so easy to get second or minute values. You need to pay for it.
Yeah.
So that's one thing. And then, of course, maybe add an NLP model, correlate the news speed with it. And then I think we have something really comparable to what the big guys are doing. So don't be scared of the big guys. Just do it yourself. All the stuff is public and open source. So.
No, exactly. That's why I've been playing around with it, because I've worked on the basis, especially within things like the cryptocurrency markets. They're fairly new markets that possibly due to regulation, a lot of the big players are not even allowed to be trading in. So
that's true. Yeah.
That's I've been sort of having a play around with that, especially with decentralized exchanges and decentralized networks, because there's not the latency. With high frequency trading, obviously you have to be very close to the exchange, and latency is a very significant factor. Whereas if it's a decentralized exchange, nobody is any closer than anybody else. So
it's really democratizing this area, no?
Yeah, indeed.
I think we too should create a startup.
Let's go to startup to it. Yeah. I nearly did, actually. In 2017, I actually registered as a remote citizen of Estonia myself, because I was going to set up. So Estonia has a program that allows you to be a remote citizen of Estonia.
Okay.
And I actually registered for that, because I was going to set up a startup, and I was going to actually set it up in Estonia because of the various ways in which they structure things would actually work very well.
Yeah,
and I did that in
blockchain, for everything there.
Yeah, and I did that in 2017, and that was sort of towards the end of 2017. And I worked on this algorithmic trading stuff. I did a fintech course at Oxford University, and I was actually going to start a startup, and then the whole this was around cryptocurrency. The whole cryptocurrency market crashed at the end of 2017. Start 2018, and hence I was actually looking for a job, and that's why I'm here now at IBM.
No.
If the market hadn't crashed, maybe I would be doing a startup based on algorithmic trading.
Okay, luckily the market crashed for us. No?
Luckily it did, and I'm here, and I've learned so much more about AI and machine learning at IBM. It's been fantastic. So it's great, because there's some great people to talk to.
Yeah, we attract all the nerds now.
Yeah, indeed. So cool. Good. Okay. Well, just looking here to see who we've got up next. I think we've got David up next. Not sure if he's about yet. But Romeo, thank you very much for coming along. Thanks for having a chat with us. So if people want to get in touch with you elsewhere, can they get in touch with you? How do they get in touch with you? What's the best way?
I have a GitHub profile. Just ping me there. It's github.com/RomeoKinzler/me.
Okay.
Find all in, yeah.
Fantastic. Great. Okay. Well, thanks very much, Romeo. And yeah, thanks for coming on the chat.
Thank you.
Okay, so hopefully we've got coming up next, with a bit of luck, we have, just checking my notes here, hopefully we've got David Cardew coming up next here. Oh, great. Lost Algorithms put Romeo's GitHub in the chat there. So that's great. That was great. I really enjoyed that myself personally, as you probably probably noticed there. I've got an interest in algorithmic trading, so that was really great to talk to Romeo. And if you haven't already checked out his talk in the conference, then go along to the conference website and you'll find his talk there on reinforcement learning, on RLlib. So that's great there. So fantastic. Okay, so hopefully we will have David coming up imminently. Aha, we do. David.
Hi. Hey,
hello.
Matt, how are you?
I'm good, thank you. Thank you for joining us.
No problem. Glad to be here.
Cool. So you've just or you've done a talk. People may have seen your talk on stacked machine learning models.
Right.
So do you want to give just a quick sort of overview, because the talks are done on demand, so some people will have seen it, some people may not have seen it. Do you want to just can you give like a 5-minute kind of intro to stacked machine learning models?
Right. Yeah. So the theory behind stacked ensemble models has been around for a long time. It was the seminal paper was actually written in 1992. And essentially what a stacked ensemble model is, it's a series of typical machine learning models that work in parallel and then feed their predictions into what we call a meta model. And that meta model ends up making the predictions. So the kind of intuition behind it is, if you use a set at that first level, if you use a set of models that are not, where the error is not highly correlated, think of you and a bunch of your friends taking a test and all of you getting different ones wrong, and then combining the answers, you'd get a really good score, because what you got wrong, the other people would get right.
Right.
So overall, your error would be diluted. Now, if everyone got the same errors, then the ensembling wouldn't work, obviously, because you'd end up with the exact same score. So that's the general idea, this idea of diluting errors by having these models combine their predictions into another model. And what makes it work is having those first level models as different as possible. And ideally, what we mean by different is that the errors with respect to the training data are not highly correlated. So
right,
back to that crude analogy I gave you, you and your friends all got different ones wrong, which
right.
is the ideal situation. So it's the same idea. So it's been around for a long time, the theory, but where it's really picked up steam recently is because of data science competitions. Right, where it's turned out to be really useful is if you're working on a model, and everyone who's done this has run into this, you've essentially hit a wall. Maybe a good model, you're getting decent results, but you get to a point where you start trying other things to make it better and nothing works. So hence,
so you tried the Titanic, you were working on the Titanic data set in your talk, weren't you? And
right,
and
yeah.
Testing,
I did that as an example, just so people would, if they wanted to try their hand at it after, it would be easy for them to sort of do it in terms of a data science competition sort of environment. So so the one thing that would be helpful for people to know about that particular competition, so the Titanic competition is really just a test bed. It's not a real competition.
Yeah.
So it is organized like a typical Kaggle competition, in the sense that Kaggle gives you some training data with labels, and then they give you some test data without labels, right? And then when you enter, when when you submit an entry, it's scored against that test data set, and you get your results. The problem is that that test data actually has actual passenger names. So the quote unquote labels are really publicly available. So, you know, with a search engine on a computer, it wouldn't be that hard for you to kind of figure out whether the test data, whether the individuals there survived or not. So the reason why I bring that up is if you go to the Kaggle competition, you know, it might be a bit discouraging because you'll see literally dozens and dozens of people.
They all have 100%, don't they?
Scores.
Yeah, I saw that. Yeah.
Scores. No, I'm not. Maybe they're all geniuses and came up with great models, but my bet is more on the
I did wonder that actually. I've done that myself, and I've looked there, and I was like, how did they all get 100%?
Right. Yeah. So I wouldn't. The point is not to be discouraged. I mean, you know, some people, there is a theory, well, it helps your reputation, but I'm not sure if kind of cutting corners and doing some underhanded stuff will actually help your reputation. But just keep that in mind. Other than that, it is like a typical competition, and it is a lot of fun. So I'd encourage anyone to sort of play around with it. It's nice doing something, making some improvements, and then submitting it again, and it gives you a nice message. Congrats, you've improved your score and jumped up, you know, N spots on the leaderboard.
Okay.
So that's actually quite that actually is quite fulfilling. So again, I would encourage anyone who hasn't done that to at least do it with the Titanic.
Yeah, I should have a go myself. I've looked at them, and I've looked at the Titanic one, but I've never actually submitted a score myself on Kaggle. So I should probably have a play around with it and see about that, and see. And one of the things I noticed as well, you said, which was really interesting, I didn't realize, is the stacked, you know, doing the stacked algorithms is actually now supported in scikit-learn, and there's actually a meta model there that you can use, right?
Right. Yeah. So it makes it, because one of the things I point out in the talk when I go through the process, it's not that in terms of implementing it in code, it's pretty difficult, you know.
Right.
But with the scikit-learn, they have two classes: the stacking classifier for classification and the stacking regressor for regression problems. And it's literally one or 2 or 3 lines of code, and you're good to go. So it makes it a lot easier. Sort of really lowered the bar for being able to quickly sort of experiment and try out different things. So one thing I didn't get a chance to talk much about in the talk because of time constraints is that there's a lot of benefit to stacking, but it also adds a lot more complexity. In particular, you have now almost an infinite number of configurations that you can consider. So you can how many levels overall levels you're going to use. I present the very simplest case, which is 2 levels. But I also gave examples of a couple of winning entries in competitions that actually use this approach, and people will be able to see that these are actually a lot more complicated. One of them, for example, is like 3 levels and has like 64 models at the first level. 64, right. And then that gets fed into, I think, like 15 models, and then that gets fed into 2 models, and that gets fed into a single model. So as you can imagine, they just didn't get a sort of a burst of insight and come up with that architecture. It was. I'm sure a lot of blood, sweat, and tears, and trial and error went into that.
I mean, so you're then probably looking at almost like a hyper parameter tuner in order to...
Exactly. So there's in one of the links there is at the end I have some references, and there's a really good blog post by a Kaggler who actually did some automation and was able to enter a fairly tough contest, and with without much sort of tuning, just doing some sort of basic, starting with the idea of building a stacked ensemble and then doing some automation to try different combinations. And he says he was able to get to like 58 on the leaderboard for his first entry without much work at all. So,
Yeah.
and he thought that was he thought that was really amazing. But again, it's one of these things that you have to be sort of careful, because you want to be able to, there's so many different possibilities. You need to come up with a way where you can sort of ferret out the ones that are promising and leave all the other ones behind. Else you could, in theory, could just crank away forever before finding something that actually gave you significant improvement.
Yeah, I mean, that's the first question that comes out when you start with machine learning, isn't it? It's like, well, which algorithm do I use, or which configuration do I use? And the answer always seems to be, well, try them, right?
Right.
It's more of a it's a bit of a art rather than a science in many cases. I mean, obviously, there's a lot of science behind it. There's a lot of people who understand, particular why you would want to use a Gaussian system versus a decision tree versus a neural network, etc. But there's, in a lot of cases, it really does just depend on the data, and you just try them and see which one works. So then with stacked ones, like you say, it's kind of adding them in, but then there's a case of, well, which ones do we add and how many do we add? And somebody's asked actually in the chat here, what factors are used to guesstimate the depth of levels? And like with neural networks, there's kind of various rules of thumb of, well, the number of neurons should be the mean between the number of inputs and number of outputs, or keep adding levels until it stops or whatever.
Right.
So are there any rules of thumb that you've come across for
No,
this?
it's really more trial and error.
Right.
You essentially, I think from what I've seen of people doing this, it's more trial and error. You start, and there is a typical, the typical pattern is that you start off with, let's say you start off with 2 levels, and you may have 5 or 6 models, and then you add a few more, and then you keep getting better results. So you keep iterating, and then you hit a wall where you get to some number n where it's just you're not getting any significant improvement. So then you say, well, let's try adding another layer on top of this. So you're kind of building on top of that. And I think it's sort of that part of it is really in its infancy. I think right now it's just all sort of trial and error. I think people who have done it several times they may have their own kind of rules of thumb. They have a feel for, oh yeah, I saw this before on my last problem. And I try, and this particular adding, another layer seemed to help, so I'll try it here, kind of thing.
You kind of get that impression when you see some of the big deep learning networks, don't you? When you
Right.
see like VGC16 or ResNet or whatever, and it's kind of like, well, we built this block and then we repeated it 16 times or 20 times or whatever. It's like, well, why did you do 20 times and not 21 times? Well, that's what we tried, and that's what seemed to work.
Right.
I'm sure there's like I said, there's obviously a lot of science behind it at some level and maths behind it at some level, but a lot of it must just be, well, we tried it and that seemed to work, and we took one away, it did worse, we added one, it did worse, so we kept this number.
Right, exactly. Just it's a lot of there's a lot of trial, and it makes sense that this would sort of work well in data science competitions, because typically if you're building a model in production, you probably would have some goals about accuracy and so on, and once you hit those, you're not going to spend like the next 3 months trying to eke out a sort of tiny incremental improvement. In fact, one of the things, I'm not sure, maybe some people in the audience may not be aware of this, but the sort of granddaddy of all competitions, the Netflix challenge, they actually ended up not implementing the winner because it turned out to be too complicated. So it was too complex to scale well, and they needed to scale it in the order of billions of recommendations. So what they ended up using was one of the earlier entries that was not as complex, did not perform as well, but performed well enough and had a much simpler architecture.
Right. And
So-
sometimes I've found as well, it's like you can get a certain level of accuracy, which works great,
Right.
but you maybe you want to actually optimize for the least worst case in some regards, right? It's
Right.
like, okay, this is how well it can do, and it can get really accurate on certain results, but actually what you're trying to do is you don't want it to be really bad at certain results as well, right?
Right, exactly. Yeah. You just the whole, yeah, exactly. You want it to, and then there's, especially around classification, there is for a lot of classification problems, there's something let's call a cost matrix.
Right.
So a false positive, the cost of a false positive will be very different from the cost of a false negative. So
Right.
you have to account for that as well.
Yeah, and that depends very much on the scenario. I mean, I mentioned earlier,
Right.
I think it was with one of the previous speakers, talking about, okay, well, what is the impact of me giving this medicine to a patient because the AI said so, and a false positive might have no impact. A false negative might be, well, you didn't give it to somebody who needed it, and they die as a result.
Right.
So the balance is very significant in that case. And you want to favor on false positives rather than false negatives, but it might be that the medication actually has a detrimental effect on well people, and so the balance is very different. So it's very much use case dependent.
Right.
Yeah.
That's exactly right. And then in other spheres, for example, granting credit, for example, there's denying someone who is credit worthy, denying them credit will typically, depending on the scenario, usually cost less than granting credit to someone who is not credit worthy.
Right.
But ideally, you would,
indeed.
in that scenario, you really want to minimize both, right? Because there is if you have the opportunity to lend somebody money who's going to pay you back with interest, and you sort of say no, then it actually does cost you money, but probably not as much as giving the loan to somebody who will probably not pay it back.
Right. So in that case, you probably have a higher level of optimization function that is like optimizing for profitability for the company.
Exactly.
Which will be taking into account the cost of whatever debt recovery or the opportunity cost of not granting somebody a credit, not for them not becoming a customer of yours, and kind of optimizing for that. Okay.
Right. Yeah, and one thing I don't have a chance to get to in the talk as well is this idea of there you have stacked ensembles, and then there's a term that's used called blending, which
Right.
they're typically used interchangeably, but the blending just means combining the results of so it's like a stacked ensemble, but at some point you combine the results. One typical way of doing it is assigning weights. So you may have, at your second to last model level, you may have 3 models, and then they make predictions, and then you can assign weights to those individual predictions. Like
Right.
you may weigh one of them more heavily than others, and then combine all of those to make that your prediction. So that's blending, because essentially you're blending the results. You're not feeding them into another machine learning model. But for the most part, people use the terms interchangeably. So it's not, but there is a distinction.
Yeah. Okay. Oh yeah, there's somebody in here just in the chat just saying, in their experience, it's hard at times to draw the line between finding what works and opening myself up to bias by wanting good results when trying stacked models. So yeah, I guess that's an interesting point actually, because we were talking about with Marguerite about bias. Have you had any kind of sort of experience with looking at maybe how stacked models handle things like biases? Is it less likely that a stacked model is going to perhaps pick up a bias because it's maybe the different component models might even each other out a bit in bias terms?
Right. Yeah. So so in terms of bias, if you talk just in terms of the old sort of bias and in terms of bias, essentially overfitting versus underfitting, right? So
Right.
bias is sort of this this idea of underfitting. So your model is too simplistic. So you're not catching all the sort of intricacies of the training data that lead to particular predictions. So generally speaking, it will dilute bias. So if you have if you have models that only have a little bit of bias, right, and then stacking will actually improve them, because again, the bias error will get, as long as the bias is different from the models, they're totally different models, typically different algorithms and so on. So it can help reduce bias, not by a significant amount, but again, if you're in a situation where your model is fairly good and it's just slightly leaning to being a bit biased, then those types of models work, do well with stacking, because ensembles, because that bias can get diluted. If you start off with models that are really biased, then no, you'll probably get a slight improvement, but not significant.
Yeah.
So it's really, the idea is, there are limits to what stacking can do in terms of improvements. So it's really dependent on the quality of the models that you start off with. But if you have models that are, pretty good and only slightly overfitting or slightly underfitting, then they typically would be good candidates for using a stacked ensemble.
Okay, cool. We've got somebody's asking in the chat actually about in real enterprise production, do we deploy the model from scikit-learn, or do we use an out-the-box ML model from a cloud provider? I don't know. I mean, is there support for stacked models in? I mean, Auto AI, for example, I presume doesn't yet support stacked models.
Yeah, it's it's kind of so really you have the way the deployment works. I can speak, for example, I can speak about Watson Machine Learning, which is IBM's machine learning service. So if you implement it in Scikit using the stacking classifier, you can actually deploy it very easily into Watson Machine Learning, because the Watson Machine Learning, it just looks like another Scikit model. It's a class, and it has certain interfaces that it expects, and those interfaces are all there, so it will work. If you sort of build it yourself, where you kind of create the models and feed the data into one level, and then aggregate the data and then feed it to another level and so on, then it really depends on the provider. Does it, do they give you, for example, can you, just some random Keras or TensorFlow model that you built, that you custom coded? If they support that kind of deployment, then you should be able to do it. Cool. So it's really, but typically they won't say we specifically support stacked ensemble models. It'll be more, we support Scikit, we support Keras, we support TensorFlow, and so on. And so, but again, I really like Scikit, because it saves you tons of time, and they do all the work for you. So I mean, it's really, and there's no way, and it's not like you could say, well, I could do it better. No, because it's essentially, it's the same. You might be able to, do slightly better in terms of the efficiency of the code, but the output, the result will be the same.
Yeah, and you get all of the pre-processors and all of that side of things for cleaning up the data. Just makes it so much easier. In terms of actually deploying, if people are interested, in the chat on the stream about deploying, the next speaker coming up after David is Sriram Raghavan, who's the vice president of IBM Research AI, and he did a talk on scaling enterprise AI. So that's going to be coming up shortly. We'll have a chat with him about his talk. So there'll be some more about kind of deployment side of things, probably be able to answer some questions about some of the deployment stuff as well in there. Okay. Just looking to see what other questions we've got, are there any specific domains that would benefit more from stacked models? Can you think of?
Yeah, so I think they tend to be used more outside the domain of deep learning. So it's typically your more, things like classification and regression problems that typically don't benefit from building a really deep, neural network or CNN. Those tend to work better with benefit most from stacked ensembling, because with deep learning you can you already have these, you can essentially do the same thing by just constructing a network, an appropriate network, and applying different the different tuning knobs you have at each level and so on. So you don't really need the stacked ensemble models don't typically give you much in that realm, but there are I've seen cases where people have used neural networks as component models in a stacked ensemble, but then they've combined them with other types of algorithms, to decision trees and so on.
And scikit-learn gives you a nice scikit-learn like interface into neural networks as well, so it's very easy to add that in. And I guess from like deep learning networks perspective, if you look at, I can't remember which it is, maybe I think it's ResNet, I think, actually has multiple parallel blocks at each level. So it has like a 1x3 convolution, a 1x5, and a 1x7, I can't, something like that, I think. So I guess it already has that concept built in, that it kind of takes these parallel convolutional blocks and then joins them together at each level. So I guess it already does that kind of similar approach. Right.
Yeah, I mean that's kind of So I would say your standard, your classification regression are the two types of problems that seem to be used most with stacked ensembles.
Cool. Okay.
And one of the, I guess one thing I would add that I've seen a lot in practice is that we do talk about this idea of those models should be as different as possible, but in lots of implementations, they use the same model multiple times. So they'll use like logistic regression, and then so they'll have model 1, model 2, and they're all up to model n. They're all logistic regression. But what's happening is that they have very different hyperparameters, and they're purposely done that way to have the idea is to have a very different error profile with respect to the training data. So there's no rule that says the models all have to be different types of models. They can be the same type of model with just very different hyperparameters. Control.
I guess that must have been the case, because when you earlier said that there was whatever 100 or 300, I can't remember what you said. Models sometimes that people use in the real world when they do this. Obviously, there's not that many algorithms, so they must be tuned in different ways. Okay, cool. Well, is there anything else you wanted to kind of cover? Anything else here? I'm just looking to see if there's any other. Actually, we've got one more question here. Maybe talk about generative adversarial networks. In the case of conditional general adversarial networks, learning traits from a relative Z-space vectors, would stacked models help reduce the bias? Influencing generator decisions has proven to be difficult in certain implementations. Right. So they're talking about GANs, generative adversarial networks, and can you use stacked? I guess a stacked classifier maybe in the discriminator, I think, or are they talking about the generator? Maybe in the generator.
In the generator, I'm not aware of anyone. I would suggest searching that up because I personally haven't seen where someone has done that, but I'm pretty that doesn't mean it hasn't been tried. I would sort of definitely do a search to see if anyone has has done that, because this technique is relatively new. I mean, it's been around for a long time, but it hasn't been used. It's really been sort of driven, again, by data science competitions.
Right, and I guess if it's using CNNs in most cases for GAN, you're using CNNs. I mean, if it's in the image domain, at least you're using CNNs.
Right.
So there's probably not much benefit for this. But if you're using other structured data instead, then maybe there is.
Right, there might be, but yeah, it's I haven't seen it, but I would definitely, you know, the people are writing papers every day with different sort of trying different things with stacked ensembles. So I wouldn't be surprised if at some point you get this kind of hybrid of deep learning and stacking sort of working together.
Okay, David. Well, thanks ever so much for coming on. So yeah, we've got Sriram coming up next. So thanks a lot, David. And is there how best for people to get a hold of or to have a chat?
Well, I could put my email address in the chat. I think that would be
great. Brilliant. Okay, thanks a lot, and we'll put that in the Twitch chat as well for the public as well. So if they want to kind of come along there, so brilliant. Okay. Well, thanks very much, David.
Thank you. Cool. Take care. Bye.
Hello, Sriram.
Hey, Matt. How are you?
Hello. I'm good, thank you. How are you doing?
Doing well. Doing well.
Cool. So you did a talk on scaling enterprise AI, right? So some of the people will have seen your talk because the talks are on demand. Some people may have seen it, some people may not have seen it yet. Do you want to give a quick sort of overview of the talk, a quick sort of 5-minute, if you're able to give a quick
sure
about that?
Absolutely, happy to do that. So the talk really was, so maybe a little bit about myself, right? So
yeah.
Responsible for running our AI strategy at IBM Research. So, IBM Research is we have labs in 13 countries, in 19 different locations. We have a global footprint. We work very closely in advanced technology to deliver innovations to sort of every part of IBM. A lot of it through our software offerings in data and AI portfolio, but others as well. And what I shared in that talk was obviously a brief perspective on what IBM Research is doing around this notion of scaling and advancing AI. And the central thesis is there's a lot that's going on in terms of fundamental advancements in AI, new techniques, new algorithms, new libraries, new approaches. But then there is also this piece of how do I take all that innovation and scale it to the enterprise so that it's not about one little model doing something, but I have AI models and AI infusion across the enterprise. And what are the challenges that we see and what innovation research is bringing to that space? And sort of I anchored that presentation really around 3 axes of work. One is around IBM Research's work in natural language processing. Language is fundamental as if you will, the language of business, and understanding language deeply is central to a lot of use cases. So what are we doing in that space? The second is around the automation of AI itself, right? We know that the data science process begins with data. A lot of work goes on and the cleansing and the preparation and the quality and the manipulation of data. Then you get to the data science process itself where you build models. And then there is the piece of actually deploying the models into an application and the entire lifecycle management. Right. And I think many in this audience are either data science developers or data science themselves, and they know that we're sort of, if you will, in the assembly language era of this. Lots of tools, lots of choices, but there is still a lot of groundwork that human beings have to do. And the question is, how do we drive automation, right? How do we drive automation into the data to AI lifecycle? And what are some of the innovations that we're doing? Then the third pillar is obviously this very rich and complex topic of trustworthy AI, which has many, many dimensions to it. There is the algorithmic dimension of new techniques, new approaches, and sort of what IBM Research is doing in that space. Right. But then there is the element of the broader policy, the ethics of AI, and I painted a picture of some of the work that we've been doing, the open source toolkits that we've been creating from IBM Research, and how they are available for data scientists and developers across the world to use. And hopefully we look to build a community around it, because now they are part of the Linux Foundation for AI. So that was really just a run through, if you will, of language automation and trust, and few examples of sort of research work in that space.
Okay, cool. Right, yes. I mean, you say, yeah, we're in the kind of the assembly language bit, and we're just about. And I remember seeing you've got a great slide in your presentation in which you kind of have, this is the whole kind of landscape, and we've just got this little tiny bit here.
Yeah.
You know, and that I think really kind of shows it. You know, people sort of doing stuff with AI, and it's like, okay, well, we've got the predictions working now. Now, what do we do? How do we deal with the
and how do we do that faster, cheaper? I think that was the point, that a lot of the automation focus. There's lots going on in the auto ML itself, right? Better parameter optimization, automated, but really the overall data science process has a lot before this and a lot after this. And how do we drive automation in those steps?
Right. Okay. Cool. Okay. So yeah, I'm looking to see. Okay, we've got a link to the keynotes in the chat there for you. Okay. So where do you? I mean. Yes, we're developing sort of new, sort of tools to kind of deal with this and to process this.
Mm-hmm.
Where do you see things in, I don't know, say 5 years time with this kind of field?
So I think we're going to see a couple of things, right? Obviously, I think it's very clear now that people are going to look at automation of AI more holistically, right? So it's going to definitely go. So if you look at that picture that I was showing, which talked about all the way from the data to the deployment, I think as AI infusion goes more into the enterprise, the focus is going to expand from, do I have the best model with the right accuracy metrics, into all of those other considerations that going to make AI real. Do I have the right model management? Do I have right model ops hooked into my DevOps process? Do I have, for example, the right data quality and data repositories that allow me to scale? Every time I want to update or build a new model, if my data engineering is going to take weeks and hours, then it doesn't matter how much automation I have downstream.
Right.
All my time doing that, right? So in fact, that's why in the talk, I talked a lot about some of the work we are doing around data quality. And AI has, so I think that's going to be an increasing focus. Data quality is an old problem. Like anybody who's done data management has worries about data quality, but AI places an additional demand. You could have a perfectly beautiful data set, complete, all rows, everything well formatted, but then that data could be useless for a particular AI problem. If you're looking to build a classifier and it has 9 billion rows of one class and then 2 rows of another class, it's very hard to build a class, right? As an example. So how do we extend data quality? And I think that's going to be, I think the tools are going to get better. The second trend definitely is there's going to be this intersection of the data science process and the broader distributed systems. Today, scaling AI ML suddenly requires you as a data scientist to have to solve a lot of distributed systems problems, which you don't want to solve. You just want the infra to sort of take care of it. I want to continue to do my data science in Bulbera. Don't help me worry about data movement and caching and frame. So I think you're going to see lots of innovation in new middleware at the intersection of data science and cluster computing and the next evolution, if you will, of Hadoop, Spark, etc., and how that's going to intersect with the data landscape. And then from a fundamental, more sort of wearing my researcher scientific hat, and I think I briefly mentioned that in the talk too, we see the emergence of sort of this area of AI that we broadly call neurosymbolic AI, which is the coming together of the more modern neural data-driven approaches, right? Deep learning networks, statistical techniques, highly data-driven techniques, with symbolic techniques for knowledge representation and reasoning and logic. We believe that we're definitely going to see more melding and infusion of ideas, because there are a set of problems that you cannot solve just with one or the other. And you're going to have to bring together the best of data-driven learning and symbolic AI. And symbolic AI was originally the AI when AI as a word was coined. And we're going to see, I think, that's our perspective on some emerging trends.
Okay, cool. And there's a question here in the chat. I've noticed that Watson places a similar focus on work package management as we do internally. So that's internally, I presume, how important do you feel the tooling for these steps before an actual model is I presume they mean constructed, are in the future. What an actual model is in the future.
Matt, I think I think you broke up a little bit. Is that a way that I can see the question myself?
Okay, I think I'm slightly trying to paraphrase the question here, because I'm not entirely sure what they're asking here. But how is the they've noticed that Watson places a similar focus on work package management, kind of before the actual model is generated. So it's kind of like I guess they're asking about the kind of the governance. They say here about the data set governance and how that all comes first before you get to the training step.
Yes. So I think you're right that across our Watson tool chain, whether it's Studio, machine learning, or OpenScale, which is the build, the run, and the manage, we're going to see that tool chain connected more and more to sort of fundamental capabilities around data governance itself. And data and models are all going to become managed assets. So something like Watson Knowledge Catalog, which is our data and AI platform approach to managing those assets, already embraces both data assets and models. And so as you go through the model development process across this tool chain, the Watson Knowledge Catalog becomes a repository in which the progress of that work package, the way they talked about, is going to be tracked. And that's what's going to give you governance and lineage. And I think that AI governance will intersect sort of the other topic that we briefly touched upon, which is trustworthy AI. Enterprises are not going to deploy models unless there is, and definitely not in regulated industries, unless the governance around managing, monitoring, testing, validation of models is recorded, certified, they have a robust process associated with it. And so we see that convergence between the data science tool chain and the data governance tool chain sort of coming together, definitely.
Right. Yeah, that's where you talk about in your keynote about trustworthy AI and the whole sort of role of that kind of going forward.
Yeah. The reason we have taken an open approach, Matt, is also there's not going to be one fairness algorithm or one explainability technique to rule the world.
Right.
You're going to need lots of techniques for lots of situations, different types of algorithms, different types of data, and different types of explanations. You developed a model. The explanation you want to improve the model is not the explanation if I'm just a customer who was given a decision based on your model. I don't care about your parameters. I just want to know what I need to do to change the decision if I was denied a loan. You care about improving the model overall, right? So the explanations are different. And so we believe that you're going to see a rich variety of techniques. And then data science teams will now be left with the problem of, how do I pick the right technique for my use case? And that's sort of going to become, I think, the next level of interesting innovation.
Yeah. Cool. Question here. Oh, that's a question more for the mods there about the actual talks themselves rather than to yourself. So, there is one here. Are there any challenges you foresee on the path forward for AI on the enterprise level?
I think the challenges are not new. It's the same challenges we've been talking about, which is getting two things right: the data foundation and the associated organizational transformation. AI isn't going to succeed in isolation, right? Because AI is not one of those technologies like you buy this, put it in there, and it is going to infuse into the enterprise, right? So for that, you're going to have to continue to make progress on establishing the data foundation. I know we in IBM talk about the AI ladder, and that's an approach to get that foundation right. But the other side, and which is interesting, our talk about governance, is the organizational process, because we often think in data science of AI model as the end entity, but really the AI model sits inside a broader application and has to be managed as the life cycle of the application. So how does the organization transform itself and its IT delivery process to incorporate AI, I think will be the second element of success. And organizations that get these two, their personal transformation and the data foundation right, I think are going to move faster than ones that don't.
Cool. Okay. And just one quick last thing, because it is a really fun thing. Project Debater. What's next to Project Debater? Because you mentioned that in your keynote as well, and that's a really interesting thing.
Yeah. So as you know, in research we pick on grand challenge problems just to push the boundary of technology. And And so in research, 6 years back now, we decided let's build a machine that's going to debate human beings. And the intent was not that the act of building a machine that's going to debate is necessarily, may or may not be useful, but we knew that trying to do that would really push the state of the art of NLP. And that's really what happened, right? So in 2019, we actually had a public debate with a human debater, and we showed how the system is actually able to in real time, because it really forces you to understand language, process language, generate language. It sort of touches on every aspect. You have to summarize, you have to relate, you have to correlate. And what we're now doing is taking those underlying language innovations and making it part of the IBM portfolio. So the innovations from Debater are going into Assistant, into Discovery, the natural language APIs. And we constantly are also now surfacing interesting applications. So I talked in my keynote about how the IBM Events team used Debater APIs to build an interesting use case in the US Open website. And we're partnering with Bloomberg around assisting a human debate with data-driven inputs that Debater provides on the same topic. And this very interesting idea of key point analysis, taking complex unstructured text and being able to elicit something of these are the key points. This is how many times this point was made. Something turning into something quantitative is very, very powerful when you're dealing with surveys and feedback and unstructured forms of it. So we expect to continue to see interesting innovations, and we are still not complete with the process of harvesting all the innovations from Debater, putting it into the IBM product. So expect a steady stream of sort of more such innovations making their way into the IBM portfolio.
Okay, cool. Okay, well, thanks very much for coming on the chat, Saurabh. It was really great, and the keynote, if people haven't seen it, the keynote is available on demand on the conference site. So go ahead and watch it. There's lots of great stuff in there about that. And yeah, so thanks very much for coming on the chat.
Yeah, pleasure to be here. Okay.
So great, thanks a lot then. Right, okay. I'm not sure if we've got the next person coming up yet, so we don't have Ruchi yet. I think what we will do then, if there's nobody here yet, well, we'll see if anybody else is around. If any of the other developer advocates are around, want to pop on and have a chat, then we can do. Or if there's any general questions in the Slack channel, then not Slack channel, sorry. Or in the Slack channel or on Twitch, then by all means put them on there. In the meantime, Mike, if we have any of the, I don't know if we've got any of the videos, if we haven't got anybody else coming up for the moment, then I guess we can put one of the videos on and kind of go for there for a little bit. Just looking to see if there's any topics in the chat. Yeah, okay, so we'll be right back shortly, and we'll either be back with Ruchi Puri talking about his talk on will AI software, or if not, we'll be back and made a little bit longer with I'll be handing over to my colleague Sean, who'll be taking on the next lot of talks. So yeah, so we'll be right back in a minute. Go and get yourself a drink or a snack, and we'll be back shortly. Thanks very much.
Hello, everybody. I'm Sean Tracy, a developer advocate for IBM, and I'm joined here by DBS. Going for the abbreviations there. How are you doing?
Hey, not bad, Sean. How are you?
Yeah, ticking along. You know, lockdown 2 is well underway, but I've been doing that for the last 8 months, so I'm equipped. I'm prepared. I've even learned to cook. How about you?
Yeah, more time to code, less time to commute, so it's all good.
Yeah, productivity through the roof, right?
Yeah.
And where in the world are you today?
Currently, I'm in Knoxville in Tennessee.
Oh, wonderful, wonderful. Well, I must say, it's quite impressive, the latency we have here in the system. It's quite low, given the fact there's an ocean between you and I.
Yeah.
Yeah. So thanks for joining us.
All right.
For the people who are joining us just now, having followed on from the talk that you all gave, you and your colleagues, with Justin, why don't you give us a little background about yourself and just how you came to be doing the media, analyzing media impact with AI.
Sure, yeah. So my name's DBS, formerly David Bartram Shaw. I look after data science for Wunderman Thompson Data in North America. And some of you might know Wunderman Thompson. A lot more of you will know WPP. Wunderman Thompson is a creative marketing media management company. And I work for the data management side of the business. So we own, manage, compile data on pretty much all people across the US. So about 270 million marketable adults. And what my team does is we use that data to create new assets, to create machine learning algorithms and applications that can sit on top of our clients' data alongside our data and help them to, target the right customers, understand how customers behave, and ultimately to inform communications and provide an uptick in a business. In particular, reference to this chat that we gave on media uplift and the work we did with Wavemaker, who is another WPP agency. It was the first time we really collaborated with an external agency. So we're sister agencies, we're all under the WPP umbrella, but we've been building this asset, this platform for the last 18 months for us internally. It's our central data science environment. And now we want to open that to other partners in the WPP umbrella. So this was our first effort at doing that. And so we worked with Wavemaker, who are, media experts, on one of their key challenges, which is predicting media sales for their clients, in an alternative approach to kind of the MMM models that they were using historically. So we brought in our assets on consumers across the US, as well as consumer data. We've also got things like point of interest data, geographical data, census data, kind of county level data. And we used all of that data in this project to help them predict, media sales. And it kind of piggybacks off of the COVID dashboard that we built as a group. Our response to COVID was, let's try and predict when the economy is gonna reopen. Try and help businesses to understand the impact of the economy, not just the impact of the virus. And we used that as an input actually to the predictors of spend based on media activity.
That's wonderful. It's interesting. I've got many questions based off of that alone. So let's work through them in the order that I thought of them. So you mentioned that this is the first time your team worked with a sister agency to create the solution that you put together. Is this something that your team is particularly focused on, like the use of AI and data to create these insights into the impactfulness of certain media campaigns, or is this something that you've all kind of been experimenting with in recent kind of months and years and decided that you could pool your resources together to have a more kind of effective solution?
So typically what Wunderman Thompson Data does is focuses more on kind of targetable media like email, direct mail, you know, that kind of identifiable down to an individual, you know, PII level. So, you know, we work a lot with clients to optimize CRM and things like this. Wavemaker, on the other hand, play way more in the media space. So, you know, so they're kind of in this cookie world, in this often non-identifiable world. So it's kind of two sides of the coin. And what we wanted to do is kind of bring in our data and create it on levels that can help them to target media and understand, you know, media impact and performance. So we brought their data in, which was on a media level, and we brought our data in, which was on an individual and geographic level. And we merged those two together to solve their business problem using, you know, using our data as kind of an extra firepower to the approach.
Right. It's interesting. It's often said that an AI is only as good as the data that's provided. And it sounds like you've been dealing with all kinds of data points from all different places and peoples and formats. Is there a lot of work that has to go into massaging these things to work in the way you expect? And I mean, I know the answer to that one already, but what I'm curious about is, in the course of this project, were there any kind of got-yous, data formats that you hadn't seen before, or perhaps unexpected things that happened because the data hadn't been worked properly? Or was it all smooth sailing because you've done this before and you've got this down to a T?
I mean, we've tackled a lot of this before. You know, we've got so many data engineering pipelines within our business. We you know, curate sources from many different places, and so data engineering is a core part of what we do as a business. And you know, as you know, as you say, the algorithms are only as good as the data that's fed into them. And in most cases in our business, we go right down to the SKU level, for example, and it's about then transforming that SKU level data into features that make predictable inputs and many different forms of the same feature. For this particular project, something we really focused on was time-based features, especially for media. You know, that you've kind of got this impact of time. So in our business, it's not something we often do. We try and predict the now. You know, like is someone going to buy? Is someone going to, you know, perform an action right now? But what we had to do was kind of tackle pre-COVID, post-COVID. You know, it had a massive impact on every sector, but for the sector that we were working in especially. So we had to create these time-based features that took that into account. So that's why I mentioned earlier, we looked at the COVID recovery index and a few other features that kind of try to encapsulate that. But you know, we learned from Wavemaker in the way that they use their time-based features, especially across media spend or previous media activity, and create these kind of new time-based features that can then be fed in to predict the future. So we're always learning. I think we can always do better, and there's always more features we can create. I think the other side of it was we had too many features, and so you know, you've got that balance of how long your models take to run and how much data you really want to feed the models on to produce the end result. And fortunately for us, it wasn't something that we had to, you know, it didn't have to train on demand. We get sales plans, you know, on an infrequent basis. So we don't really have to worry about how quickly the algorithm can turn around. So, you know, we didn't have to solve that problem, but it is something that for other parts of our business, having lightweight models that will run quickly is a key concern. So.
Absolutely. It's interesting that you mentioned that you had too much data to input at some points. So obviously you've removed certain features and facets to try and get your algorithm to predict what, you know, is actually a representative model of the real world. Was that driven largely by a sense of intuition, or did you have a more data-driven approach? So I imagine something like the simultaneous training of different models of different features to see what kind of result you get. Or is it very much like I, as a person, think that if I move this feature, it'll depend more heavily on these other features, and thus we'll get the result we're expecting for the input that we're giving?
It wasn't intuition. I wish we had the time to sit down and inspect. I think intuition comes in when you're carving and creating new features more so than selecting them. There's programmatic ways that you can test features, feature selection, feature reduction steps within the algorithm pipeline. But I really do think that intuition does play a large role in the curation of features. Like, for example, the point of interest data that we have, like every location of every store, for example, in many different sectors across the US, how do you create that into features that can be predictable based on where someone lives, for example? And then how do you transform those into features you can input into your algorithms? That's the type of intuition, where intuition is important. But pretty much everything we do is programmatic in terms of selecting them. Obviously, you then got, once you've trained your model and you're evaluating whether it makes sense, again, intuition comes in there too.
Of course. Oh, excuse me. Yeah. Now, my next question is for our audience, for the developers amongst our crowd. Can you tell us anything about the kind of stack that you use and why you've chosen to do it that way? Are you using particular frameworks or a combination of them, or different kind of cloud computing platforms, locally training them even?
Yeah. So we use, as I mentioned on the talk, we use Cloud Pak for Data as our central data science collaborative environment. And for those that haven't used it before, that may have used something like Databricks, it's very similar, but I think it's a bit more flexible and maybe less reliant upon Spark. But even though a lot of our algorithms we run are in Spark. So we've got a couple of different clusters, and we're also testing Cloud Pak as a service now, which is a managed model. So my team don't have to deal with the kind of OpenShift backend pod management. But the main stacks that we run are on AWS and IBM Cloud. And to run big models, we've got this fixed amount of compute that the platform runs on. And within that platform, you can create environments and your team can build models. It could be an elastic environment with a certain amount of, with a non-defined amount of memory and compute, or it can be a fixed amount of memory and compute. But for our large models, we've kind of got this external elastic compute process where we spin up an external cluster. We run our big algorithms. Let's say we're training on 20,000 features and we have to score on 260 million rows, then we don't want to do that on the cluster that the platform's running on, because we'll overload it. So we use external compute, and we've got pipelines that spin up and spin down those clusters automatically. And so our users don't have to deal with that problem. We deal with that for them, and we spent a lot of time optimizing the Spark configurations across those clusters to make sure they run really efficiently. So that's how we kind of deal with our big jobs, and that took a lot of work to get to that place, I think. And then for deployment of models, CPD is really nice because you can expose your notebooks or scripts as a job, which then end up as an endpoint, a REST API call, which can then be activated through other applications in your business. And so, in the olden days, your time to deployment might have been, quite long, and you'd have to bring the engineering team in to maybe work with a data scientist to publish or deploy that model. We've now started to change that, and now the data scientists are able to deploy their own models much quicker without necessarily increasing the span of their skill set too much through this approach. So the deployment has become much quicker within our business without necessarily drastically changing the skill set that sits across the data science and engineering group.
I think that leads us to a fascinating view on the world. If we look at where we were 10 years ago, we started to see the introduction of speech to text services, for example, in things like Apple's Siri and of course Watson APIs and whatnot. Would you, and now AI is everywhere, from helping you choose the food that you eat to sometimes driving cars to helping ships navigate the ocean without anyone on board. Would you say there's been a single tool that has enabled that explosion, or is it more just the sheer raw power of raw availability of the raw power of computing now in like cloud infrastructure, for example, being able to access the computational time to do these sort of things? That's what's enabled the push into AI in our everyday lives.
Yeah, it's hard to say that there's a single tool that's done it. I would probably say it's the community that's done it, and it's driven by open source. And obviously, big tech companies, especially, and small tech companies that are maybe more in the fast-moving, innovative space, have taken these things and wrapped them up, and they've become tools that do enable companies to move much more quickly. But I think that's a product of the collaborative environment that we all work in, and the energy and the sort of snowball impact of the open source environment community. So, and none of this is possible without the compute. So, accessibility of that compute, it still is costly. I mean, everyone says the cloud is cheaper, but it's not if you don't configure it right. I mean, we saw that when we first moved our modeling across to the cloud. It was costing us thousands of dollars to run models, and that's not, we couldn't run our business like that. So we had to spend a large amount of time and resource to optimize those models so they were cost efficient. But it's only cheap if you use it correctly, which is why which is why all of these tools that help you to do that correctly are now coming into play, I think, and it kind of the balance between the technical skill set and the tools that can help you get there quicker. It's a fine balance, I think, and it depends if your team is comprised of very technical guys versus client focused, revenue focused, deployment focused, which side of that coin you go for. Yeah,
I think that ties in nicely to something you mentioned before, which is the amount of work that has to go into setting these things up in the first place. And now that's become easier to both deploy and to expose to your colleagues in other parts of the business so that they may get the benefit of it too. Does with each project, obviously each one is bespoke and unique depending on the needs of the client or the job that's being done. And of course you all learn something from that process each time. But does it become easier to do when you start a new project, having experimental lasting? Do things get carried over now, or do you start clean slate and then build anew as you did in the previous project?
I think it depends on your approach. If you approach it correctly, if you code it in the right way, if you have that in mind, then it can absolutely. I mean, you're always going to learn things, and within people knowledge, that will get passed over. But more importantly, it's about how you wrap up your code. And what we're trying to do now is create applications that can be repeatable. Like the project that we had the conference on. We've done that once. We've proved it works. Now we're wrapping it up into an application that can be used over and over for many different clients across our business and our partners. So. But it does require a certain way of coding and documentation. We sometimes we hate that word, but it's really important to store those learnings so that people can pick up and run, as opposed to pick up and spend hours going through what the hell you've done. So I think it's about approach and it's a culture. But when those people start benefiting from the hard work that they've put in to wrap their code up and turn it into an application, as opposed to, the reward is evident.
Yeah, it's interesting. I've always believed that documentation is king, because without it, we've all had to do a job and we've had to look at things like, what's going on here? What is this thing? What is this? It's just a single letter variable. Why is it there? Yeah. And with neural networks, we have structures that are the way that they are because they're effective, but no explanation as to why without that documentation, right? Would you, for our viewers, recommend any particular bountiful treasure trove of documentation, be it a project or any kind of book or reading or YouTube series, perhaps, that they can use to kind of get a sense of these sort of things and how they might start building these things if they've not done it before?
I don't know, to be honest. I mean, most of what I find is not one book or one source, but it's it's a group of people chatting online. So I'll definitely share some links afterwards of some people more than necessarily books. But I think the key is to tap into a community of people that you can learn from. I mean, we're fortunate. We've got a big group of hundreds of people across our business, and even wider across WPP, who are all energized by what we're learning and how we're solving problems better. You think of WPP and you don't think necessarily of a technology company. I mean, we weren't historically, but we have to become one. So you've got a group of people within the business who just want to do things better, and so we built this community of people up, and people who can look outwards as well as inwards. So you've got external communities that we're all part of outside of WPP, across the open source community. So I think just people and keeping your eyes open. It's one of those fields where you have to keep reading, you have to keep learning, otherwise you stagnate. And so, it's hard to give you one source to read, but I'll pull together some links and share them in the chat.
I'll admit, most of what I've learned from neural networks has come from Stack Overflow and Wikipedia articles. It's a smorgasbord of knowledge. But again, 15, 20 years ago, we wouldn't have had that. And I think the thing that fascinates me the most is a lot of the things that we're experimenting with today and applying today were things that were conceived of in the 60s, 70s, and 80s, and even before that. So it's just now that information is out there, and the computational power and the tooling is there to enable us to do it, that we've had this ability to go and tinker on one's laptop, and then in this kind of high charged environment like WPP, where you've made these magnificent models that do all these fantastic things.
Yeah. It's funny. I was chatting to one of my guys the other day about what's important nowadays, and you mentioned neural networks, for example, and there's so many complex models out there. What we've actually found is that people ignore the rudimentary, fundamental statistics behind, how the data looks, your distributions, for example, or how to deal with outliers, or these simple things that we all learned back in our university degrees and years ago. They just get overlooked, and we get young kids coming in all the time. They can code like hell, fantastic, they're super, but they just don't pay attention to what actually makes a big difference. And we've seen, doesn't matter how good your algorithm is, if you treat the data correctly and you think about the data and the distribution it has, and there's so many steps you can take, so many things you can do to that data to prepare it well for an algorithm. If you discard all of that and stick it into a great algorithm, you will not get a great result. And it's one of the things that we've had so many great improvements by just going back to the fundamentals of what are you feeding into your algorithms, that I would say do not overlook. I mean, you can learn neural nets all you want, but there are fundamental things about data that you should always be aware of, and it gets overlooked. I find it so frustrating when I interview guys and they just don't care as well. Like, you have to care about statistics and the data. So there's kind of a balance between how quickly we run and how we equipped ourselves for the race, I guess.
That's the thing. I think you're onto something there. With all these kind of wonderful, fanciful, interesting things we have to play with now. When you have a hammer, everything can become a nail. Where perhaps there's a more precise tool that can get you the result you want much quicker in a much sharper sort of way. And again, statistics is key to that. I was very fortunate then in my university degree, we did a lot of computer vision processing, which back in 2009 was very much edge detection and finding patterns in that kind of thing. So I had exposure to those kind of ways of doing things before I got to neural networks. And surprisingly, years later, when I thought about some of the solutions that had come, I was like, oh, that's actually kind of analogous to what a neural network does. Like I've done this without realizing it like 10 years ago, which is kind of crazy. So yeah, I think that's a very good point you made there. My next question, I think we have a half an hour, right? So
yep, 7 minutes.
One or two more. So I think my question is to you and about your personal journey. When you studied at university, graduated, and got into the world of development, did you see yourself doing this kind of work? Or was it like the goal to be building these kind of models in this kind of space, or is it something that as the years have gone by, you found more kind of use for it, and you found the role that's taking you there?
I actually started in what I'd call insight analytics.
Okay.
So
statistics then.
Yeah, but it's more about, you know, how you inform the business, how you pull out insights and inform a business, and so, you know, I did some models, but I didn't start in the technical space. I did a very technical degree, but then I moved into kind of the business side. So I was more of an analyst to begin with, and then I saw this big gap in the businesses I worked in for the need for technical development and more advanced models, you know, models that run faster at scale. And then over time, I moved into this space where I kind of found more value for myself across businesses I worked in. There were less people that could code well and talk well, you know.
Right.
And so I became, you know, more technical, but at the same time, I had that kind of background where I could really think about the impact of what I was doing, and so I kind of morphed into this, you know, very, very technical role, but with a background in what does it mean, how does it matter, and how do you take it out to the business. So I can sell things in quite well now, but for me, the value is in being able to scale what you do. You know, we've got many people that can build a one-off model and make it really good. But then once it's done, it sits there and it never reaches its full potential unless you can truly scale it or repeat it and consistently run it over time and make sure you put the right things in place to ensure that the degradation doesn't drop, and that, you know, it's constantly retraining and it can be served in real time into an application. And so it becomes this, and it starts as an idea, statistics, you know, a model, and it becomes, you know, software, it becomes an application. And so over time, my focus has moved and shifted to scale. And, you know, it recently, in the last couple of years, went from just data science to data science and data engineering, like what you talked about earlier. Like the data that you feed into your algorithms is arguably more important than the algorithms themselves. And in the past, in a couple of businesses I worked in, there was this kind of separation between analysts and data science and IT, right? And you've got IT over here that manage infrastructure, and they kind of, they owned the cloud and they owned the data. And then you've got the users, the consumers of the data over here. And there's often this wall between them. And I've seen it with many of the clients I've worked with. And so smash that wall down and integrate those two teams. And that's what we've done. And so now having the ownership of the data as well as the ownership of the consumption of that data means that, you know, you get the best out of it. So I also think with auto AI and all of these automatic machine learning frameworks that have been built, which are fantastic, that the shift of focus is changing to the data. So now, like, you know, and I think auto AI will continue. And as I said earlier, it needs to consider more the data inputs, the distributions. I think there's a way to improve them, many ways to improve them. But I think the shift of focus will become, what is the data and how do I extract features better? You know, so auto feature extraction, for example, but that only goes so far. It's infinite how many different ways you can extract features. So that will continue to grow. And I think that the value of technologists in this space will be, how do you pull it all together? How do you use the right tools in the right place? It might not be developing the code yourself, unfortunately. For some of us who love developing code, I think it might, I think it might just become being able to hook things up that you might not have built yourself, but it's using the right tool in the right place. And so it's kind of just like spanning, this focus is spanning. And so, but I think it's about, scale and productionization of data science approaches that have the impact across businesses. So.
Fair enough. I think that's pretty much our time. One last question. What are you most excited for in AI or data science next, in the next, say, 5 years?
I am most excited for, I think, the next big explosion of compute power. I think the real, we say it's great, but it's got a long way to go, I think. Cool. So I don't know what that's going to be yet. There's many different things, and I think you as IBM are working on a few things yourself, which are interesting. But I'm interested to see where the next big explosion comes from, and from a cost perspective as well. How do we keep driving those costs down? Because as I said earlier, they do blow up. So yeah,
we've all had it happen to us, even me. And I work at the cloud company. So, yeah. Well, thanks again for your time, Dave, DPS, whichever you prefer. It's been a real pleasure to speak to you. Thanks for your talk earlier on as well. And thanks for coming along to join me and speak with me and add some more information for our viewers today.
No worries. Good to chat.
Likewise.
Take care.
And you. Stay well. Hello, everybody. How are we doing today?
Hi, Sean.
Hello, hello, hello.
Very good. How are you?
I'm very well, thank you. It's nighttime here in sunny London. Well, not sunny London, once sunny London, which, despite its reputation, it's a lovely city for the weather sometimes. You get the odd day here and there where it's not just raining cats and dogs. Where in the world are we all today?
Colorado. It's snowing here.
Nice.
I'm in Cairo. Still nighttime for me too.
Austin, Texas.
So we've got people from quite a wide span of the world right there. So that's very kind of cool. And I'm quite jealous of you, Skull. I love the snow, and we don't get it here nearly enough.
We don't get it at all.
We can swap. I go to Cairo right now.
Yes, that is true. That is true. So thank you for joining me.
I was going to complain about the heat. I figured we have Hania on the call.
Yeah.
So I was going to complain about the heat where I am from, but then I figured we have Hania from Egypt here, so I should not really complain about heat.
True. I don't know about you all, but in London we had some of the hottest weather in history for the city of London back in the summertime. People don't realize.
That's like spring.
That's
like spring weather for us.
We don't have air conditioning. Our houses are designed to keep the heat in, so it's like a week of suffering, and it only happens once every couple of years. And it's like, we should get air conditioning. We should get air conditioning. And then, the world goes back to normal. We don't need the air conditioning. And then the next time it comes, I was like, why didn't we buy the air conditioning? Oh, no. So I'm quite glad that we don't have that anymore. I envy those with functional AC units. But perhaps we should get to the meat of the talks that we're coming here. So again, thank you for joining me. You just come off of doing your bits and bobs. For the audience that are joining us now from into the live stream, could you fill us in a little bit about what you've done and why you did it and why it's exciting?
Ooh, what a big question.
Yeah.
Well, you start, Omid.
All right, I'll start and pass it off to you guys. Well, we got a team of superstars here, and together we put together a course around data and AI, which is taking an entire track for the Digital Developer Conference. It's on track 3. Shameless plug. If you're watching this, join us there. We have a lot of cool content that starts from the beginning of the AI journey, which is where you start with the collecting of the data, how to bring your data in. We go through the cleaning, we go through analyzing it, making the model, we go through deploying the model, operationalize it. We kind of cover the whole space and try to just teach people all the stuff that they need to be able to just take AI and actually use it in their applications. Every one of us worked on a different part of it. So really, you got experts on every part of it. And yeah, that's all I got to add to it. It's awesome. It's not just what you learn in college, which is just building models. It's actually the entire flow. And I think it's cool. It's stuff that I wish I learned in college. So
it sounds great. It's interesting, isn't it? What we study in uni often isn't very useful in the real world. So, you know, or it's only like a modicum of the actuality of deploying the thing, you know. So this kind of leads on from the questions I was asking my previous guest, Dave, about the kind of tooling and the availability of compute and resources around education resources, for example. What spurred you to create this series that bring people from kind of zero to hero in deploying AI in modern ways? And that's an open question to all of you. So have at it. Fight for it if you wish.
I think part of it is you learn all these things in isolation. You might have a Jupyter notebook where you do some work and create a model, or you might have some way to deploy it over here where it's running on a server, or you might have some, if you're working in an enterprise, you might have some data governance team that's controlling where the data comes from. So it is nice to have a sort of flow where you see how it's all connected together. And I think that was the starting point for a lot of this. Was we had worked with some customers and worked with some people internally. They're saying, "Hey, wait a sec. How do we connect the data scientists, the data engineers who are deploying this, the people who are working, the database engineers who are bringing the data in, and the governance folks who are worried about compliance and governance, and how do we make everything smoother for people?" So we started piecing things together because as IBMers, we have platforms for this. We have the Cloud Pak for Data platform, which is now available on the cloud. And we started seeing how, connecting all these things is as big a task and as important as each of the individual things. So it helps to tame some of that complexity to sort of see how you can bring the flow together and connect the various roles, all the different personas who might be utilizing all this data in a way that, helps them do their work and eliminates that friction. So I think that was one of the big incentives.
That's very interesting. With my previous guest, we were talking about a lot of the power behind modern AI deployments and applications is not so much from the tooling or the availability of raw compute power, but from connecting people and communities together to enable them to do the things that they want to do. So connecting the data scientists to the IT department, connecting the governance people to both of those, and kind of breaking down those silos. And I think it's interesting. A good question to be asked would be, has the availability of those AI tools driven the breaking down the silos between teams because now everyone can feasibly do it? Or is it the people's want to be able to do all these different things, the thing that's driven the development of those tools? So I'm going to throw that out there as a question that you might want to go. It's a hypothetical, but if you have any insights, I'd be more than fascinated to hear what you think on the subject.
I think it's the tools.
Sorry, Hania?
I think it's the tools and them connecting teams together that kind of brought instead of you working individually as teams and passing on the baton to each other as you go, kind of the availability of everything in one place kind of made it seem and force people to kind of think in an agile mindset, to kind of go through everything together, make sure that whichever step you're in right now, you're considering who's taking it and you're considering who's going to be handing this over to someone else in the step after that. So I think for me, it's the availability of tools and having it in one centralized platform kind of shifts the focus of people to kind of think about other teams, not just the team coming after them, but the teams until you deploy the project and until it's live in production too.
I think that speaks to the value of something like Cloud Pak for Data, where you have this one resource, one-stop shop for pretty much anything that everyone would want to do in a common place with a common tool set and availability to anybody on the team who may want to experiment and explore and deploy those kind of things. So naturally, it's great that you built a course around doing these kind of things so they can get started, right?
We just used it to solve a problem because we had a problem, and we grabbed the link from the notebook and shared it with some support people, and they looked at it, and we got to quickly get to the solution because we were able to share it and just quickly, easily say, hey, here, you go have a look at this. Those little small things add up and connects things, reduces the friction, solves problems faster.
Yeah, and I think
I think it's.
Sorry, go on, Amit, please. Apologies.
I was going to say, I think it's interesting. I think my opinion is a little bit different in the sense that we created all these problems by making tools. Initially, we didn't have any of these problems, right? And then we created tools, like if you think construction, we created, I don't know, shovel, we created the wheelbarrow, and everybody got an expert in one part of it because the tool became so advanced. And then we got to a point that nobody knows how to do the other part. Like, I don't know, the person who does the framing doesn't know how to put the windows in, the person who does this doesn't know how to do that. And finally, we were like, all right, maybe we should build an excavator. Maybe we should bring the car and the shovel and like all of these things together and build a way that it all works in Unity. So I think it started from having tools, and then the tools got so advanced and so unique that now we're at the point that people who are expert in one tool don't know about the other. Like Hania was saying, data engineer doesn't really know what data scientist wants. Data scientist is not really empathetic to how much work goes into getting the data. The developer is like, what am I supposed to do with this model? You're just giving me a file. What do you want me to do with this? I'm a coder. And then we finally have a bunch of coders. We have the Cloud Pak for Data platform. There's like, all right, fine. Let's look at what everybody wants and let's bring it all together. We're all a team. Let's build this one big machinery where everybody does what they're good at while actually helping the bigger picture. So I think it started with having tools that got too good, and now we need a tool for the tool, which is the platform, really.
It's turtles
Tool
all the way
inception.
down, you know. So
Toolception.
Yeah, the software only started going wrong when we started to write it. Yeah, it's an excuse I may have used in the past, you know. And we've all had that knowledge, you know. I've definitely had an urge, particularly in recent times, to just flee technology and head for the hills and live in a quiet shack. But at the same time, you know, I couldn't grow my own lettuce. It just wouldn't end well for me. So it's probably good that there's a big global distribution business that will bring me the foods that I wish to consume. Otherwise, I'm just going to be a very thin man in a very short time. Yeah, that's fascinating. Thinking in the last, say, 10 years or so, you know, I asked my previous guest, Dave, we saw AI starting to be introduced to the population, to the general public in the kind of things that they do. So the most memorable thing for me that I remember was the first time I heard Siri answer a question. I'd asked it with my voice on, I think it was the iPhone 4. So that's back in like 2010. And of course, AI has become more prevalent, not just behind the scenes in its usage, and, you know, and helping people make, you know, purchasing decisions and whatnot, but also in very in front of you kind of ways, such as, you know, self-driving cars is kind of the big, you know, Hail Mary AI moment at the moment. Do you think there was anything particular that drove the pushing of, you know, algorithms and the kind of the data algorithms from the background to the foreground that made them accessible to people? Or do you think it was a natural progression that was always going to happen? It wasn't one thing that kind of pushed it down that road.
I almost think of it like,
I have a strong opinion, though, so I'm gonna go. You guys can add.
Go ahead.
Why an earthquake?
Well, because, you know, the tension builds up. Like in an earthquake, you have these two plates, and they're just doing this thing. You know, they're moving and they're moving and they're moving. The plates are always moving, but they're not really moving. There's just all this pressure building, and all of a sudden you see this big slip. Yep. And it's an earthquake, and you think, wow, something big just happened. But all this stuff was building over the years, and in the you know, research labs and in you know, the universities, everybody's doing research and building cool things. You know, there was speech to text. I remember, you know, trying to use Dragon Naturally Speaking 10 years ago. It was like, it's so frustrating. I wish it worked, but it just doesn't work. And now, you know, sometimes when I'm typing, I'm like, the heck with this. I pick up my phone and I just dictate it because it's faster and it works so well. So there's was this sort of seismic shift where everything started working so much better, and it just kind of exploded. I mean, that's the way I see it. Lots of stuff happens over the years. You don't really see it. And all of a sudden we have all these wonderful tools, you know, on the consumer end or in the business end, and it's all working really well. And, you know, there's problems, but like we just taken this huge leap forward. And now we're at the point where, like, wow, we don't have time to implement all the solutions we want to implement. And we, you know, so it's exploded so fast because of this sort of building pressure of lots of people doing a lot of hard work for a lot of years. And all of a sudden we've got these fantastic tools that makes it so easy. And we're just like building things as fast as we can.
I think that's
interesting.
Yeah. Sorry, Eric, go on.
I was gonna say, that's actually interesting. I didn't look at it from that point of view. I looked at it as like what was available, and then what was just the next natural progression. As like I guess that does make sense. There's a lot of little work that goes into it, and then suddenly everything clicks, everything plays together. But I kind of was like looking at, you know, what happened in every decade. You could say you'd see like in 1990s we kind of perfected the assembly line, we perfected the manufacturing, so we had a lot of new cool products coming out, and then the market was dominated by all these new cool products that we made. In the 2000s, we had, all right, we have all these products, so the next natural thing to come after that was all the services. Now people need, companies like enterprises needed help with all of these products to kind of bring it into their system and try to get more value out of it. And that was around the same time that like the internet was kind of maturing. So everything started slowly getting more connected. And by the end of it, we were like, okay, we have internet, we have this world of connected stuff. We have no idea what to do with it. So we started collecting data. Not knowing what to do with it, we just started collecting a ton of metrics. We started collecting a ton of data. And then eventually towards the end of it and towards the big, like in the 2020s, we were like, all right, we have all this data. What do we do with it? And then I think the next natural progression is just getting value from this data, be it training models that can understand what you're saying, be it figuring out exactly where to put that button on a website that's going to get the most number of clicks. I just feel like kind of like was the progression of what was available and what was maturing at a time that got us to a point that now we have so much data. And I guess the next natural thing to do is, assuming we have smart people with the right tools, they could do something with this data.
Yeah, that's interesting. When I think of kind of the explosion of AI, I think back to the creation of the internet as well, how it was this system of disconnected networks. You know, you had the ARPANET and all these little, university-ran kind of programs across the world. And they were like, well, okay, let's try and make these things up. Well, what do we need for that? Well, we need a common protocol to speak to one another. So, TCP/IP comes along. And, there are these interconnected networks for a little time. And then Tim Berners-Lee comes along and says, actually, I think there's a better way of doing this, HTTP, a universal kind of way of communicating across these networks with this thing called HTML, which is a standard format for presenting information across the different systems. So you could run a server on Nextqueue, for example, but still have it appear on something running DOS over on the other side of the world, and it would just interoperate, which was, people forget how few computers in the olden days like to work with one another. We're IBMers, we have a history of making things work, with other things, but it wasn't the kind of go-to in the kind of commonplace market. I have a question for you, all three of you, that I'm going to throw out to you one at a time. And it kind of ties back into what Scott was saying a minute ago. What was the first thing you remember, the first time you actually remember noticing AI? Not just the concept or its usage of it, but that it was good. And I'm going to throw it out to Hania first.
Scott said it, and you said it, I think Siri, and because, wow, my Siri on my laptop is picking up right now.
Machines are listening. Close them all.
It's listening to us, yeah. So I think because I was so interested in natural language processing in general, and when I used to speak to it, and I kind of looked at the screen as opposed to just speaking and having it dictate, and I saw how it's I stopped at a certain point in the sentence, then I continued on, and it kind of corrected itself in a way that it's taking into account my context. And I thought wow, that's really interesting. How does it do that? How does it continue to learn? That's the first time I've said that sentence to it. How does it learn that within this context, it's gonna use that spelling or use that definition? And I think that's essentially what kind of pulled my focus to AI when I was especially when I was studying in university too.
Okay, that's a wonderful answer. I also was very interested in natural language processing when I was younger. The thing that kind of blew my mind in that space was that there were APIs all of a sudden. So I could just throw an audio file to, and I would get text back. It's I can do stuff with this. No, it's what can I build? I now have the ability to have a computer understand what I'm saying to it. And again, we've all had a lot of experience with these things over the years in consumer products, as well as things like DragonSpeak as well. I remember DragonSpeak. Even Windows Vista had a kind of built-in kind of speech-text engine, but it was something that I could play with. And I think when you have a thing, a tool that you can look into using in the way you do it, I think it's a natural follow-on. They go, right, now how do I do this kind of thing myself? And I think that's where we have things like TensorFlow coming in, Cloud Pak for Data, exposing all these kind of functionality to experiment, to explore, and to learn, to apply, which I think is fascinating. I'm curious if I would say, "Hey Siri," if it would trigger everyone else's kind of laptops right now, because that's quite a good practical application.
No, it's not.
That's good. That's good to know. It's a good practical application of where AI kind of falls down in some ways. It's clear that I am not the person that should be saying that. It's coming from me, not from you. I have a friend who lives in Liverpool who hates that when we're on a Zoom call together, I'll scream out, "Alexa, set a 3-hour timer," and it would do it. But it won't to him sometimes. So it's a good thing we're good friends. Otherwise, he definitely would come for me. But I think it's kind of fascinating. It just shows that even though we've got these things really, really good now, being able to dictate, if we were to understand context, to put commas and the punctuation in the right kind of place, it still doesn't know when to turn on almost. So Omid, I'm going to throw that same question to you next. What was the first time you really kind of were wowed by AI? Not just noticing it, but where you thought, "Wow, this is good."
So my actual background, like my bachelor's degree, is in electrical engineering. And I remember one of the projects we were working on was, all right, let's create all these like little IoT stuff and just see what it is. So we worked with a group and we created these little IoT sensors that you would put all around the building. And they were just like temperature sensors, heat sensors, humidity sensors, and all these things. And you managed to collect all that data and actually create a model that could predict what's going to happen. And based on that, we ran simulations of what needs to be improved in the building so you could actually save money on the heating and cooling and all these things. And that was the point where I was like, oh, this is cool. You can collect all this data and actually now you can do stuff with this data. You could have models that take into account the weather and what's going to happen and what's going to change. And some other team after us took it further. So they had these little shades that could automatically open and close. So based on how you wanted it to impact the rest of the place, they could adjust how the shading worked. And I was like, okay, this is cool. I enjoy actually having my world become easier automatically for me because of these AI around me. I guess the example of it in the home is the smart thermostats, but this was like on a large scale in a big building. And I was like, this is pleasant. This is nice. And it doesn't cost AC. It's just shades opening and closing by themselves.
It's interesting, isn't it, how, that sheer amount of data and, that kind of AI becomes almost invisible once it's there. Like people may question the first time that the shades are opening and closing, but you'll forget very quickly that that's not normal. 30 years ago, you'd start calling in the Ghostbusters. You're like, that's not right. But now it's like, this is the perfect way to live. Like, who are you going to call? Anyways, I got carried away. Sorry. And we're seeing more and more of that with the smart thermostats too, and the kind of godlike powers almost we have over the ability to control our environments, which is really rather cool. One of our colleagues, I went to Hong Kong with him, and he pulled out his phone one time. I went, "Huh." I was like, "What's wrong?" He goes, "My wife just turned on our heating." His wife, who was now 6,000 miles away in the States, he's like, she can't make it for another 2 weeks. It's like, the interconnectedness of these things and the ability to respond to them, whether it's, having blinds open or closed, or a husband being out to his wife for driving up the fuel bills a little bit earlier than she really ought to have, I think is a very interesting time and world that we live in right now. And Scott, finally, I'm going to throw the same question to you. When was the first time that AI kind of wowed you? You thought, wow, this is cool, this is good.
I'll skip the natural language thing because it was kind of a slow thing. It was really not great, and then now it is great. But that was a little bit of a slow boil of the water. What really wowed me when I first saw it was visual recognition. I work, developing these code patterns to teach people about some things that we do with some of our Watson things. We have Watson visual recognition. I was told, hey, we're going to create this thing. It's for the insurance industry. They want to be able to detect. You take a picture of your car. It's going to detect whether you have a flat tire or a broken window, and then you could use it to determine if it's covered in the insurance or something like that. So you'd give it some pictures of a broken window and say this is a broken window, and you give it some pictures of a flat tire and say this is a flat tire. And then when you took a picture of something that it hadn't seen before, it could get it right. It was so amazing and so simple and so easy to use. And behind the scenes, if you delve into it, you see all the cool tooling and the deep learning models and how that all works, which is really fascinating. But just how easy it is to use, like how far it's come where you can just basically train these things. Here's a bunch of pictures of this. Here's a bunch of pictures of that. Here's a bunch of pictures of another thing. Now, what's this new thing? And it just gets it right. It's like that. I think that's pretty amazing. There's so much you can do with that. And it's just come so far where it's, to use it is easy. You know, the behind the scenes stuff is all kind of there for you, so it makes us developers look smart. You show it to your family, they think you're really some genius. Hey, I work in artificial intelligence. And like, wow, that's really smart. I'm like, hey, you know, somebody else is really smart. I'm just standing here on the other side of them, you know, throwing it together.
This is the thing, and it's that availability of technologies now, so readily available that we can all tinker with and create, and you know, connect with other things that might not be normally thought of in that kind of space. I like to remind my mother that she has the most technologically advanced picture frame in the UK because I just whacked Watson visual recognition into it so that it would only show her pictures of her grandkids rather than the rest of my Instagram feed, which is, you know, before lockdown made life very, very boring, was perhaps interesting and the sort of thing that would cause one's mother concern. But yeah, and again, that's just visual recognition. You know, that kind of thing 10 odd years ago was very, very difficult. And I think it was, I think 2011, it was AlexNet that came along that managed to bump up the standard visual recognition test from like 75% accuracy, which were like, you know, hard-coded, you know, looking for edges and people defining patterns manually. They jumped up to something like in the mid-90s, which was an incredible feat. I mean, ever since then, you know, we've been using a knife to make a sharper knife kind of thing, which is kind of cool. And now everyone can play with that. You know, if you want to do something that detects when a person walks past your window, for example, you just download the model. It's there. It's good to go. If you want to build something new, there's probably data sets out there already that you can at least use to get started. I know a lot of people are using kind of ImageNet until recently. Now people are using kind of YOLO and all these other sort of things. Things like from OpenAI's GPT-3, I think it's called, where you know, it's able to generate entire books based on a couple of sentences, and it can extrapolate it to an almost freakily human kind of level. I think that leaves the question, you know, would you say that with great power comes great responsibility?
Indeed.
Of course, yeah.
It's funny because like people, you know, people fear this. If you don't understand it, you fear it. When you do understand it, you understand, you know, the machines are only as powerful as what we hook them up to.
Mm.
You know, you're not going to have a system that can, you know, launch a bunch of missiles because we don't connect computers to our missile launch systems. We never have. Remember that old movie War Games where they were, you know, the missile launchers failed, so they said, we're just going to hook it all up to a computer, and then that caused a big problem. Yeah, but we never did hook them all up to a computer. We never have, and we never will. And there's always a way to protect real things from AI by just kind of keeping them separate. Use the AI as a tool, but you know, you can always just reach over and pull the plug. You know, it's not like it's going to somehow
that's the thing, gain
life and walk around and you know, plug itself in. We still have control over these tools.
That's the thing. I think Oscar Isaacson in Ex Machina could have avoided a lot of troubles if he just imbued a fridge with artificial intelligence rather than, you know, what's it going to do? They're all like, oh, I'm angry now. I'm not going to chill his food the way he quite likes it. You've proved the point. You know, why would you give it arms and an ability to, you know, harm one sort of stuff? And as for the missile systems, I do believe they run on like sister mainframes from the 70s even. You know, they're so, you know, good lord, it's kind of fascinating in that sort of way that, you know, those systems are reliable, but there is no way that those kind of things can go kind of wrong. And even then, I think I remember being on a bus tour in Berlin. It was only me. It was raining. Because I was an Englishman, I was okay with getting on the bus because I'm used to it. But the tour guide, he said, well, it is just you, so let us talk. And I was like, I want the tour. I want to know what's going on. He said, what do you do? I said, I work for IBM. He goes, oh, I know IBM. What do you do? And I said, I spend a lot of time with AI. And of course, you know, the first thing he went to was those kind of fears. You know, is Terminator a thing? Are the computers coming for me? Are the machines coming for me? And the answer is a resounding no. You know, like not least because we have a self-interest in not making that kind of thing, but also because it's really very difficult to do that. You know, we're talking decades away. Sure, you know, Alexa can now understand my Scottish cousins where it couldn't before, and that's because it's gotten very, very good at, you know, analyzing that linguistic data and being able to put it through where before there was a small data set. But it's a massive leap to having a machine that can think for itself. It's why things like Alexa and the Google Home have personalities programmed into them by people, because it doesn't have a personality or, you know, a way of expressing itself beyond what we construct for it, because it's just really, really difficult. So yeah, that almost wraps up our time. I guess one final question before the time runs out. What's your favorite color? Let's go with that. Nice and light. End on a high note. Mine's red, which as a person that works for Big Blue is probably not allowed, but I'm sticking with it.
I'm gonna go with yellow.
It is good.
I don't know why. It just makes me hungry. It makes me think about food. It makes me think about food for some odd reason.
Like, did you grow up around a lot of cheese or something? Like, you think of yellow, you think of green?
No, I didn't. Maybe a dining room had some yellow hue to it. I don't know. It just makes me think about food.
See, it's an innocent question. Stuff. Rorschach test of personalities. We're getting right into Omid's psyche right now.
Yeah, what have you done?
I don't know. I'm scared. I'm scared of the power that I now have. Tanya, what's your favorite color? Choose one.
My favorite color is
teal.
Wait,
is Sean the AI here?
Beep, beep, beep.
He could be.
Evidence that I'm a real person. You haven't even seen my legs. I could just be an avatar, but those are getting quite good right now. Actually. But you said teal here.
Yeah, I love teal. It's kind of all over here. Like if you go walk into like the old Cairo, you'll find stalls like selling like jewelry with teal stones. It's pretty common. So like I grew up walking through these like awesome architecture and like stores, and I used to see them all the time, and then like I grew to love them.
No, that's straight. Egypt has a rich cultural history, literally filled with color. I've seen the pictures, so
yeah,
that completely makes sense. That's awesome. London is mostly just yellow brick. That's it, and they've changed some red brick, but the architecture is wonderful, but it's all the same color. So
I mean, the pyramids are yellow now, like.
So like white with a marble covering on top of them.
They used to be, yeah.
Yeah, that would have been fascinating. Yeah. But, fun fact I remember is Cleopatra was born closer to now than she was to the construction of the pyramids, which is crazy when you think about it. That's how long human history is and deep and varied. And now we've got the tools to make AI, which is kind of cool. And Scott, finally, our hour's up. What is your favorite color?
Black, always. I wore a shirt one day that wasn't black, and my teammate was like shocked, like, "Wow, I've never seen you wearing anything other than a black t-shirt."
It's good. It goes with everything black does. I've been wearing grey recently because I've been trying to make my wardrobe more interesting from the blacks and whites that I have. I'm not sure I'm going to keep it. It's a bit too radical a change for me. So
I'll go grey when it's like a big, holiday or
big event.
Celebrate.
Wonderful. Well, thank you all for joining me this evening, this afternoon, this morning. I know we're all in different places. It's been absolutely delightful to speak to you. Thank you for sharing your knowledge with myself and our audience. To our audience, I'd say check out the workshop. I know it's good, and you hopefully, from listening to all of us today, you've seen it's been put together not just by experts, but those who care as well. That makes the best stuff, right? Thank you all for your time.
You bet. Thank you.
Thanks, Sean.
Bye.
Hey, can you hear me?
Bill. I can, yes. Can you hear me?
Yep, perfect.
Wonderful. I think that might be the question of our times, isn't it? Can you hear me? Can you hear me now? Can you see me? These
even my 7-year-old.
Wonderful. Well, thank you for joining me today, Bill. Where in the world are you?
Raleigh, North Carolina.
Oh, wonderful, wonderful. Yeah, so I guess you're on Eastern time, right? So it would be just gone lunchtime there, right?
Yep, just the start of the Apple event. So,
well, thank you for putting yourself away to join me here today to talk about all the good things that we've got going on. Just for our audience members who are joining us now, could you recap a little bit for us on the content you've produced and presented prior to this chat?
You mean that I talked about in the context of the conference?
Yes, just a wee coverall for everyone.
Yeah, so I lead core AI development, and in March, when COVID was really breaking out in the US, there was a group of folks from our weather group, our AI group, and our cloud group who collaborated on the data pipeline and data lake to provide granular, trusted, accurate COVID-19 information down to a county level that we started, and a week later launched on weather.com for like hundreds of millions of people.
That's the thing.
So we talked about how we did that.
Yeah, clearly COVID has thrown the world into, particularly back then, chaos. So trying to get a solution that could be impactful, not in a matter of months, but in a matter of days, is quite the undertaking. What was the biggest challenge you had in putting all that together? Was it sourcing the data, or was it trying to figure out how best to apply data to solve the problem that was there? Or was it some unknown X factor that you discovered in the course of trying to solve that problem?
I think there were kind of like two classes of problems. There was the technical problem, and there was the solving a hard problem really fast problem. So the technical problems were around the extreme fragmentation and low quality of the data. If you put yourself back into the mindset of what was happening, it was literally a matter of days between like COVID is this kind of abstract news story, and like they're canceling schools, canceling the NBA season, and turning the US upside down. And so people, the states of the US, and for if there's anybody on from the US, there's 50 states plus a number of territories. They all were scrambling, and so they all were taking different approaches to providing accurate information on both infections and deaths. And so what we wanted to provide, and you can see it now at weather.com/coronavirus, was a map where you could zoom in to a county level of granularity in a consistent way, see that information. But since it was fragmented, both in terms of where it lived, but also how it was formatted, basically we had to do a scraper project that could basically scrape the data from HTML files, PDF files, and sometimes graphical dashboards, and then both normalize it into a consistent form as well as have quality, circuit breakers, because oftentimes the formatting would change or the numbers were wrong, and we'd have to catch that so that we didn't propagate misinformation. So that was the main technical challenge. And then compounding it was the organizational challenge of getting people who all had day jobs together to build a complex system in a number of days. And so what we did there was got some of the best programmers in the company and just asked them to work on it, best effort, and they all have a fair degree of autonomy, so they could take time off from their day jobs. And so they built the main kind of pipeline. And then there was kind of an army of volunteers who came in and created the individual scrapers, since each of the states was different. And then gradually we coalesced those, gradually being, weeks, not months, coalesce those into a set of reusable building blocks to more consistently go after the classes of information sources, web pages, PDFs, and images.
Right. Yep, that touches quite nicely on the theme that's been kind of woven throughout the answers that my previous guest has spoken about, which is the integrity of the data and getting consistent data to feed into the different models and solutions that have been put together. And you've clearly had a monumental task, not just in the different data formats, but in the different locations across the 50 states, United America. It's not at a federal level; it's at a state level. Now that you've done all that, now that you've undertaken that work, you've created reusable components. Have you found that people have been more willing now they have these tools available to them to experiment with different kinds of solutions because there's a common kind of tool set to it? Or have you found that people have kind of gone, okay, this works for our kind of like local level, this is what we're going to focus on in this direction now? How have you seen that kind of progress now that an initial implementation has been done? These things are kind of available for people to experiment with.
Yeah, I mean, there's been, so the weather maps use case was just the initial use case, but our working assumption when we were doing the work, which is proven out, was that once you have a consistent, high quality, trustable data set around COVID-19 that's accessible via API, the number of use cases is kind of unlimited because of the broad impact of COVID-19. So it's been used in solutions like chatbots, where maybe a company will deploy a chatbot where somebody could ask about how they're responding to COVID, like, are you open? Has anything changed? And so especially for like hospitals or governments, having that data available in a chatbot context is really helpful to help provide more self-service, because one of the kind of the second order problems that happened because of COVID was that people got really busy trying to solve the most urgent problems. And meanwhile, everybody's calling them to ask them what the deal is. And so, so like, for instance, like if you're a doctor in the early days of COVID, there's lots of people who want to ask you, like, what are the symptoms? Might I have it? And those are obviously really important questions. But if you're doing nothing but answering that on the phone 24/7, you're not actually treating patients who might have COVID. So by providing the chatbot that can answer those questions instead, it helps get people the right answers and freeing up the experts to focus on the problems that really need their skills. So that was one. Another is it's been integrated into our back to work solution that helps people make kind of risk assessments and trade-off assessments on when or how people should come back to work. And then finally, we made it available to our data scientists who can work on custom solutions. And there, the canvas of potential use cases is literally unlimited.
It's fascinating because, in such a short space of time, an entire ecosystem of tools and products have kind of grown up to support myriad use cases. Could you tell us a little bit about the initial development, the kinds of tools and frameworks and softwares you were using to create these kind of things, and how it's developed over time, if it's changed at all, if you've gone, right, this was a good MVP, but now it's time for, to integrate this in a more kind of grown up kind of way almost? Or has it been consistent, like, the day one kind of launch is a thing that's kind of spun out and lasted rather well, solving most people's problems in different ways?
Yeah, I mean, the basic parts of the solution have remained constant because honestly, there's not too many ways to do something like that from an architectural pattern perspective. But of course, the implementations have become much more robust and higher quality over time. In the early days, so there weren't just 50 scrapers, like one scraper per state. There was more than that because in some of the big states, particularly California is more like a country than a state. So there was way more than 50 scrapers in the beginning. And initially, there was just lots of copy and paste of code, which normally would be like the last thing that we would do because it's such a poor practice. But when you're making an intentional technical debt versus time to market trade-off, we actually judged that was the right trade-off then. And then we would start to consolidate as we had time to consolidate. So basically, initially, it was just like all hands on keyboards and allocating ownership of scrapers into different people's hands. And then maybe 4 or 5 days in, we started to see the patterns emerge and the opportunities for reuse that would make things simpler. The other part of the scrapers that was kind of interesting was a lot of the information was only available via PDF files and graphical dashboards. And for humans, at least humans without visual impairments, that's fine because, you can just eyeball the data and, it's helpful. But for automated computer scrapers, that data is traditionally invisible to them because, especially in the case of like, a graphical dashboard or a PDF that might be a scan of an image, it's just kind of noise. It's binary. And so what we did was we took some of our Watson Discovery technology. Watson Discovery is a product that we use to basically make sense of business documents and repurposed it to make sense of COVID reporting documents. And that was for the PDFs. And that's something that otherwise we couldn't have done because it's just impossible without that sort of machine learning based technology. The other one that was kind of funny was the graphical dashboard. So the solution we ended up coming up with there was actually using Selenium to take a screenshot of the dashboards, then using optical character recognition again from Discovery to parse out the data. So it was totally like a Rube Goldberg machine. But if the constraint was 7 days, then that was the right approach. So you got your scrapers, which is basically collecting the data. And like if you think of, we talked about the AI ladder, there's collect, organize, analyze, and fuse. So the scrapers were really the collect. Then they piped into a cloud object storage kind of staging area. And then we had a set of normalizers and sanity checkers that would basically run over that and basically say, is this data, can it progress to the next stage? And then we had finally had I think it was a database where we had the trusted data, which was then fed from the API into the weather channel and everything. And so The part that has changed a lot is the scrapers, but that's just been in terms of making it more robust. Everything else has stayed fairly constant. One thing is that, like I said, we brought the best developers from the company to work on it. And so like all of these folks had done systems like this 10 times already. So it wasn't like they had to figure out new patterns. It's just, okay, we need a data lake. Okay, cloud object storage.
Yep.
We need a database. And so that the basic architecture was pretty straightforward because of the experience of the team. If it had been a bunch of, right out of college folks, there would have probably been some like, oh my gosh, what do we do?
Yeah. What is this JavaScript of what you speak, and how does one obtain its power? Yeah. I think it's fascinating. As you said, this was very much an all hands on keyboards kind of deal. Normally, when you're dealing with a project of this kind of scale and size, take a Newsroom, for example, looking at the American election just come and gone. Those teams have been setting up for months and months and months in preparation for those kind of events. But there was no prep for COVID. It was here, and it needed dealing with now. I think it speaks to the strength of the available technologies, both in like things like cloud object storage, which without you'd have to start provisioning, network RAID clusters somewhere to handle the sheer volume of data, the availability of GPUs to crunch these kind of data, crunch these data points, and then actually do something with them afterwards. I think it speaks to the kind of power of the tool sets that we have and the capacity we have to use them in storage, compute, and general access. Also, things like Selenium. Selenium is a magnificent tool to to do things which normally humans would have to do, but when it's only accessible in a human way, it's a bit of a nightmare for a machine. I've dealt with parsing PDFs in the past, and all I will say is thank the Lord for OCR technology, because could you imagine having to do that yourself? So I think it really speaks to the power of the tools we have available to us now, and in experienced hands such as the team that you put together yourself, you can be really effective very, very quickly, because that's what time demands. There is no time to stop and plan. There is no time for a retrospective. We have to do this now. It has to work tomorrow almost, and it has to have results that we can use to inform people, businesses that want to open, people that want to go and see the GP what the symptoms are, because lives depend upon it. It's not often one has a project where there's a real human impact in a very direct, correlatable way. So I can imagine there was some pressure there as well. When you were doing this project, did you feel like you were more connected to the results and data coming out of it, or do you feel that it kind of cut you off a little bit from it so that you could focus on the work rather than the issue?
Yeah, the latter. And that was one of the reasons that we were able to get so many hands on deck. Because I remember the one weekend where we made the most critical progress was the first weekend. And we basically literally on Friday afternoon, like we'd had a small team of about 10 people working on it. This was like day 2, day 3. And we just put out a call for volunteers over the weekend to work on scrapers. And we said, we're not asking you in an official capacity, come if you want to. And everybody showed up. And what we found out later was, because if you remember, like that was the first weekend of lockdown, or maybe the second weekend of lockdown, where everybody was used to like going about their business and just leading a normal life. And all of a sudden, what are you doing? You're locked in your house or your apartment, and you're watching this horrific thing unfolding on the news. And so what a lot of people told us, and this was my motivation, was, okay, there's an opportunity to help. And that feels good. And number 2, if I can redirect the fear and uncertainty towards a sense of purpose. And so for a lot of folks, it actually made the whole situation more tolerable than if they had just been watching CNN for the entire weekend and all the stuff that was going on.
And this doom scrolling on Twitter, which I'll admit I am very much a full victim of far too often, particularly with this last week in the elections as well. It's like,
yes.
But it was fine. But that is an interesting point. You have all these people kind of appear. You put out a call for help, people arrive. Could you tell us a little bit about how you kind of coordinate these kind of efforts? Like, I remember you mentioning slightly earlier on that there was a great deal of autonomy amongst these people, but at the end of the day, they had to have data that was useful in a common, understandable format so that it could be processed. So how did you set out like a spec for what you need and what kind of format, or was it very much as the data kind of appeared, you cherry picked and went, okay, this from here works, and we could pull that from there, and this works? Can you tell us a little bit about that process for our audience?
Yeah, well, at IBM, we have a fairly good internal kind of digital tools set up. like we've got the world's biggest Slack instance, the world's biggest GitHub Enterprise instance. You know, we've got WebEx, et cetera. And so we really made use of those tools for the collaboration. So when we decided, like, yes, we're going to do this, then we created a Slack channel called, I think it was called COVID War Room or something. I brought Slack to IBM, so I still kind of have root access to it. So I shared it across all of IBM and just started inviting people in there. And soon it grew to like, 200 people. And then, so that's where some of the collaboration was happening. Then we also had just kind of an open Zoom War Room, or maybe it was a Google Hangout. I can't remember. It was the weather guy, so it was a Google Hangout that was just open all the time, and people could just kind of jump in there. And then we would, and then of course the code was in GitHub Enterprise. So I think there was sort of like these central war rooms where we would tend to coordinate at a macro level. And then as people picked up work, they would coordinate on a micro level. So 2 or 3 folks might leave the Google Hangout and start a WebEx to focus on their particular thing. So it was fairly kind of like semi-chaotic self-organization, but if people have the right commitment and they've got the right mindset, it's actually very possible to do.
Yeah, and it's fascinating to look at where we were 10 months ago, where tools like Slack, WebEx, Zoom, all these other different places were something that we could use to do work if we wish. But now it was the way to do work, and still very much is. I haven't seen a colleague in person in 9 months, which was unfathomable in the before times, right? Unless you're working remote from the before times is what I call the distant past now.
Me too.
But it's kind of fascinating. And so, now, obviously you've got the project underway, you've got results going from it, and, you've kind of built out this ecosystem that people can go tie into in their various different projects. Now that, we have a vaccine on the horizon, which, fingers crossed will be great and should be rolled out everywhere very, very soon. What, with the technology you've built and the lessons you've learned, what do you think is the future for this kind of thing? I mean, if this were, God forbid, to happen again, this kind of situation where there's a second virus, say, would you feel that you could take what you've built here and straight up go, right, okay, number 2, let's go. We've done this before. We've got it now. Or do you feel that each situation is unique and thus requires that kind of, opening of a war room, sitting down, hunkering down in the basement and figuring that out before jumping in?
Yeah, we actually, my kind of colleague from the weather company, Misha Solpover, who I did the interview with, he was really the mastermind behind the data model. And the approach he took was a very extensible data model, so that as new information became available, we could incorporate it where it existed. So for instance, at a certain point in the spring, and it might be happening again, the hospital capacity became a real problem. And so he started ingesting like hospital bed availability, because that becomes a very important thing to know at both a macro level. Like if you're deciding like where should we set up a army field unit or something like that. So the data model was designed by Misha to be very extensible. And so that's one thing. And the other thing he noted is that if you kind of zoom out from the COVID-19 situation, it actually is an instance of a class of problems which are sort of chaotic events. And other things that are in this class of problems are hurricanes, wildfires, those events that you either have no time to plan for, like in the case of an earthquake, or very little time, as in the case of a hurricane. And the presence of accurate information in a timely manner can make all the difference in terms of people making decisions at micro and macro levels. And so since he works at the weather company, his intent is to adapt the system to be kind of a general purpose emergency response system that will provide similar trusted data and experiences for those other kinds of chaotic events where the situation unfolds very rapidly, and having timely information can, again, mean the difference between life or death.
Yeah, I think it speaks a lot to your point there that these problems, whilst they seem separate, are actually very, very similar in lots of circumstances. I think it speaks to that that IBM's Call for Code this year, which normally focuses on environmental disasters such as hurricanes and wildfires, expanded to include COVID-19, and we saw tens of thousands of solutions come out of that, which could still help in many different circumstances going on in the future. One thing I want to ask about is you mentioned one of the data points there, which was the hospital admissions numbers. And I think that's a great example of how one data point can offer more insight than it just would seem on the surface. Were there quite a few instances of that? Was there any other kind of thing that when it was put into the modeling, you were like, oh, that's actually really, really helpful when linked with these other three things? Or was it the different data points that were coming in were very much kind of evenly important depending on what was going on there?
I mean, I kind of think of the data points as interrelated, and you know, especially as you see the trend data over time, and as you can kind of compare and contrast the state information, it helps you understand the dynamics of the situation. Like, of course, we know now, but didn't know then, that there's a fairly predictable progression of COVID from when you initially catch it to the onset of symptoms on day 5 or so, to like the really risky point at day 14. And so, I mean, we kind of take it for granted now, but back then it was really helpful to know that if infections were spiking in an area, that hospital beds would be in very short, well, could potentially be in very short supply a few weeks later, because, you know, the onset of symptoms, when you might get tested positive, you may not go to the hospital for another week or 2, because that's just the nature of the progression. So gaining insights into things like that, the dynamics of the situation, I think help make better decisions, kind of downstream effects that weren't obvious in the early days, but now we've kind of internalized as sort of the mental model around COVID as a pandemic.
It's interesting. So, we're coming to the bottom of the hour now, so our time is short, but I will ask one last question, and this is for our audience members. Obviously, the COVID pandemic has not gone away. We know a lot more now than we did before. We're better at handling it. We're better at predicting its cycles. We can kind of maneuver around it rather than just be kind of hit by it and having to deal with it. Given what you've done, what you've built, for the developers out there who may be interested in helping in some sort of way, is there something you'd recommend, a program or a project that you can contribute to at all? Or what would your thoughts be in that kind of space if people want to contribute to this kind of thing for their local community, say, or on even a national level, such as the team that you've put together has done?
Yeah, I'm actually not sure, because what we did, we kind of produced this API that I think is still only available to IBM and partner teams. I think we might have talked about not commercializing, that's the wrong word, but externalizing it. But I'm not sure what the status of that is. So the only thing that really comes to mind to that question would be the call for code, which I can't remember where it's currently at, but of course there will be additional ones, and they'll continue to focus on how do we use code to impact the world. So if folks have never checked out Call for Code, I definitely recommend checking out both the recent winners as well as maybe signing up for notifications about the next ones.
Yeah, my understanding of Call for Code now is that it's in a continuing cycle, so it's not, it never ends. It's like Bob Dylan's never-ending tour, right? I believe the current. So go on, please.
Oh, I just had one thought. So the one thing that, just based on this conversation, that might be interesting to folks is the checking out the Watson Discovery product and the Watson NLU product to basically make sense of complex documents, because it's kind of, you know, what do we say? Like, data is the fuel of AI, but initially it's unrefined fuel. And so if you can master things like natural language processing and smart document understanding, the aperture of data that's available to you for your own solutions, I mean, it doubles. And so, but a lot of people either don't realize that it's possible, or think that it's only for people with machine learning PhD from Stanford. But one thing that we're really trying to do is make it accessible to both kind of like normal users as well as developers through APIs and SDKs that encapsulate the complex machine learning behind the scenes that's making it all work. So I definitely suggest people check that stuff out. I actually don't come from an AI background. I come from a development background. And it was pretty exciting and liberating to me when I realized that my development skills, software development skills, actually could make use of AI, because all of the machine learning magic is encapsulated behind these APIs.
That's the thing. I myself, I come from a media background, and I kind of fell into software engineering. And then, of course, my eyes were opened up through things like APIs and SDKs. Like, oh, I can have this power as well. I can learn how to do this. It's not this mysterious dark art. It's something that's very understandable and easier than ever to use with things like Discovery, for example, or things like speech to text or Watson visual recognition. To do. It's
and I
fascinating.
just posted a link to you. I don't know if you can share it with the group, but I wrote an article last year that got pretty good reaction, called AI for Developers, that talked about my own learning journey as somebody who was thrown into this world of AI as a developer and didn't know which end was up. And so I think sometimes if you share your own learning journey, it can help other people with their learning journey. So if that's helpful to anybody, check it out.
Yeah, I don't think I can share that, but I think Mike, our producer, might be able to do that for us. But we'll make sure that gets out to people. I've got it open in tab for myself later on. But yeah, thanks for your time, Bill. We're just shy of the half hour. Is there anything you'd like to talk about in the last 2 minutes, or would you like to claim that time back and have a nice, relaxing lunch?
No, I just hope it was helpful to folks, and thanks for letting me tell that story, because I think it's really important as software developers that we have a mindset not just of like, how do I churn out the next feature, but how can I use my skill to do some good in the world? And when those opportunities present themselves, take a shot, and then it's good to tell the stories to hopefully inspire some other folks.
Absolutely, I think that's very much the case, and thank you for telling the story. It's when you do something day in, day out, like writing software, it's easy to forget that those skill sets can be way more impactful in different scenarios that you may never have thought of. Again, if you told me 10 years ago, hey, you'll be able to make AI and program quantum computers, and there'll be this pandemic that you'll be, using 3D printers to go and solve problems with, I'd have been like, I'm sorry, what? And it's very much something that pretty much anyone can pick up with the right kind of time and energy and focus and apply, and despite their backgrounds, such as ourselves, where we haven't come from that traditional kind of comp sci engineering sort of learning. So thanks for your time, Bill. Thanks for sharing the story with us. Thanks for sharing your knowledge with us. Thanks for the work you've done. It's truly fascinating and immense, epic stuff. So yeah, thanks for stopping by, and have a wonderful afternoon.
Thank you. Have a good day, everybody.
Thank you. I think we're going to go to a short BRB, everybody. So thank you for sticking around. Check back in a few minutes, and we should have our new guest online soon. Otherwise, we'll have me filling the gap for half an hour. I've got a backup plan. It involves AI around the house. So see you all shortly.
Hey, Sean.
Hello, hello. Hello there. How are you doing there? Now, I must apologize. Is it Ruchi or Ruchi? How do I pronounce your name?
Ruchir. CH as in Czech.
Okay, so Ruchir. Wonderful. Thank you for joining me today, Ruchir. It looks wonderful weather where you are right now. It's where are you in the world?
I'm in New York.
Ah, wonderful. Upstate or in the city?
The first county north of New York City, Westchester County.
Wonderful stuff. Wonderful stuff. I do believe that's where Professor X's Academy for Gifted Children is in the X-Men series, Westchester. That's lovely, that. Oh, I'm very jealous. I'm in London, where the weather was nice today, but it's now dark and cold. So,
well, I'm just trying to absorb last few days of remaining warmth. Actually, it's been beautiful for last several days. High of 73, 74. So it's beautiful.
Yeah, again, jealous. I've not seen those temperatures in months, But hey, that's the British weather for you, right? So, thank you for joining me today. Now, I've told you have quite an evocative talk title that you're just coming off the back of, which is "Can AI eat software?" So, just for the benefit of our audience, there, could you just kind of recap a little bit of what you covered, so that we can get into asking the questions and exploring that topic a little deeper and picking at your brain?
Sure. So I think the main sort of essence of the talk or the discussion is AI is really disrupting every aspect of our society, benefiting it in tremendous ways as well. And obviously, software is benefiting tremendously from that acceleration as well. The last 10 years or so, I would say, software engineers have roughly 24 million software developers in the world, projected to go to around 30 million in next several years. Now, the question on the table is, interestingly, software AI is disrupting part of software industry already, which was more centered around technologies like computer vision, speech, and natural language processing, and so on. But can AI disrupt software engineering itself? By that I mean, there is obviously nirvana of AI write software for you. That ain't materializing anytime soon. However, it can make our life tremendously better. And in what ways can AI help our life as developers better? So that was the essence of the talk regarding AI disrupting the world. In what ways is it disrupting the world? In some ways, it is writing the software for us. By the way, in terms of computer vision and others, we don't write that code anymore. It's sort of trained by examples or data.
Exactly.
So that
it's crazy. So as a software engineer myself, I think me and people like me have felt kind of almost untouched by AI's impact on the world. It's a tool that we can use, but it's not something that's going to replace us anytime soon. Whereas other industries, there is that very much real fear. And yet, you have things now that are starting to turn up, which put the fear of God into me, I tell you, which was GPT-3. Someone built a small application which managed to, you would describe to it what kind of React app you would want. So you could say, I want 2 buttons that have a sum total. When I push one, it adds 5 to the value, and when I push the other, it takes 5 from the value. And it would build the React app for you. And that was the first time I've gone, oh, I'm not immune. I'm vulnerable to this as well, because we're at this point now where with the availability of computing power, which is a theme that we've been having this evening with the other talk we had, and the tools and the data that are now available to us, it seems that all the things we've always said couldn't be done are now being done. Take the late 60s, chess is the purview only of the human brain. No machine will ever learn it. And then 1997 rocks up with Deep Blue, and we defeat Garry Kasparov. And of course, it's like, okay, well, computers will never be able to understand human language to extract questions. And then Jeopardy came along with IBM Watson, and we beat that as well. And okay, cars. You'll always need people to drive cars, right? Now cars are driving themselves too, and now software seems to be the next thing that's on the chopping block, even though it's remained largely untouched. And so I think that not that we're all on notice, but perhaps it's something that we should definitely start thinking about AI's place in that world and software engineers in the kind of symbiosis of these two things working together. What do you think is the next step? What do you think is going to be the first kind of time that we notice that AI is taking over aspects of our roles and the things that we do? You've mentioned that computer vision is no longer crafted by people, it's trained by people. And there's lots of examples of these days. But when it comes to the day-to-day life of software engineering, the kind of things that we do, what do you think is the kind of the next step, the next thing we'll see kind of appear in that space that we'll have to take notice of?
So there are several, I would really say, immediate ones that we see rolling out. Critical ones are code reviews, as example. AI to be able to help you in reviewing the code. AI to be able to help you find the right things. And nobody writes things from totally scratch anymore. I have a problem. I go, type it in Google, I say, hey, there is something on Stack Overflow. Great, actually. Okay, so can AI help me find the right things that are the right posts? There's just too much of junk in Stack Overflow and Quora as well that I tried it doesn't work. Then, okay, hone down on the right set of things and help me get the access to the right information. Third one, I would say, which is very now moving over onto sort of business applications. There is a massive task of modernizing applications, actually, modernizing legacy code. The more the more an industry exists, the more baggage it carries with it, actually.
Absolutely.
And interestingly, you look at still banking industry, there is, I know this personally, there is COBOL code that's still around, by the way, working just fine.
Millions of lines around the world. It's impressive that it's still knocking about. Yes.
So interestingly, can AI help me modernize my legacy applications? Massive business, very painful. Nobody wants to deal with it because everybody wants to be on the exciting side of the stuff regarding writing new application. Nobody wants to take the pardon my language, old trap and trying to move it on the right hand side, actually. And again, I think those are the things where we find it very painful. Nevertheless, it is like the bread and butter of the industry, actually. Of every industry. Can it help me reduce my pain? That's where I would say AI can help you, where it truly delivers value to the CIOs and CXOs of the world. That's where we will start from. Obviously, developer productivity as well. I don't think this point of view of, AI will write the software for me. Like, okay, I just tell it something and it'll write it. In kind of toy applications, it might. Right. But, like real software is quite complex. And yes, there will be aids that will help me. Automation will continue to move forward at rapid pace. Right. But I don't think we are going to replace human ingenuity in terms of reimagine, sort of almost a reimagined way of doing things. That is not going to occur anytime soon. But I think there's this, what I really want AI to do, which is what we are working very hard towards, is help me reduce my pain, actually. I have just a lot of pain on a day-to-day basis. Can it help me reduce that pain?
I think you've touched on lots of interesting topics there. The first thing that came to mind for me was back at the start of the COVID situation. I believe it was New Jersey State that had it's universal credit kind of programs running on old mainframe systems running COBOL that just couldn't handle the load because they hadn't been updated in 30 years. And of course, no one is taught COBOL very much anymore. You have the kind of seasoned developers who learned it back in the day and still know how to do it. But no one my age, for example, I know of COBOL. I know what it looks like. I've never written a line of it. And so to have to update this massive system, which, society depends upon in lots of ways, and not having experience there, if you could automate parts of that, if only to, point out to developers, this is what needs to go over here. This is what needs to go over there. How these things kind of join up together could definitely be something that was very much helpful. And I think still shows how much we rely upon those legacy systems and how much, we've lost when it comes to the human resources that can actually make those things kind of happen. The second one that makes me, that I thought of was, I'm glad to hear that I'll still have a job for the next couple of years at least. That always brings me joy, and I'm sure it'll bring our viewers joy as well. It's always good to know that we're wanted and needed. I think the point you've made that how do I reduce my pain is a very important, interesting one. The thing I've always believed and I've always said as a developer advocate is that developers want one thing, an easy life, a simple life, one without messy complications or, and of course, things go wrong and problems happen and there's a rise and we try and figure out how to do it. But then you have tools that solve that, right? Things like PaaS, where I write the app, I ship the app. Containers, where I have a system that needs to run in several places. And of course, I think the example you brought up of code reviews, helping people know where to look for these kind of things and pointing out where there may be errors. And we see these kind of exploits every now and then where someone will change a little bit of code in C where it's if blah equals true, and then the person has like root access, which you and I might read over because it's the 1,000 if statement we've seen today. We're like, okay, yeah, sure, it's probably fine. People aren't going to read a 1,000-line pull request. The best way to get a pull request approved is to send a massive one in, right? But having an AI which is diligent and good at finding this thing and saying, no, hang on, did you mean to grant access rights to everyone? Because that's what you're going to do here. I think that is where we'll start seeing those kind of things very, very soon. I can imagine, given what we have now with NLP and GPT and all these other kind of things, that's not very far away at all.
That's not actually, and I think the other interesting aspects are on vulnerability detection. Actually, obviously, you can always go in terms of your dependencies, go to National Vulnerability Database. There are lots of tools out there that help you do that. Actually, but people are fixing vulnerabilities in GitHub on an every minute basis, actually, and I put a comment in there regarding I fixed this vulnerability, learning from that pattern and extracting that data and finding the patterns regarding these are the kind of code samples that give rise to those vulnerabilities without going into this cycle of it got into National Vulnerability Database. That's like 1 year cycle with the government bureaucracy, actually. Do this in real time as people are fixing stuff in GitHub. In public GitHub repos, just crawl through that on a daily basis, find the right patterns and build a model on a continuous basis that learns and gets better and better over time. Actually, is another yet very, very good example actually on fixing vulnerabilities, actually recognizing vulnerabilities.
I think that brings us to an interesting question, which is about you, Ruchir, which is how did you get started thinking about this kind of thing? Was there a day that came where you'd had to put up with so much nonsense and so many problems? You were like, no, we need to fix this with AI. Or has it been a much more kind of slow burn throughout your career and your experience where you've come to kind of realize that, this is a natural progression, I think, based on what I'm seeing now?
So I would really say my life has always been, right after my PhD degree, has been about automation. I've been in the automation industry since the day I started my professional career. And I say the goal of an engineer is to put himself or herself out of a job. That's my job description of an engineer, actually, which is the goal of an engineer is to keep on continuing building the tools that automates their current job and move on to the next level, actually.
Absolutely.
And, as I write software or as I design hardware or as I develop AI, I work on technologies to automate AI itself, AI to build AI, actually. AI to kind of help me in my day-to-day task, and maybe one day AI to develop software for me as well. And I will tell you what to do. And hey, I have a new algorithm, actually. Can you go and kind of implement it for me and optimize it for me? Great, actually. I want that. I want that day on my beach, actually. This is to leave.
You and I both, providing someone's still paying the rent. I like living here. This is always a nice place. I think that kind of brings up an interesting point, which I've forgotten, annoyingly. Hang on, what were we talking about? AI, automation. I had a question. I have forgotten the question.
That's okay. It'll come back to you. It happens to me often, Sean. Don't worry.
Oh, yeah. It increasingly so now that I'm stuck at home all day. It's like, I'll ask all these things later on, then it all goes out the window. Where I wish I was, but I can't because it's not safe these days. But yeah, we were talking about automation. Oh, that was what it was. No, it's gone again. Oh, this is embarrassing. This is embarrassing for me. We were talking about automation, your career, your path. Oh, yes, okay, yes, I got it. So you were mentioning that you want to see the nature of the notion of AI is creating AIs, of you saying, hey, I have some software, make this software go and work better for me. I think that follows a trend that we're seeing now where, the last 50 odd years, whenever we've had a problem we want to solve with a computer, people like you and I have sat down, we've opened up a text editor, we've written some code in it, and then it's gone and executed. And now in, not even in an AI space, just in a kind of development space, we're seeing a lot more kind of low code or no code environments where people don't express through computer programming language, what they want to do, but they connect chunks of functionality together to achieve an objective. And again, I think that's something that way particularly it's a trend that's kind of growing a following even now, but lends itself even more effectively to the kind of AI way of doing things. Because whereas, like NLP, having a computer understand it is a difficult proposition until it's done. Having it understand what's going on in the programming languages is difficult until it's done. Because there's so many different ways of, using a loop or conditional statements or functions or whatever to achieve the same kind of thing. Look at the lexicon of the English language. It's possible to say a sentence no one said before because of the infinite number of combinations, right? With things like low code and no code environments where there are core simple functionalities which connect in certain ways to do certain things, I think that would lend itself quite well to creating solutions and learning what's going on there. It's like, okay, this person's trying to achieve this output. I'm going to do this. So it becomes more like a visual recognition problem than a kind of semantic understanding sort of one where you're kind of analyzing those sort of code bases. So I think that's a fascinating example that you kind of...
Yeah, it is. And if you look at, just from a very practical point of view, and whether AI or not, automation point of view, you look at more recent environment these days like Ray or others, whereby people should write Python code. They shouldn't worry about how it gets sort of underneath it, distributed processing happens, and it gets sped up. Even you have 4 cores available, it's going to speed it up all automatically. You just write Python code and just import one file. Let's say Modin as an example, you are using import Modin, and then you just that's all you need to do, and all functions are imported automatically and they are overridden. And now, voila, you have you're just writing Python, but it's twice faster, by the way. And I want that life, actually, and more and more of that, rather than trying to worry about how do I map this to 4 processors, and how do I import GPUs, and how do I actually take it? Well, like painful, actually,
As a man who had to configure NVIDIA drivers on Linux to get his TensorFlow models working, I know that pain, and I never want to do it again. It took a long amount of time. Like, why doesn't it work? And I think I think one thing we've kind of skirted around in the kind of answers to the question we've had is the power of open source. Like you said, you write some Python code, you can put in something, and it's there, and it just goes. I've never written anything on a kind of Linux level or a kernel level. I've operated solely in user space. I don't care how the operating system runs my code, just that it was. And there's always ways you can tweak what's going on to make things run faster. Either making your program one that can be multiple threads rather than a single one, for example. But when it comes to open source, as a data source to find where these problems that can be identified and analyzed and then solved in an automatic kind of way, where we have people contributing to frameworks and to kind of tooling whatnot, would you say that open source has been a big driver behind this kind of movement, or would you say they're two things that have kind of evolved organically alongside each other and now kind of finding one another?
I would say recently, in last 5 years or so, open source have been a big driver. I would say none of the advances of AI would have happened had it not been for the open source. In fact, nowhere is it exemplified more than the massive lightning speed of progress in AI. Because if we were not collaborating openly across academic and industry community, none of that would have happened, because I think the researchers and the practitioners and the industry is collaborating at such a fast pace, including data sources, which are critical to that particular area. And broadly speaking, whether it is Kubernetes or whether it is Spark or whether it is Ray, or there's so many areas in which I think that if there is one single factor I can point out in last 5 years, leave AI aside in software engineering, it will be that trend towards open that has really accelerated the trend and benefited us all, actually.
Absolutely. And as people will know, IBM has been a big open source contributor for many, many years now. And I think, we've definitely reaped the benefits of that as a company. I think people have reaped the benefits of that contribution too. You look at projects like Linux. We funded that all years ago, and now it runs the internet. Google as well with the production of Kubernetes, for example, which is now kind of the de facto way to deploy applications in the cloud. Things are better when they're open.
And not just that, it's nowhere. We put our money where our mouth is as well. Acquisition of really Red Hat is a critical foundation for IBM, and it's a culture. It's not just about software; it's about culture, actually.
Absolutely.
So I would really say open is not just about I put some software in there. It's about open first. It's about culture of the people in what they exemplify in terms of their day-to-day work as well. And I think anybody wants to actually sort of delve deeper into it should read blogs and videos from Jim Whitehurst. Phenomenal, actually, in terms of what culture it takes, actually.
I was just about to say, I read Jim Whitehurst's book, The Open Organization. He talks about the process and practice and culture of innovation over at Red Hat. And I read this book when I found out we were going to acquire them. And it's a fascinating way of doing things, because clearly it's been the very effective driver for this massive company which had great success despite all of its key products being open source, which historically, if we look at software engineering in the kind of prior 30 years before that, is very much people had code they would sell, it was proprietary, it was copyrighted, it was licensed. That was the model. And then Red Hat comes along and nope, we're not going to do any of that. And the culture part of that as well is, my understanding was, if someone wanted to do a job, they would create the job and they'd be left to go and do it, which in a normal organization which is used to hierarchies is baffling. It's mad. It makes no sense. And yet it's allowed the company to move where it needs to go based on where the people are, and that willingness to undertake that responsibility and those roles, because they see a need for it, because they see a need for collaboration, for that space to be filled, for that kind of osmosis between these different kind of factors, and let them move in such fantastic and magnificent ways. So yeah, it's I hadn't thought of Red Hat in that context, so I think that's a very interesting point you brought up.
Yeah, exactly.
What are so obviously your hopes for the future have been expressed quite clearly. You want an easy life and you don't want to deal with the hard stuff anymore. What do you think is going to be the biggest obstacle to your idyllic existence coming to pass in, say, the next 10 years? Do you see any roadblocks on the road ahead? Or is it to you a very clear path which is easily surmountable if we have the right kinds of things happen at the right kinds of time?
I would really say it is a combination of I would actually start with culture first.
Okay.
I believe technologies can be brought to bear if we were sharing enough data together in open ways. So I really say foundation to all of this, and this is why I love actually Jim's sort of point of views on this. It's about culture, and if we get the right culture, then it generates the right set of collaboration mechanisms and right set of data sources on top of which AI and other algorithms can be trained. Then I'm confident in our ability to move the ball forward. Now, whether that'll happen in 5 years or 10 years, we can debate the pace, but I'm confident in the direction. I think one thing that will stop us will be kind of us stopping in our tracks and saying, well, I don't want to kind of collaborate in that open way, or I don't. Then it becomes harder, because then you are trying to reinvent the wheel, actually. You are not trying to put our energy and brain power together. And to me, obviously, all businesses have to find the right medium between what their value proposition is versus what is there in open. But I think it's that boundary of pushing the ball forward and still be able to find the right value, just like Red Hat has, is the one which is critical. And to me, Red Hat exemplifies that software model that will benefit all of us.
I couldn't agree more. And that's our time. So again, Ruchir, thank you for joining me this evening. Thank you for the content you've put together before this as well. I've had fun talking to you. I'm no longer scared for my job, which is a good thing for me to take away from it. I hope you've enjoyed yourself. And again, thank you for your time. Thank you for your energy. Thank you for your thoughts and ideas. And I hope
thank you, Sean. And if it is if it makes us feel any better, my wife is a physician. Right. And she says AI will never be able to get to that personal touch I offer to my patients. I don't see that happening anytime soon, actually.
Well, here's hoping. Let's see how it goes. But again, if it can come for software engineers, it can come for anybody. So let's see how the future progresses. But again, thanks for your time. Thank you today. Have a wonderful sun-soaked afternoon.
Hey, thank you. Take care. Bye.
Bye-bye. Hey, Alkar.
Hello. Hi, Sean. How are you?
Ticking along very nicely. Just settling in for the evening over here. How are you doing over there?
Wonderful. It's very sunny outside. It makes me happy when it's like I'm in a spot where all this, I don't know if you can tell, all this sun is coming in and it's wonderful. Oh, look who's here. Hey, Matt.
Hello. I thought I'd come join you too.
Party is Mr. Hamilton, So, yeah.
Good to see you. Good to see you.
How he's in a sun-drenched room and he's enjoying life at the moment. Whereas you and I are in these dark closets just waiting for the night to finish.
Yeah, I've at least discovered artificial light here, Sean. It seems like you haven't quite got that there.
I mean, you know me. My genetic legacy is one that if I look at the sun, I get burned. So darkness is my natural habitat. And, that fits my career as a software developer very, very comfortably. We found each other, and it works.
On the other hand, I live in California. We pay special tax for the sun. Yeah, it's wonderful.
Good to know. Yeah, honestly, there are times when the sun comes out in England and I start worshiping it as a deity because I forget it was there. It's been grey for so long. It's like, it's just the sun. It's not the Almighty. That's good. That's good.
So
I've been.
Go ahead, Matt. I was just going to say, so for people watching, the guests we were meant to have on now, we're not sure if they're able to make it. So that's why, hence, you've got the three of us. We thought we'd have a kind of just a bit of a chat and maybe a recap about some of the stuff so far today. So, but yeah, go ahead, Alkar. What were you saying?
No, I was gonna say I've been hopping in and out of the conference, and it's been going great. I learned a lot of things. Sean, your last guest was very knowledgeable and also very entertaining. I loved the back and forth between you, and I liked how you said
it was a good chat. When I think I certainly enjoyed myself. I hope Richie did as well. So yeah, I think those are the ones where people can speak freely and kind of explore ideas as well as explain it, and having the knowledge behind that too. So that it's not just kind of airy-fairy kind of thinking, but it's like, no, this is the way things are because of this and that, leads to far more interesting conversations, to far more in-depth conversations. And that's where we learn things through being challenged. And, if you're at the end there, I'm not going to lose my job, which is always good. That's always, I like hearing it. I don't hear it often enough. So it's always a plus, Yeah.
Yes, I liked what he said about he said every software developer should aim for a time when they can automate all of their jobs and move on to other things. I like that.
Yeah, absolutely. Yeah. That's the goal, isn't it? We just want easy lives where it reminds me of a blog post a couple of years ago of a developer who had clearly way too much time on his hands and had automated the minutiae of his everyday life in the office. Like he had a script which would hook into the coffee dispenser in the kitchen, wait 20 seconds, and then start brewing. And that was the time it took for him to walk from his desk to waited for 20 seconds, but instead he kind of went forward. Oh, no, I'm back. I'm back. I think the computer's telling me I'm talking too much. I'm going to be quiet. It's that time of night where the internet's like, you know what, Sean? Good night. It's bedtime.
So Matt, I want to know, what has your experience been? I know you were up in the early morning, and interviewing our wonderful speakers. Do you want to share a couple of thoughts with us on what you've learned today, or some insights?
Yeah. Well, I mean, first of all, luckily it wasn't too early morning for me. It was 3 o'clock in the afternoon. So that's why we've got you picking up the tail end there in San Francisco. Yeah, but it was really good. It was really good. The talks maybe started off with Marguerite, who I've spoken to a lot. She's on our team, talking about fairness in AI, which was really good. It's a topic obviously she's really knowledgeable about and passionate about, and that always comes across, right? So there was a lot of really good chat in the Slack channel about that. So that was really good. And then I had a talk that I found really, really interesting with Romeo Kinsler about deep reinforcement learning, and about financial. He did an example of financial trading, which is really interesting because I've done the same thing myself. And it was kind of what I was kind of doing as a startup, or was about to do as a startup, when the whole market, cryptocurrency market, crashed in 2017, and hence why I'm at IBM now, right? and now I've learned even more about machine learning and AI at IBM, and so it's been fantastic. So it was really good, and learned about RayLib, or Ray rather, which I've kind of heard of, but I've never really had a chance to use. And he's saying it's really good for reinforcement learning. So I'm looking forward to playing with Ray and using that. And he's got a very good example. I need to find his notebook, because he was working through a notebook in his talk that was really good. And the next one, David Cardew was talking about stacked machine learning models, which is something I'd never heard of either. And until his talk. And so stacked machine learning models are kind of one step above ensemble models. And so you can take a bunch of ensemble models. So you can take something like a decision trees model and a XGBoost or something like that, and then you combine them together. And scikit-learn actually has that now as an option. So you can define that as like a meta model, and give it a bunch of sort of smaller models and get it to learn from there, which is really cool, because it's all the still same scikit interface. So it's just pretty much just drop in. So that was cool. I talked to Srinam Ranghavan, who's the kind of like the head of AI research, and so that was really good, kind of hearing his big picture kind of stuff about where things are going, and asked him a little bit at the end about Project Debater, which is really cool. So yeah, lots of really fascinating talks today.
It's
very, very interesting.
The different models there. I've noticed in recent times it's not so much the creation of new kind of neural network, but a combination of structure of these things, which brings out the kind of new and interesting results. And we don't know why it always does it. It's like, this is interesting. What more time goes into figuring out why the model works than getting it to work in the first place? Because we can try, we can tinker, we can poke and prod and get the results. I was like, okay, that's great. Why? The big questions of life also applies to AI, which is why does this do this?
Yes. Yes. So I see Peter, our next speaker. Peter is here. Hello, Peter.
Hi. Can you guys hear me?
Yeah. Yes. Welcome. Welcome to the show. Am I coming through to you? You can hear me?
Yes. I'm sorry. Just been having a lot of computer issues this morning.
No problem. We're glad you're here. And Sean and Matt, you're welcome to hang out. I'm not sure what the plan is here, but you're welcome to hang out here and talk to Peter with me. Or I know you also need to sleep. That's important too. So up to you guys.
Good night, John.
Right.
I'm gonna drop off for a bit, and but I'll be hanging around. So I might pop back later, but I'm gonna drop off for just a little bit because I've been on for a while. So yeah.
Likewise, my throat is raw. I've been speaking for 2.5
Oh my
hours.
goodness.
So I'm going to go and, neck a liter of water. But, good to talk to you again, Upker. It's always a pleasure. Peter, wonderful to meet your acquaintance. And have fun.
Nice, guys. Thank you. Great.
All right, thank you. All right, Peter, let's get started. So,
all right.
Just a quick introduction. Peter Wang is the CEO of Anaconda. Peter has been developing commercial computing and visualization software for over 15 years. So I'm so happy you're here. Lots of experience to talk to. We're looking forward to learn from you. Peter, you're also the creator of PyData Community and Conferences, which I love. I've given a couple of talks at the local PyData chapters.
Oh, good. Excellent.
And it's a fantastic community. It's there's the technology and the language and the frameworks and whatnot, but then there's a sense of community, which I have not, to be frank with you, have seen in other communities. So thank you for building this.
Well, thank you for participating. It is definitely the idea of I think the PyData community, as opposed to I think a lot of technology industry specific sort of things. We try to get people participating in it in a very we get people participating and really get the voice of practitioners, the voice of you get just it's such a authentic, I think, experience at any of the PyData conferences. And I really love, I mean, obviously with COVID now, we can't socialize as much, but prior to COVID, I really enjoyed going around the world and just meeting so many different people in so many different countries, all, trying to apply these really cool technologies.
Absolutely. And also thank you for speaking at the conference. Your talk on open data science meets the enterprise was really interesting to me on multiple levels, given my background, and I'll tell you more about it later.
Okay.
But before we get into the talk, for folks in the audience in the chat who are new to Python or to data science, perhaps, would you like to say a couple of words about Anaconda?
Well, I guess the only thing is just to reiterate to everyone that we are, as a company, Anaconda, we're known for, obviously, for making the Anaconda software distribution and all the Conda packages and all that. We've also made a number of open source technologies that people are starting to use quite broadly. But really, Anaconda is here to be a partner for people who want to adopt open source into the enterprise. We sell some enterprise solutions. We also have, quick starts and services and training that we do. So there's a whole host of things that we can do. We have partnered with IBM to deliver some of those software products, of course, as part of Cloud Pak for Data. And so we're really excited about the partnership with IBM. But yeah, I would just hope that people in the audience who love to use Anaconda, feel like they can come to us for kind of commercial solutions as they need in their business practice.
Perfect. So going to thinking back to listening to your talk, one of the things you discussed were the different myths, right, in data science in the enterprise. Before you went into the challenges, which was also very, very interesting. But going back to the myth, you talked about this concept of, or myth of, a unicorn data scientist. And I have a background in software engineering. I went to school for software engineering and a little bit of math and data. And it was very intimidating for me to come into this sphere and this role. And even now, if I see certain job requirements out there, Peter, I think the funny one I saw was 15 years of TensorFlow experience, which kind of predates that framework.
That'd be fairly impressive. Even among 3 people, right? That's 5 years each. That's actually quite a lot.
That's quite a lot. So can you talk to a little bit more about why that, or first of all, the sort of the current landscape in that role, or for that role, and why you think that's a myth, and how do we address that?
Well, honestly, I think recruiters try their best, but the thing about the data science role, unlike I think some other more like software engineering, it's been around longer, right? We have more experience in knowing which kinds of technologies or frameworks code for certain kinds of skill and expertise, because the data science, machine learning engineer, whatever term you want to use, kind of in this whole zone of stuff that we do, because that's relatively nascent. I just think the recruiters, they're trying their best. It's like, well, is it a framework I can use to screen out, the riffraff, or is it this thing or that thing? It's an unenviable position to be in, because it is hard. As anyone who's tried to hire for data science positions, that is an unsolved problem still. And I think it will be actually for quite some time in the future. We don't have a good way as a emerging profession. We don't really have certifications. We don't really have like a standard curriculum that everyone uses. I think this is a problem we have to solve. The industry has to solve. It's not a problem we're going to be able to route around any other way. But I would encourage people who are hiring managers, let's say, trying to hire data scientists, I would encourage you to look more for what people have done and less for just what things they put on a CV or on a resume, right? And I do think going to, for instance, community events like PyData, going to talks, or going to these kinds of things, that's actually a really good place to recruit from, because at the end of the day, for a data scientist to be effective in their job, they have to be good at communicating. So if you can find someone who's good at communicating their ideas to their peers and fellow practitioners, that's a good proxy for them being able to communicate well to business stakeholders, right, in their work. So yeah, just a couple ideas there, but we'll get it sorted out, I hope.
I like what you said about in your talk. You had a slide on becoming a data scientist versus applying data science in my current role. And I think this came out of a survey where you were asking people how they're using data science. And so in that regard, even though we have software developers or database folks, even PMs, line of business users, would you say data science is sort of touching every role, and it's not the sole role of one person?
Yeah, I think you will still have people whose job titles are. So that's why I say in my slide, data science isn't just a job. It is a literacy. Because, I mean, some of the roles you mentioned, right? The PM. If a PM doesn't understand, a product manager, if they don't understand the data science processes that were used to give them the ideas about their product, right, and feedback about the product, then someone else is doing their thinking for them. Right. And likewise, even for like a data administrator, if they don't understand the nature of why certain data sets are being pulled or getting, denormalized in some way, at some point, they do their jobs better if they can understand the context. So I do think that a lot of different people are going to learn some basic data literacy, but there's still going to be, of course, data scientists that is their full-time job, is to be, just that. I do think they will bifurcate into exploratory mode and production mode data scientists. The latter being more maybe what one would call a machine learning engineer. That's where software engineers probably will matriculate more into that role, just because good software engineering principles do apply to building robust AI and ML pipelines. So.
Right. You also talked about one of the challenges was sort of understanding the essence of data science, and you brought in, how the world is changing to be more of a data-driven world and environment. And how does, we've had this agile as a paradigm, as a methodology in software development for a little bit now. How do you see that fit between data projects or data science projects and the agile methodology?
They're related. It's interesting. This is actually the second time I've had this conversation about agile and data science, and just today. They're related in the sense that you want to be able to quickly iterate, and the speed of iteration is critical to the quality of the product, right? It's like it's sort of this counterintuitive thing where if you build a car by building the pieces faster, you get a better car than if you take a longer time to build something kind of in this non-iterative approach. So that's a counterintuitive thing. It doesn't apply to every walk of life, but certainly in software engineering, it's true. Because I think in software, what happens, the reason why Agile works so well in software is we discover the terrain of complexity. We discover the kinds of trade-offs we need to make. We basically are vetting our assumptions every step of the way as we're building, and that incrementalism is really good. With data science, it is also a very incremental thing, because you find things in the data that you didn't know. You find, you'll test assumptions, and then that will let you refine faster. In both cases, it's running an OODA loop faster and faster. But in the case of in the software, where does the surprise lay? The surprise lays in the intrinsic complexity of software and information systems, and maybe unknown or unforeseen requirements that you didn't know you had underspecified. In the case of data science, agility helps you uncover quickly unknowns in the data itself, right? So in both cases, you're absolutely right that the agile methodology as an overarching principle applies.
Right. And then I think it also ties back into what you said about exploration versus production. And I feel like even in the workshops I give, right? So I'm a developer advocate with IBM. I'll give a workshop on perhaps a framework in software versus data science. Data science is always running a cell, changing something, see what happens, break something, put it back. And so I couldn't agree more with the exploration bit that goes more with the data science aspect. And I also, challenge number 2 that you described in the talk was the role of Python and how that's changing in the enterprise over the last couple of years. I have personally I've been with IBM for about 12 years now, and I've seen, even in IBM going from a very, at least my roles were a lot more Java-centric enterprise, J2EE, EJBs, and all of that, and going that from to like Node.js, more of Python, more on the agile stuff. How would you describe your experience looking at the role of Python and how that's changed?
I think Python has had such a unique trajectory. I've been using it since 1999. And I felt like I got on the train late at that point because there were already so many smart people doing cool things. Now I realize I sort of got in ahead of a lot of other people in the world. But I think where the really unique and interesting thing about Python is that whether you're using it to write some cheesy little system administrator script, whether you're using it to build some cool, interesting little prototype thing, Python fits the agile mindset very well, right? Because you're sitting there, you're trying, you're like, how do I make this work? How do I build the simplest possible thing so I quickly iterate? The fact that it has a REPL, Python is the thing that actually popularized the REPL in recent decades. Nothing else really had it like that until Python was just like, oh my God, this is so nice. I can try stuff, it's right there. So I think that the REPL essentially and the sort of emphasis on readability, those things combine to create a modality, like a mode of using Python that's very iterative, quick and dirty. I'm just scripting. I'm just doing X, right? No one sits down with like a large, J2EE code base with this giant XML like structure of all this other stuff and says, I'm just going to do X quick and dirty. Like there's no quick and dirty with that.
Right.
There's, it's generally a slog. And so with Python, you get in this mentality of like, this is a thing I can pick up. It's like a little screwdriver. It's a lightweight tool. I should just be able to get in there and do this thing. Even if it's not the right tool necessarily, you just try it, right? So I think that scripting mentality then evolved into the data science. When that mentality got picked up by data scientists, it was really good because it encouraged them to write code, play with your data, write code, try to plot this, look at that. It gets you in this very agile mindset, which is awesome. But Python is strange in that you can also go and build very large object-oriented structures with incredibly rich, advanced object-oriented concepts in it. You can also do that. And I think the fact that it is a blurred line between these things makes it, unfortunately, it makes teams have to really get disciplined about how they're using Python, right? Here, we're just doing data scripting, some crummy little bits of things in some notebook cells. Here, no, we're really doing something serious. We really need to build these unit tests, think about the class hierarchies and whatnot. And so I think we just, as long as practitioners, if we keep these two modalities separate in our minds, we can be fine. Anyway, that's kind of how I see it. Sorry, you're still muted. I think you're muted. It's very strange. I can't hear you. Can you hear me?
Oh, there
you are.
Peter,
yeah.
Can you hear me?
Yes, now we're good.
All right, you are not coming through, so let me try something real quick.
Oh, I'm not? Okay.
Sorry about this. Let me put these back in.
Mike's, well, you can hear me now, right? Can you hear me now? On the Mike on the chat says he can hear me.
My microphone, just to make sure.
Yeah.
All right, can you hear me now?
I can, yes. Hello?
Okay, I cannot hear you, so that's a problem. Okay, what happened? Oh, yes, Peter, you can hear me, but for some reason, my headphones are not picking you up. I'm not sure why. So just give me 1 second. All right. I just switched to the MacBook speakers. So
okay.
Can you say something?
Yes,
okay.
Testing. Can you hear me?
Perfect. Thank you so much. Sorry about that.
No problem.
All right. So let me ask you this. You talked about some of the opportunities that come with these challenges, and I liked how you said businesses, the main goal still remains the same. Businesses are still looking to lower costs. Businesses are still looking to get new customers, customer retention. The problems have remained the same. And so I guess my question is, what has changed around, like in the environment, that would enable for these new opportunities to come up, and how do we take it, or how would enterprises and companies take advantage of that?
I think what fundamentally changed in the landscape is really simple. It's big data and cloud, the convergence of both of these things. And so big data, which we sort of stopped talking about, but certainly many years ago, that was all the rush, and everyone's like, oh my God, like we have all this big data, the 3 Vs, 4 or 5 Vs, how many Vs you want, but volume, velocity, variety, certainly that created a problem for people. But in that data, which, I think the variety part of big data was the real problem for people, because it did not fit within your standard SQL database. And therefore, however you stored it, you had to figure out new ways to store it, but you can ask more interesting questions than you could ask with SQL. And that's why Python and R really got their start in the data science aspect. Right. But that would all kind of be irrelevant if it took you forever to compute on it. The fact that you can rent and really, have a bursty compute infrastructure that matches the exploratory needs of the data scientist, having that variety also be mated to a flexible compute architecture and structure and very, very cheap storage. You put all that together, and now you have the magic, right? So now you can actually do something very interesting that could not be done before. So this double disruption is something identified in 2012. As when we started the company, Anaconda, we recognized that this double disruption was going to accelerate the adoption of tools like Python and R, which can ask deeper and more interesting questions than you could ask with SQL on a much larger set of data. And so businesses now have this incredible opportunity. And if they don't seize it, what's going to happen is startups will overcome their data advantage, right? Because the businesses have a lot of legacy data. Inside that data are latent models of customer, supplier, whatever, logistical behavior, kinds of things that they can model out. But startups don't have that, but startups can move faster, right? They don't have to convince a whole line of VPs up the stack. They need to change what they're doing. So this is the grand race in every single sector, in every industry. This is the grand race we're seeing play out right now.
Okay, no, that's very interesting. I know we are sort of running out of time, so one last question on since we have you here, on a very high level. Open source has been such an important part, an integral part of data science and the community in general. How do you see that changing in the enterprise world moving forward in the next 5-10 years?
Wow. Well, yeah, 5 years is about as long as I'm willing to comfortably make any predictions. given look, 2020, right? So I'm not going to go to 10 years. Right. I will say, well, I can make I will make one prediction about 10 years, which is that we are done. We're going to have more variegated computing infrastructure. So we're just sort of like coming out of the end of 30 years of x86 plus like Windows kind of dominance. I guess Linux kind of got in on the server side for a while, but we're coming to the end of that. The hardware variety is going to be massive. Sensor systems, edge compute, all sorts of things. So software developers had it easy for 20 years because we just expected, the chip makers to just give us better performance all the time. No longer will that be the case. We're going to be building 10 years from now. I know for a fact that the people who are making good money building information systems are going to be reasoning holistically about algorithms, data storage, latency and bandwidth between all these different things, and the algorithm, like all of it together, right? So value dependent, data dependent computing is the order of the day and will be the order of the day for the next 10, 15, 20 years. Now, with that being said, the reason why open source is such a critical piece of this is because open source software is now the underpinnings of how all this stuff works. Businesses are going to have to get comfortable using it. They can use vendors like us, like Red Hat, IBM, others to give them the assurance that they feel comfortable to bridge the innovation of the wild open source Wild West to enterprise needs. So we can do that. But I think that the businesses, basically, this is not going to go back to I can call up a vendor and just buy a proprietary pile of bits anymore. It's going to be, I need to go and use whatever is the cutting edge technology. And you know what? The good news is that cutting edge technology is yours for free to try. No one's going to stop you. You fire up a cloud instance, you slap a bunch of open source on it, self POC, right? Now, once you've got it working, you like it. If you want to support it, you need to go talk to Anaconda, talk to IBM, Red Hat. That's great. then you take a lot of the risk off the table. So I think that enterprises need to change their thinking about this a little bit. If they still believe that they can just buy some off-the-shelf thing, they're just gonna get left behind, because all of their competitors and all the startups that are funded to try to eat their lunch, they're not waiting, right? So open source really it's interesting because it's commoditized the cost of the software. It then basically lays the groundwork for a much faster competition, and it's accelerated the innovation pace for the model layer and the algorithmic layer. So yeah, it's very exciting times. This is really once in a couple of generation kind of phase change that we're seeing in the industry.
Absolutely, absolutely, and I'm very happy and lucky to be part of a company that not only endorses open source, but it is a big part of that as well.
That's right. Yep.
So, Peter, I thank you so much for spending your time here with us today. I'm going to post the link for the talk, so if folks didn't watch it, they can go watch it again. And I again thank you for bringing all the experience and learnings to us. It was
my pleasure. Yeah, thank you so much for hosting and having me on. This has been great. It's nice to meet you.
Bye bye.
Bye bye.
All right, so I know we have our next speaker in the backstage. He'll be joining us pretty soon here. Hello. Hi, Francesca.
Hi.
How are you?
Good.
All right, so I know we have a shorter time frame with you, so let me introduce you to our audience here. So Francesca is an IBM fellow, AI ethics global leader working in IBM research. She's an AI scientist with over 30 years of experience in AI research, on which you have published around 200 articles in the top AI journal and conferences. I've got like 3 more paragraphs on what you have done, so I'm not going to go into that. This is amazing. Thank you so much for being here, Francesca.
You're welcome.
So I know you talked about I went through the talk this morning on AI fairness and ethics in AI. Thank you for sharing that with all of us. I myself, I'm a developer advocate with IBM, and I give talks on our AI Fairness 360 framework and just the topic in general to local meetups and things like that. And I'm really surprised that my first question usually is how many people are aware of this topic, and some hands do go up. And then I ask, okay, so how many of you are actually pursuing this or actively working to detect bias and making sure your models are fair? And a lot of hands then go down. And I'm curious, in your experience, what does this look like when you talk to clients and other members in the industry?
Well, that shows that there are many steps that need to be done and many dimensions that you need to consider to actually making sure that the AI products or services that are being built have the right properties, for example, about AI fairness. So building the toolkits, like, for example, the libraries that are contained in AI Fairness 360 is certainly helpful for developers to share code, discuss, share data sets, test results, and so on. But it's definitely not enough, because the developer community needs to be trained to understand what is this fairness bias. There are more than 20 definitions of fairness. So how do they choose the one that they need to check, they need to achieve the right notion of fairness in the product that they're building? So that's the first question. And then, so they need to be aware of their own biases, because of course they can inject these biases, not just in the training data, but also in any decision that they make during their AI pipeline. Okay? So they need to be aware, and usually this is done by, again, educational, reskilling, training, but also possibly by some diversity in the teams, so that people can tell each other, oh, look, but this is biased. Your way of introducing bias, while my way is a different one, and so on. And then you have to build a very clear methodology for injecting this bias, for example, detection and mitigation into the AI pipeline, a methodology, and then you have to make it very easy for developers to include it in their normal everyday job. And then you need to really listen to the challenges that they have in changing these processes. So AI ethics is still something that is kind of an add-on to the usual AI pipeline, while, for example, other things that were an add-on now are completely integrated, like, for example, security or privacy, okay? So it took some time, but now it is part of the pipeline, okay? And so this is not true yet for AI ethics. So developers need to understand what to do, how to change what they have been doing to include, for example, bias detection and mitigation. So, and then there is also, they also have to put in place within a company right incentives and evaluating procedures to make sure that these developers, they spend, for example, more time in developing a product because they do bias testing and mitigation, for example, they are not evaluated negatively because they took more time than somebody else that did the similar project, and it took less time because it didn't introduce any bias. So bias testing and mitigation should be necessary, just like security is necessary, just like the handling of privacy is necessary. So you also need an incentive and you know, from the manager's point of view, you need a commitment that this is necessary and clearly communicated to the developers, and they will not be evaluated negatively because some other metrics, like, for example, the speed at of development goes down because of adding these other things, you know, like these other things are necessary. So there are a lot of dimensions that have to be put in place where the toolkits are useful, but are just really just the beginning of this story. So that's why I think many people say, yes, I know about fairness, about this, but then in their everyday job, the company still didn't get to maybe to the point of putting in place all these dimensions so that it's integrated in the AI pipeline.
I'm getting an echo as well. Okay. That's fine. I saw a tweet that you put out saying technical solutions should be complemented by many other activities, including education and governance. So that, I think, kind of summarizes what you just said.
Yeah.
Okay. So we do have a question from the audience, and the question is, how do you balance open source and ethics with certain applications of AI? So I think it's sort of we need a little bit more input from this person too. But did you have
an ethics? So because maybe they think that if it's open source, then it's difficult to make sure that it respects some ethical guidelines because it's open source. There is no control on how it is developed. So how can you be sure that it's not introducing bias and so on? Okay, I think that's an interesting question because you're right that open source AI libraries are, you know, getting more and more tractions, you know, among developers, and also IBM is, as you say, is releasing things in open source like this fairness. There is a similar one for explainability. You know, so there are open source toolkits, but I think that what we are advocating is also a form of transparency by documentation. So we hope that whoever is using a system asks that, yes, you're giving me this system, but you have to tell me what you have been doing while developing this system. What's the intended use? What's the accuracy, which is the minimum that you can get, and usually you get, but also what is the kind of bias that you detected and you tried to eliminate? And did you eliminate it, or what is the result of the test of on that form of bias? So all these informations are very important to make sure that whoever receives this and uses this system knows what are the real capabilities and limitations and risks, possibly, you know, in using that system. So then I understand that in an open source environment, it's a bit more difficult to enforce some guidelines and to, but I think that, I mean, from our point of view, I mean, when we develop things, of course, I mean, I understand that one can say, okay, I'll take my own, I'll take some available off-the-shelf open source tools, and then I put together this solution, and then I use this solution. But then this solution is used where? In a company usually, right? So a company has to be, you know, compliant at least to the laws, for example, about non-discrimination. And a company usually also has to, I see that more and more clients are asking us, what are you doing around bias? What are you doing about discrimination? So it's also a pressure for whoever is going to receive that service or that product, that it becomes a competitive advantage to show that you are taking care of these issues in a reasonable way.
That's a really good point. So it may not be on the creation side, but it might be on the consumption side that there is pressure to adhere to these policies. And you alluded to in your talk, there was a slide I saw on fact sheet project and fact sheets.
Yeah, that's the idea of the transparency. So the fact sheet is basically a lot of documentation about things that have been done during the development of the product or the service. And so this idea of transparency by documentation. And in IBM, we use this concept of the AI fact sheet, but also Google and Facebook have similar ideas. One is called the model card, one is called the data sheet. So in fact, we are in a project together comparing the different approaches. And we're working together within the partnership on AI, where all of these companies are partners. So the idea is similar. You know, the concept, maybe the incarnation of the concept is different, but the idea is basically to build transparency by documenting what has been going on during the development.
That's wonderful. Thank you. And I know we just have a couple of minutes left. I wanted to get your take on what kind of things you're currently working on in IBM Research that you can talk to us about, sort of what's coming, what's exciting, what's new in this field.
Well, I mean, now I'm trying to, I have a project which is in the so-called exploratory science program. So it's a very longer term project than other projects in IBM Research. And this is a project that tries to give AI some of the capabilities that human beings have and that AI still does not have. For example, the handling of causality, causes and effect. And so if AI does not really, cannot really understand well the notion of causality, but only can derive correlations from data, then yes, it can be very good at making predictions, of course, but it cannot be very good and useful in suggesting actions for interventions, because we cannot understand, you know, what if I do this action, then what is the consequences of that action? So if they cannot handle causes and effect, this is not something that is really can be supported by AI. So notion of causality, handling of causality, ability to adapt from one environment to another one. We are very good at that. AI is not very good at doing that yet. So how can we, these are two examples of capabilities that human beings have, and then the AI still does not have. AI, of course, has other capabilities that are better than human beings, but the idea is to bring what is good in human beings. And to do that, we are trying in this project to understand the causes of these capabilities in human beings by looking at cognitive theories of human decision making. So we are going outside AI to see what we know of how humans make decisions, what causes these capabilities that we have in human beings. Like, especially we looked at this cognitive theory of human decision making that is called the thinking fast and slow. You know, like thinking fast is like intuition, reaction, unconscious decisions. So we use it more than 90% of the time. Thinking slow is like when you are very accurately considering all the consequences, all the pros and cons and so on. And usually it's more correct. And we use it very seldom, but we are more correct. So, and this interplay between these two capabilities allows us to do many things, also in the ethics space, and we are trying to understand what causes this behavior, these capabilities in human beings, to transfer them to a completely different platform, because our platform is our body, our mind, our brain, which in the completely different platform, which is a machine that is very different, of course, but it would really be much more useful in many respects, also in terms of AI ethics, if it could have this capability. So, for example, in terms of being able to explain well how it goes from the input data to the outcome of the machine.
Mm-hmm. No, thank you so much. That sounds very much like a sci-fi movie, or I guess the future is here. It's good to know that you're working on all these different efforts. Again, I know we're a little bit over time. Let's see if we have one more. If you have time for one more question, there is one from Alexandru, and they're asking if we have limited amount of data, how do you strike a balance between accuracy and fairness? Is there always a tug of war, and how do we address that? If you could answer that, please.
Well, I mean, there are a lot of researchers also within IBM research that are trying to understand how to help machines to learn with less data. Because it's true that in some scenarios, you don't have a lot of data. Or when you are tackling a new problem, you don't have a lot of data about how to solve that problem, because the problem is new. By definition, you don't have a lot of data. So you have to really help machines to learn with less data. This is another one of these capabilities that human beings have and machines do not have. And then if you do that, then really this trade-off between accuracy and fairness. So the mention was the trade-off between accuracy and fairness. To me, the trade-off is even more than, I mean, it's even more expanded than that, because even within fairness, there are so many for example, protected variables, right? You don't want to discriminate on gender, or age, or on other things. So, and by maybe trying to remove one discrimination over one variable, you are increasing the discrimination of the other variable. So even within fairness alone, you may have intersectionality issues that, lead you to really understand what's the best trade-off. So the issue of trade-offs between different fairness or other properties, accuracy, privacy, for example, or other one, is still very central. And again, because probably you will not be able to minimize all these criteria, all these properties that you want, the possibility of being transparent is even more important, because you say, okay, I try to do the best trade-off, and this is the trade-off that I found. This is the best trade-off that I could find. This is around fairness, this is around privacy, this is what I got around accuracy, and so on. So again, the transparency is also important also in this respect.
And I might imagine the trade-offs also may be different based on which stakeholder you talk to, what the context is. So there's a lot of there's a lot of things around the data and the numbers themselves. So Francesca, I know we're over time. I want to thank you so much for spending time with us today and giving us a landscape of what's going on in this field. Very exciting stuff. Thank you very much.
You're welcome. Bye-bye.
Bye-bye. All right, so I am waiting for my next speaker who's here. Hello, Patrick.
Hello, good afternoon, sir. How are you?
Good afternoon. I'm doing well. How are you?
I'm doing very well. Thanks for having me on this, very interesting discussion. So I really enjoyed the conversation you had with Francesca.
It's always fun to talk to you, Francesca. She's she's an IBM fellow, and her thoughts are. I sometimes say we are sort of in the weeds, and to hear her talk about the forest, it's kind of nice.
Yeah, definitely.
All right, so let me introduce you. So Patrick is a dear friend of mine, also a developer advocate in IBM, and Patrick works for a team called Codate, Center for Open Source Data and AI Technologies. So Patrick, I know we only have 15 minutes. Do you want to give a quick shout out to the team, what your role is, what the team does, and then we'll dive into an open source project that you're part of?
Okay, sounds good. We at the Center for Open Source Data and AI Technologies, we are a group of about 40 developers and data scientists who are contributing in various forms to open source projects, predominantly focusing on AI projects. So your audience probably is very familiar with Apache Spark, right? If you want to do data analysis or machine learning at scale, that's when you would use Spark. We're also contributing to the major deep learning frameworks, right? TensorFlow comes to mind, PyTorch. So we have developers who are contributing code there or updating the documentation. The AI Fairness project that Francesca just mentioned, right, is one of those open source projects that was started at IBM. But we have other projects that, for example, focus on open data. I'm not sure if you've talked about this earlier during the day, because I just recently joined, but open data is becoming increasingly more and more important, right? Because in the past, it used to be that as an enterprise, you kept hold of your data, right? So nobody else could use it. And of course, that was stifling innovation, right? If you share your data, different people or institutions can analyze the data and derive new information that other individuals or institutions might benefit from. And so that's one of the projects that I was heavily involved in during the past couple of years. Similar project where we were trying to establish an exchange for open deep learning models. Right. So if, for example, you are a data scientist, a developer, you just want to use an existing model to, for example, identify objects in an image. On that exchange, you could simply download such a model. It was wrapped in a Docker container, just spin it up, and it was ready to use. So if I have to describe kind of the mission of our team, we're just trying to simplify the AI lifecycle and make it more efficient at an enterprise level. More recently, and this is what has me now really excited, I've been focusing on a project called Lyra, which is part of the Jupyter Lab or Jupyter ecosystem. Pretty sure at least those among you who are practitioners of data science have used either the classic Jupyter Notebook interface or have already used the Jupyter Lab integrated development environment. And so what we are doing there is we have created a set of extensions that simplify your day-to-day activities.
No, perfect. I've been pasting links like crazy in the chat as you've been talking about all of these amazing projects the team is involved with. And you gave us a brief introduction to Lyra. And so is the audience for Lyra people who currently are data scientists and work with Jupyter Notebooks and Jupyter Lab? Is that the primary audience? And also talk to us a little bit about the need for Lyra and what pain points, if any, it's trying to solve.
Okay, yeah. So probably the audience is fairly diverse, right? I mean, obviously it's going to be data scientists, right? So whether you are a beginner or a well-seasoned data scientist who's been working in the field for many years. Jupyter Notebooks have really become the de facto standards, right? When it comes to, for example, performing data analysis, creating models, tuning models, at least when you're getting started, right? And with Lyra, what we are trying to do is we are trying to extend this environment that you would traditionally use with productivity features that just help you with those day-to-day activities. Let me just give you a couple of examples, right? For those of you who have used Jupyter Lab before, let's say you wanted to share a project that you were working on. So let's say Upka and I were working on a project. Upka's working on a couple of notebooks that are of interest to me. Traditionally, if he wanted to share those notebooks with me, we would have to upload it to some cloud storage, or God forbid, email it to each other, right? With the integration for GitHub, what we can now do is we can share those assets in a seamless manner, right? And then, of course, we can take advantage of all the Git features that are out there. So, for example, versioning support, right? Very important. We tend to not think about it really when we are getting started, but over time, of course, the notebooks are changing, right? And so I might want to retain a history. Also might want to have the ability to compare my notebooks, right? And then with the GitHub support that we have integrated, you can actually do this in JupyterLab without ever having to exit the environment.
I cannot imagine resolving conflicts in a IPYNB file if I was collaborating with other people. So yeah, to me, that's just that feature alone is really amazing to me. Yeah, and definitely, and it's one of those features that I'm really excited about because it's so universal, right? So it's not just a problem that applies to data science, right? It applies to development in general. So it was just a question of time until there was really a need for this kind of support. But I mean, just going beyond version control, right? Think about reusable code, right? In software development, we try to reuse as much code as possible, right? And then the same kind of paradigm applies to notebooks, for example, right? You create some code that does a visualization in one notebook. You might want to reuse that code in another notebook, right? And in Elira, we have a code snippet editor, which allows you to actually do this, right? And then share those code snippets across multiple notebooks. And then probably last but not least, so even though there are many more features, the support that we have for pipelines that support the ML workflow. So let's say if you're thinking, let's say you are a new user, right, an entry-level data scientist, and you're just getting started with, let's say, a little project that you downloaded from Kaggle, for example, the Titanic data set, right? You would go through your data analysis, you would try to identify and create a model, you would try to train that model, and then tune this model, right? So all these individual tasks you need to perform, and you could do those in a single notebook. But this doesn't really scale, right? Because once you have to deal with larger data sets, once you have more compute-intensive operations that need to be completed, you can't really run this locally on your machine anymore. And with the pipeline support that we have, you can actually do this on the cloud using Kubeflow pipelines and then Kubeflow in general. That's so interesting because it reminded me of what Peter, who was the first speaker I was interviewing earlier today, said about what has changed in the recent years, or what is going to change, is the availability of cloud computing and scalable systems that we can now use. They're on our fingertips, so to speak. So yeah, thank you for bringing us back to that. So before I let you go, I know we have a minute left. Tell us how folks can get involved with Elira. What are the different ways to help or consume the solution? Okay, yeah, and sorry for there's so much I can really cover, but so Elira is an open source project, right? So it lives from community contributions. A contribution can be a bug report, enhancement requests, right? It can be contributions to the documentation, always very welcome. So if you're interested in learning more about Elira, if you just Google ELYRA, it's going to be one of the first hits. It's a public GitHub repository where we have tutorials and everything that help you get started. Yeah, we have weekly community meetings where people can ask questions or make suggestions. So we're very welcoming. And of course, if you have any questions, you can reach out to us at any time. Wonderful. Thank you so much, Patrick, for spending time with us today, telling us more about Codate, telling us more about Elira. It's always lovely talking to you. Thank you very much. Thanks for having me. All right, so let's, Gregory's here. Hello, Gregory.
Hi, Avkar. How are you?
I'm doing well. How are you doing?
Doing great. Thank you so much.
I feel like taking a breather, and then they keep throwing the screen at me, and I'm like, wait. Yes. But you know, I'm kidding. I'm really happy you're here today. Let me do a little bit of an introduction. So Gregory is an architect and a research software engineer at our TJ Watson Research Center in Yorktown Heights in New York. Gregory has, by the way, Gregory, do you go by Gregory or should I say Greg?
My friends call me Greg, so that's good.
I'll be your friend for today.
Good.
Okay.
Sounds good to me.
So Greg has many years of software engineering and artificial intelligence experience in both industry and research, and has architected and built several major applications for critical business purposes. So a lot of experience coming here talking to us. I'm so glad you're here, and thank you for spending the next 30 minutes with our audience.
Sure, it's my pleasure to be with you. I'm excited.
So I was at your talk. It was a very interesting, lovely talk. I was very curious about the one of the first slides. The caption was AI building AI. For people who were not at the talk, can you elaborate a little bit more on that concept and what you meant?
Sure, I'd love to do that. Yeah. So basically, well, Auto AI is kind of the product that I've been working on. I'm in the research group that's been behind Auto AI, and yeah, essentially what we mean there is that there's a lot of automation that can be done at the data science and machine learning pipeline creation level, and even the whole Auto AI process can start growing, we think, into the AI lifecycle. So basically, adding automation on top of this work to create AI and machine learning pipelines. So that's essentially what Auto AI is. So we basically try to automate that experimental type of process that the data scientist typically does. And we try to make it a very interactive experience as well, so you have AI building AI, but also it's very collaborative with data scientists or business analysts and users that basically can interact with the results of Auto AI and set the configurations and just work together to build quality AI pipelines.
The first time I created a Watson Studio service, and I added Auto AI experiment to my project in Watson Studio. I was just blown away by how much it was doing for me. Which also, when I say that to people, that brings another question: is Auto AI replacing data scientists?
That's a good question. No, not at all, we think. But I'm glad to hear that you felt it was doing so much for you. I think it's not at all replacing data scientists because there's just such a need really for data science. And as businesses decide that AI has to be a part of what they're doing in the future, it turns out that there just aren't enough data scientists. So Auto AI can be a place where businesses can invest in AI without having to maybe invest in a full data science team. And then also, I think we see a key use case is with the data science community, because being a data scientist, I think, is a difficult job that requires a lot of iteration, a lot of exploration of different kinds of models. Different data scientists usually are comfortable with certain models. They might have an expertise in that area, which is great, but maybe they're not so familiar with other models that are coming into the picture. So I think it can be something that also helps data scientists, and really also I think it can be educational in the sense that it can help create more data scientists, because when you have an explanation of what data science pipeline looks like, and you can really start to see what data scientists do, which I think the Auto AI experience can give you, it enables you to learn, essentially. So you can start tackling different problems, and people that might have said, machine learning, it's too complex for me, I can't figure out what's going on there, they start to get a little bit more insight into what's going on, and maybe they participate in a prediction problem of their own or a challenge of their own, or, like we have this Call for Code, we're actually hosting a data science challenge. So it's an opportunity for people to start getting more involved in machine learning and AI.
That's actually really good timing, because somebody, Somalai in the chat, said you can see a little bit about what Greg is doing with the Call for Code Spot Challenge for wildfires. So can you tell us a little bit about the challenge itself and how Auto AI can help, as a starting step, or even boost your productivity as a data scientist?
Yeah, absolutely. So we've, I think this competition is just launching, and basically the Auto AI system, we have a walkthrough. If you look at the main page there, you can click next to my talk on the walkthrough to see what one of my colleagues, Arvind, has put together, basically to show you how you might begin to use Auto AI on a problem like this. Now, the problem that we're looking at here is a wildfire prediction problem, which is more of a time series type of problem. And the current version of Auto AI is more around classification and regression problems, even though time series is coming very soon. It's not there yet. But in Arvind's walkthrough, what you can see is how you might begin to cast this type of time series problem as a regression problem, which is one that Auto AI can solve. So basically, when you do that, you need to start looking at the data set and figure out how can I sort of aggregate the different time series features into things I could predict, things I could use to predict. And so in this competition, we're looking at predicting, the area of wildfires in Australia for February, next February, and you basically have to predict before February what you think they're going to be. So when you treat that as a regression problem, you basically have to start aggregating features and you could look at maybe the last February, how the temperatures were, and predict based on that. And that's what Arvind kind of shows in the walkthrough. But then once you get into that, sort of see that Auto AI is generating models, you can then also start to tweak the data set and work on it yourself to figure out what else could I add? Or maybe do I want to look at what the data is going to look like the few months before February? What kind of features do I want to expose there? So that data preparation step is something that I think the competitors can try to do a better job with. But then once they put that into Auto AI is going to give you what we think the best model is, what some of the best features we're able to generate from that model. And you can either use those models directly or use them to inspire more ideas. So I think that's kind of how I see where Auto AI can fit with this wildfire prediction challenge. And I think, it's just, even if you end up building your own model completely from scratch, it's kind of nice to have a baseline. It's nice to see what, something that says, okay, this is what a good score might look like. This is what a decent score might look like, whatever the case is, give you an idea of where you can improve.
Yeah, no, that's really interesting. One of the internal hackathons at IBM, there was an AI hackathon that my colleagues, my friends, and I took part in. And the data scientist in the group, he lives in Italy, and as a team, we used Auto AI for just that, for doing the benchmarking purpose. And then what he was building, we tried to pass that in terms of the different evaluation criteria. But it gave us a solid first step to go from.
Yeah, and that's so important. And it's something that even very many experienced data scientists don't always realize, especially in these competitions, because in a competition, usually you submit your result and you see your score on the leaderboard and you start getting excited. You try to get your score to go up the leaderboard, and you're just using primarily the leaderboard as the way to evaluate. And that's really a mistake for any data scientist, because you should spend the first week of the challenge or whatever it is to figure out how can you create a local environment that's stable. And I think Auto AI kind of is in that direction, because we already have cross-validation built in, different metrics built in, and it's going to give you a baseline that you can't necessarily question. It's going to be something to start from. And yeah, that's really important to get that evaluation criteria set up. I've seen challenges where sometimes people it's called overfitting basically to the public leaderboard, and then at the challenge ends, and then the people that were overfitting drop like all the way to the bottom of the leaderboard, because it turns out they were just overfitting to this public data set, which is what the challenge was using. And then when it actually got to the real data, their model wasn't robust enough to work over a period of time. And so, having a solid evaluation criteria like you can get with Auto AI is going to help you there.
Okay. Well, this is so exciting. You're giving us these little tips to use in competitions, and not just talking about Auto AI. So thank you for that.
Sure.
Sharing insight. Another question, Greg, that I get normally with something like Auto AI, if it's doing a lot of heavy lifting and assisting you in your data science projects, can you talk a little bit more about transparency and control, right? So as data scientists, maybe we want to have a lot of control over what goes into the system and how it behaves, versus a click button where stuff is happening for me. How do you address this concern in the solution?
Yeah, that's a great question. I think that's probably the most important thing and one of the things I like and that we want to continue to do better with Auto AI is how do we make sure that it's interactive and explainable and makes sense. So one of the things that we're proud of in the current Auto AI is this generate or save as notebook feature. So basically in the Auto AI run, you get a leaderboard and it has, you know, the top ranked models that Auto AI thinks might work well. So if you click on the right side there, you can save as notebook and generate a Jupyter notebook that has the code for the model. So you can see what are the hyperparameter values that for the model that Auto AI found, and also what are the feature transformations that Auto AI thinks will work well, and what are the data pre-processing steps that Auto AI took. So this really is something that data scientists have been positive about. We have a lot of research that shows that they like this feature. And I think it really does kind of get at where data scientists are, because if you look at how data scientists typically work, they're not like a standard development team that would be working in an IDE with Git version control and you can kind of trace and track everything. They're more, you know, in a notebook, trying to test, trying to experiment, trying to see what works as fast as possible, trying to get results and work in these notebooks. And, you know, if they find something that works, they're going to, in the end, maybe find all the things that work and aggregate them together, and then that's their model. So it's a little bit different. They like to work in Jupyter, so we like generating these notebooks. And they like, I think, the freedom of kind of trying different ideas and experimenting in different ways. So that's something that it sounds like they've liked. We want to continue with more in that direction. There's also that notebook would give you the ability to see what Auto AI did and potentially reuse it elsewhere. Also, the dependencies of that notebook are available for free, downloadable and installable using pip, like in the PyPy Python module library. So end users can just go try that and try different things. And then I think also, yeah, sorry, go ahead.
I was just going to ask you about the libraries. Are these libraries interfacing with Auto AI as a solution, or the models? Can you elaborate a little bit more on these?
That's a good question. There's two notebooks right now. One which and that's not the one I was talking about, but there's a notebook that you can use to interface with the model in Watson Machine Learning. So if you've deployed the model and you want to experiment with it, or you want to just tweak it in WML, you can do that through that notebook. The other notebook that I was talking about actually has no Watson Machine Learning dependency. It just has this dependency on this Auto AI libs package, which we give away for free. It's not the actual Auto AI search. It's not like the join optimizer that does the search, but it's the, you know, different transformers that the pipeline that comes out of Auto AI will depend on. So you can kind of go run that thing in any environment, and it's just, you know, one of the outputs of Auto AI that we're kind of giving to you as a result of your run. So doesn't have that, you know, lock-in to Auto AI in the system, but you can use it that way if you want to. It's just kind of, you know, it's a way to give that to the end user.
No, that's brilliant. I think that, you know, one of the other concerns, apart from transparency, is also the lock-in into a certain platform. I see Matt Hamilton in the comments is saying the Save as Notebook feature in Auto AI is very cool, and it's very helpful in learning the steps. So I couldn't agree more.
Well, thanks for that. Yeah, I think also in terms of transparency, the user interface that we have, if you run through Watson Studio, there's also two ways to run Auto AI. You can run through the Auto AI SDK, which is like the command line version or programmatic call, and then the other one is through Watson Studio, which has an award-winning user interface, which I give a lot of credit to our design team. They've done an awesome job with that, and it basically enables you to see how the Auto AI process itself is evolving and what stage it's in and what's happening. And then you can also see the pipelines that come out and dig into them. And I think my favorite feature there of what you can dig into is you can see the feature importances. So you can take a look at, and also the confusion matrix and all the other metrics. We compute all the metrics and you can see those. So the data scientist probably loves to see this. And it's a very, it's just a clicking through user interface. So you can get the Jupyter Notebook out, but then if you also just want kind of a simple way to dig into things and see what worked well, you can see that in the UI. And so like one cool thing there in the feature importance is we have this feature engineering step where we've tried a bunch of different transformations on the data, some which work and some which don't. And of course, Auto AI tries to search and find the ones that do work. And then in the feature importance part, if you click into the pipeline, you can see which of the original features help the model the most, and which ones of the features that we generated help the model the most. And you can really get a sense in kind of a sorted order of what's helping there. So this is another example, I think, of the transparency and how you can see how things are working. You really start to get a better feel of how the data looks. And I don't want to say that we've solved it at all, because there's a lot more research we're doing and want to do around this. One thing is around how can we have the user provide their own transformers, essentially, so that AutoAI can search them. So that's something we're looking into. And then, you know, there's a lot more things in terms of explainability and just making the data understanding and experience of what's going on with the data clearer to the user.
Okay, so just going back to the feature engineering bit, I always thought that was a really cool feature, and I'm trying to figure out, why did it take the log? Why did it do the sum? Oh, it did the product. It's doing these cool things. Can you give us an insight on how the feature engineering aspect of it works?
Yeah, and I think the most important thing to understand there is that the whole AutoAI approach that we take in IBM is, at least currently, evaluation based. So it means that we're just like a data scientist trying things. So in the feature engineering search, it's using reinforcement learning to search transformers that may work well for the given model. So before feature engineering, we have this model selection phase, and K models, the top K models come out of there. That's configurable. It could be 1 or 2 or 3 or 4, however many models you want to take out of the model selection search. Then we do hyperparameter optimization and then feature engineering on each of those models, because we're trying to find the features that are best for that model. And when we do that, we do this reinforcement learning based approach. So basically it uses the model that it found to evaluate the quality of the transformations. And in the beginning, we have a list of transformations that we think work well, but for a given data set and model, that varies. So we have to try. So it's really an evaluation-based approach. We're building a tree internally that we're searching using reinforcement learning, as I said, to try to figure out which transformations are working the best. And then we expand the nodes of the tree based on which ones look the most promising. And it's limited by a number of iterations. So I think by default, it's like 60 iterations that we're building this tree. And then in the end, we choose the one that had the best performance. So it's completely evaluation-based approach there.
Is that configurable? I remember when I started my experiment, there was a sort of easy, no, I shouldn't say easy. There was a path that was determined for me with all the stuff configured. It tried to make guesses, and also some things are pre-configured, but I was also allowed to change certain things.
There's some of that is configurable. So the number of top models, I think, is configurable. The number of iterations I think that's coming soon, kind of, where you could have, like, if you want a configuration that's fast but maybe not as accurate versus a slower but more accurate, we're looking at how we can have the different configurations set up for that. So that's probably coming soon, not quite in there yet. But the code is structured in the backend so that that's all possible. It's just, I think, a matter of what's the best experience in that sense. But I also, through the SDK, I think you can try a lot more things too there in terms of controlling the number of iterations and things if you feel like getting at that layer. And we also have, so basically the AutoAI run itself is kind of the AI building AI. There's another aspect of automation which I think is interesting, which we've started to do before the AutoAI run. So right when you upload your data set, we make the prediction that we think it's a regression or classification problem by looking at the data, what metric we think might work well. And we're trying to explore more how we can have this, one of our researchers is, I think, calling it like a human-directed automation, where it's automation, but you can also change it. So, like in this case, if you actually want to treat it as a classification problem with many classes instead of a regression problem, you can change it. AutoAI kind of found that most data sets like this are regression, but you can change it. So that's another aspect that we're looking at. I think that gets at what you're talking about in this beginning configuration piece. How can we still give the human interaction while also helping with automation there?
Yeah, I really like the term. I'm going to steal that from you. Human-directed automation.
Yes, I like that term a lot too. It's not from me. It's one of our researchers, Dako Wang. Yeah, he did a lot of research into this, and it's a great term. I agree. Yeah.
Yeah. Let's see. There's a question by Matt in the comments. There was a talk earlier about stacked learning models, which are now supported in scikit-learn. Are there any plans to add that to AutoAI?
Yeah, so at the moment we're planning that some of the ensembling methods are coming soon. Basically, we have a lot of models that come out of AutoAI, which internally are ensembling. So like the gradient boosted machines are the best example, like XGBoost, LightGBM, where they essentially build a bunch of decision trees and use boosting to improve the score. So it's multiple trees together. But then since we also have a lot of pipelines coming out of AutoAI, we've added some functionality in the back end to stack them or ensemble them in different ways. So that's, I think, something we have on the roadmap to come soon. It's not quite in the product yet, but you can imagine that the pipelines that are coming out on the leaderboard, if you combine them in some ensemble, it might improve performance a bit. So that's something that we want to enable soon.
That's really cool. The other thing I saw, I'm not sure if this is out yet or if it's in the pipeline, was the ability to get data from multiple files or multiple tables. Can you talk about that, what the current state is and where that's moving to?
Yeah, that's also a super exciting feature. I think it's in a private beta right now, so you can get access, but you have to go through the private beta process. So I think hopefully public beta soon. I'm not sure exactly the date, but basically this feature is a big one because you can, right now in AutoAI, you basically have to do any sort of joining prior to coming to AutoAI. You come with a single CSV, which has a target column, and you start predicting, which is great for many use cases. But maybe you have a database, or maybe you have a bunch more tables that have interesting features, which somehow join to this main table, and you want to use them. So this multiple table join feature is coming soon, where and this is, again, I think you'll like the UI. It's pretty cool, where you can visualize the different tables and join them together. You just provide the ways that they join, and then you start the run, and then AutoAI will search the ways that these could be aggregated. Mm-hmm. So the real value there is, like, if you want to group by a certain feature that's in both tables, and then some other values, other features to use in your final model, it will find things like this automatically. And I think a lot of times you'll find when either you're setting up a data science problem, or even in the initial weeks of trying to create a model for a given AI application, a lot of it is trying to join these tables together and figure out what features are good. So this really automates a lot of that. So it'll basically create this single table out of these many tables. And a lot of these features that come out of there will be potentially very powerful aggregations that could help the final model a lot. Very, features that we know work well. And then that CSV will then go through the same process that AutoAI has right now. So it's essentially kind of like before the AutoAI run, that's where this multiple table feature will come in. And then that AutoAI run will run as it does now. So we'll still try to generate new features, find the best model, etc. But it'll have this end-to-end now, where you can generate predictions still based on a target column in one table, but you can bring in many, many more tables, which may have all sorts of features that you didn't know about, and that AutoAI can find automatically.
That's amazing, because I guess in real world, data sort of lives everywhere. It's not nicely structured in one table for a project. Yeah. So there's a very interesting question, Greg, that I really wanted to see your take on it. And the question is, should I use MATLAB / Octave in 2020? Are those solutions still relevant with what we're seeing with AutoAI?
Definitely, I think they're still relevant, but I don't know. I guess it depends. I think that I've seen that a lot more in academia, and obviously there's I think a license cost associated typically with MATLAB. What we've done with AutoAI, at least at this moment, is we generate a lot of sklearn style XGBoost, LightGBM pipelines, which are Python based. And I think if you look at some of the trends, things that I've seen out of certain studies, is that Python is getting more and more popular. But I hesitate always on any sort of programming language question, because we all know how quickly that can change. And I think the key for any sort of programmer or data scientist, somebody working with code, is to be using the tools that are the best and the fastest to get the job done. So I'd say right now Python's at least on the top of the list there. Depending on your application, maybe MATLAB, Octave are there, and of course there are others as well. Right. But yeah, I don't know. I think it's a good question, and my answer is depends. But I personally think Python is very powerful for data science, and a lot of people agree with that.
Yeah, so I'm coming from a software world, and when I started learning more about data science and Jupyter Notebooks, data science, I tried R, and then I tried Python, and I just naturally gravitated towards Python just because of my background. So I think there's something to say about that as well.
Yeah, I agree, and I think when Python gets better and better, and more people that use it, the better it gets. So it's doing pretty well. It has, I guess, some issues, but for data science, it's definitely the hot one right now. So yeah,
right.
Yep.
And I love what you said about you mentioned scikit-learn and a couple of other open source frameworks. Can you sort of talk more about Auto AI as a solution, collaborating / relying on some of these open? How do they work together?
Yeah, so I think basically, like I was saying, the notebooks that are coming out of Auto AI, a lot of them have, well, you can see the code, and a lot of the models will be open source, or the models will typically be open source. So they'll be sklearn models or XGBoost or LightGBM models. And then there are some transformers and things like that we've built that are in this Auto AI libs package. But yeah, no, I think it's important to use these great models because they're the state of the art. And we also have an open source package within the broader theme that I work in here called Lale, where they and you can see Lale in one of these notebooks that Auto AI generates, where it's basically an open source package where we try to make this interaction with the pipelines that come out of Auto AI easier, and just kind of give a better syntax for hyperparameter ranges and things that are searchable. So that's an open source library that you can check out and take a look at. So that's an area where we're trying to kind of be a part of that community as well. And so yeah, I think it's a huge part of any software system these days, and definitely it's an important part of Auto AI too.
Right. All right. And I know we're running out of time here, but between the data input that you talked about, that feature, plus the time series feature, I think a lot of exciting things happening in this space. How do you see? I mean, we talked about how Auto AI is not a replacement for data scientists. How do you see, or where do you see solutions like Auto AI, in the next 3, 4, 5 years, impacting our work and our jobs as data scientists?
Yeah, I see it as a collaboration and helping. I mean, I think that the investment in AI is just going to get larger. That's what a lot of the reports are saying. It's about, I guess, collaborating with our business partners who are finding better ways to use AI in their organizations. And then, so Auto AI is basically a solution there. It's like, if you have a problem, Auto AI can help you solve it. And the more, businesses are going to try to put AI in their enterprises more and more over the years as they come. And I like to see it as a collaboration. I think, as we've said, through the user experience, through the Jupyter Notebook generation, I mean, that's the whole way it's kind of built, is to try to automate these parts of data science, which are just painful, and where automation makes a lot of sense, where it's experimental, where you can, iterate and try a bunch of different things over and over again. And yeah, I think if you look at some of the reports, especially from Gartner, where Auto AI is mentioned, these automated approaches are becoming something that's very important to data platforms. So like IBM's, Watson Studio, Watson Machine Learning, OpenScale platform, it's very important for us. We want to bring automation across the whole life cycle, and Auto AI is a step in that direction. So I think, it's going to be a part of a lot of these platforms going forward. And I think the reason is just that there's a need for it. There's for many different reasons, as businesses invest more and more in AI.
Right. Another very high level question from the audience, and this is, again, I think some of the previous speakers also talked to this. Do you think AI would be able to code entire software in the future? I know it's not relevant to Auto AI, but for the sake of our discussion, I want to.
Well, I guess a quick answer in auto AI is that some of the work that we've done to like generate the hyperparameter ranges and generate the notebooks, these are essentially software created systems, but they're not exactly probably what the questioner is saying, but there's a bit of that there. And then I guess, so yeah, we'll continue to maybe go in that direction. I think you're still, what I would say though is there's never going to be a silver bullet. If you're a software engineer, you understand that the software development process is a long process and that there's, requirements gathering, and you have to understand what everybody wants and how the system is going to work well. So that part of it is always going to be there. I think the AI and the tech tools will keep getting better and better and better, and we're trying to do that with auto AI. But it's got to be about this interaction too, to make sure that the software that's automatically being built or semi-automatically being built or manually being built still is exactly what we need and what we want. So that's kind of where I see it. It's like, I think sometimes people can ask that question and just think, well, every part of the software development process will go away. Well, but that doesn't really make sense, because at the end of the day, we want software that works well for us. Like it's a tool for us to use. So that's kind of where I see it.
Perfect. Greg, thank you so much for spending that time with us.
Sure, my pleasure.
The next step would be to get a T-shirt that says "I love auto AI." maybe we work on that.
Works for me. Yeah. I'm down.
It's an amazing solution that you and your team is building, and thank you for sharing some of the insights with us today.
Okay, thank you so much, Upkar. It was my pleasure. I enjoyed our conversation a lot, and I hope you get that break soon. I think you're almost at the end. I don't know.
Yes, we are. Thank you so much.
All right, thank you.
All right. Bye. Oh, hello, Pooja.
Hey, Upkar, can you hear me okay?
I can hear you just fine.
All right, awesome. How's it going?
It's going well. Thank you for joining us. Let's see. I'm just gonna quickly go through the comments and see if there's anything here. All right. So, Pooja, thank you for joining us. This has been a super exciting conference so far today, and I'm glad you're here. This is our last slot for the day today, and I'm so glad I'm ending this day with a conversation with you. So let's see. Let me do a quick introduction. Pooja is a friend of mine, a colleague of mine, a developer advocate with IBM, focusing on some pretty cool technology and solutions, including chatbots, natural language processing. I used to call Pooja Node-RED Queen. So there's this platform called Node-RED, and Pooja knows a lot about that. Building AI ML models in general. So Pooja, is there anything you're not doing these days?
I'm still I'm still learning every day. I feel like I'm, picking little things here and there and trying to learn them. And then, obviously with technology, there's just so much and things are constantly changing. So just keeping up with everything, and especially in the AI world. My talk is all about conversational AIs, and even this year we've seen so many new changes with that tool and what that looks like in the market. So yeah, just keeping up with the trends.
No, that's awesome. I love that you're constantly learning as a developer advocate. That's very important. So for folks who could not attend the talk earlier, give us like a quick 2-minute summary of building smarter conversational AI.
Yeah, so my talk is really about building a conversational AI using the Watson Assistant platform. And for those of you who haven't really used that platform or are learning that, it's a really great talk that talks about just using the tooling to build a conversational AI that not only is effective for a specific use case. We kind of talk about 2 different use cases. We talk about a travel use case and a
Hey Pooja.
Yeah.
Just before you continue, there's a lot of static coming from it. And I'm not sure if the mic is working because I can hear a lot of background noise.
Okay.
So there's a lot of noise, plus there's a lot of like static So I'm wondering if the mic is on or if it's connected. And it just seems like the voice is not coming through the mic.
Is my mic okay now?
I can hear you better. There's background noise that's on that, but
Okay, all right. I hope that this is a little bit better. I was playing around with this a little bit, especially with StreamYard. I was having some issues, but I think I wanted to just to go back to your question. For those of you who guys missed my talk, I would highly recommend you check it out because I'm really talking about Watson Assistant as a platform, which allows developers specifically to build really engaging bots, especially using tools like some of the inbuilt NLP tools that we have, as well as some of the inbuilt tools that allow like a lot of dynamic data to be transferred. So we specifically dive deep into webhooks and using and building a webhook API that takes a lot of data from a COVID API, and then you can actually use that data to kind of return some output that might be useful. So it's interesting because we're taking a couple of different components, and with the Assistant platform, it's really intuitive to do that and also deploy it across multiple different devices and channels as well. So yeah, really just diving deep into the use cases there. So yeah.
No, that's perfect. So this whole chatbot revolution, I remember when they first came out, and every Facebook Messenger or even like even internal company communication channels would have some sort of bot that was ready to help you out. But for most part, from what I could see, the bots were not that well designed, or they broke often, or they weren't very helpful. And I'm wondering, in your opinion, what do you think is the current state of chatbots as you see, with the clients when you do workshops?
Yeah, so I think the chatbot revolution was really booming in 2017, right? And so I would still say that chatbots are relatively popular, especially in the customer service space. They're really helpful for businesses and to create really strong brand images and provide some of the best customer service as possible. I think there's some data that is, given that was, IBM had collected, where most companies spend majority of their yearly earnings on just answering customer requests, and chatbots are really there to help mitigate that. But of course, there's, with the rise of chatbots, it's also the effectiveness of chatbots. I do see there's a trend of sometimes being too many bots on too many channels, but how do you mitigate that and kind of provide like a more easier conversational flow in one spot? I think that's been one of the challenges, especially as we move forward in this revolution. And of course, chatbots are becoming a lot more human-like today. They are taking over in a bunch of business sectors, and they're helping companies interact with their customers and in different channels. So for example, you can now order an Uber on like a Facebook Messenger. So you can see that cross-interoperational ability of different applications being run through chatbots. And they're a lot more AI driven now. So, for one of the best examples is that a chatbot is capable of handling any customer query and also doing some predictive analytics that can anticipate some of what a customer's needs are before a customer even goes in and tries to interact with the bot. And they can also help guide through a lot more complex issues than they were before. So I feel like the market is becoming a lot more proficient and advanced with the type of insights that a chatbot can give. The one thing that, along with the insights, chatbots are also gathering tons of data, and they're also giving so much they're also providing a lot of rich customer insights for customers themselves, and this lets just businesses do their jobs better. and know what issues are happening. So I would also say one big trend that's happening in 2019, 2020 is that voice experiences are becoming a lot more mainstream. We all, of course, know all the different voice bots that are out there, but now I think the ability to be able to plug in that technology is a lot more mainstream. And actually Watson Assistant just came out with the newest release of that, where they're going to be involving, especially on their Plus plan, making voice integration a lot more easier. So I think those are some of the new upcoming trends that you can definitely see. And I don't think they're going away. I know that 2017 was the big boom, but I think it's becoming a lot more ubiquitous, I would say. Yeah.
Right. Yeah, no, I agree. And I like what you said about it's not just the chatbot, it's the integration of chatbot with the other AI components and solutions. Yeah, that's great. Speaking of, I'm sure you've built one or two chatbots now in your career.
Yeah.
What does that process look like of going from, I don't know what the first is, the requirements gathering to deployment? Is it like the typical software lifecycle? Does it look any different? What does that look like?
Yeah, so I can talk a little bit about, the two of the bots that especially that I showcased during the workshop. So both of them, as a developer advocate, most of the bots that I build are really for educational purposes, right? So the bots that I built aren't really for the live use case, so maybe my perspective on this is a little bit different. But especially for our COVID crisis bot, the way that was initially designed, it was designed by first getting the most common questions and answers for that particular issue. So what we did was we actually scraped, the crisis COVID FAQ page just to understand what are some of the most common pressing issues for that particular use case, and we use that as our basis to build our intents. So in that scenario, just to have an idea of what your use case is, what your customers or what your users will be asking, and then having that one-to-one mapping of what the response will be, that was really the thought process behind that bot. But for our travel bot, so I was working on a team where we built a whole end-to-end microservice filled application called B Travels, and we had 4 different services that we were working with. We were working with a hotel service, a car service, a flight service. And with those services, we wanted to also create a bot that not only could you book a flight, hotel, or a car through the web chat, but you could also book it through the chatbot. So just to go through the entire end-to-end flow, mapping that out. So I remember my colleague Max and I, we would actually initially just map out the flow of what do you go through when you actually go through a travel website. You first find where you're going, then from there you look at the hotels, the check-in dates, check-out dates are important, price is of course important. So building that whole flow of how a user would first go through and get the figure out what destination to put in the kind of price that they want to book a hotel. I think mapping that whole flow was something that we both needed to do. And then of course taking into account, what if a user wants to change their destination? Well, that means we have to make sure that our chatbot can exit that conversation and go back to a previous conversation, and so on and so forth. So for anyone I recommend doing this or is thinking about doing this for their businesses, I would suggest first come up with a user flow. I think that's very important. Before you even start the chatbot process of creating a bot, you should really think about is what are your users going to ask, and where will they get stuck, and where can they opt out, and where can you collect some information. So in our case, we were collecting information on users' location preferences, as well as their price data, because we have a service that's specifically on mapping
flights to their budget. So I think just thinking about it holistically, taking a step back, and then tackling it is really critical. So in that case.
Yeah. So you did mention, you did mention the Plus plan of Watson Assistant. That's the tool you used to build conversation this morning in your talk.
Yeah.
So just to be clear, there's also a light plan. Is that right? With Watson Assistant?
So there's a light plan, which is really great. So for anybody who is interested in building one, you can actually build it completely for free. And the light plan is really, really useful, and it's really robust to at least get you started. So one of the really amazing features that's available on the light plan is the web chat feature. And so this feature is one of my favorite features because it allows anybody to kind of build a bot and then just design the bot, design the look of the bot. They recently came up with a feature called Homepage, where you can actually add your company's logo, your branding, and the 3 topmost questions that someone might ask you as part of your home screen. And then when you click to embed the bot, it's only 3 lines of JavaScript. And all you need is those 3 lines, and you can embed that bot across any user interface. So for those of you who are, UI developers, this is really useful because that whole embedding process of embedding a bot into your UI, it practically becomes so seamless that there's no work to it at all. So no coding, it's all kind of there. Yeah.
Especially for, you said for designers, I'm thinking for non-designers like myself, I have no idea how to write the CSS to actually create something like that. And yeah, that feature is, I think it's very cool.
Yeah.
So tell us, let's say two of your top features outside of that in Watson Assistant on any plan. What 2 features you think are the most important that save a lot of time or?
Yeah, I love the web chat feature because it just makes it so easy to integrate anything that you build on Watson Assistant across any user interface. So that I would say that's my #1 feature. But my second favorite feature is the use of webhooks, and that's directly integrated within Watson Assistant. So for anybody who is looking to send some data or from any API, so from a weather API, or if you're looking to send some data for what kind of movies people might be interested in, you can make that process very seamless through the webhook feature, because all you need to do is integrate that webhook that has the code to hit the API, and you can actually send any data. So I think that feature makes your bot super dynamic. So it's not just a static like question answer type of thing. You're actually getting real life data that's being sent across. And then if I were to talk about my third favorite feature, which is the analytics feature. So that feature is like, once you have your bot deployed, you can actually see what kind of questions are most being asked, what time of day people are interacting with your bot. So I feel like that one's a really useful feature, especially for those of you who own businesses and want to get a better insight of your customers' activity. And I feel like that's a very, very useful aspect of Assistant. So
yeah, no, for sure. So can I chime in with my 2 features? So the first one for me would be I forget what the feature is called, but you give it your existing data, and it tries and finds utterance, or you give it utterances and it finds intents out of that existing data. I think that's really cool, and it's really important because a lot of times, especially enterprise customers, as Peter was telling us before in the first talk that we did today, is that the advantage that enterprise customers have is that they have a lot of data. They have a lot of existing data from clients and support calls and Q&As. And so I really enjoyed that feature. And the second one for me would be the disambiguation, which is very, very cool. And so for folks who in the audience who don't know what this is, Pooja, do you mind telling us what that feature is?
So the disambiguation feature?
Yeah.
Is that the one? Yeah, so I think so correct me if I'm wrong, but I believe that the disambiguation feature really lets you kind of opt out of a conversation and disambiguate as well. So one example I think of that is it's all about if you want to kind of, I think for me, I think the way that I think about it is a feature that lets you, one second, sorry, just get out of any conversation, and then especially when you're trying to have a specific conversation there that lets you kind of escape that particular talk. So
yeah. No, when I was using it before, the demo I used to give was, let's say if the bot is for a car mechanic and you have to book an appointment, take your car in, let's say, and the question that the bot may ask you is, so why are you coming in? What's the purpose of your visit?
Yeah.
And instead of saying, instead of saying my windshield is broken or my tailpipe is broken or whatever, you might say my car is not working. And so my car is not working is a very sort of bigger concept, and it's not very clear what the problem is. And so there's a feature in Watson Assistant that'll help you get that clarification from your user, from your client, without having you to put in that logic for it to do that. And it uses NLP in order to do so. So yeah, thanks, Pooja. I think that's one of my favorite ones is the disambiguation. So there's a comment in the chat saying feature vectors and word embedding. To that audience member, I would say correct. So those are the core NLP sort of concepts that you use in order to create I wouldn't say a bot, but any sort of natural language processing or natural language understanding. You would use something like feature vectors and word embeddings for sure. With Watson Assistant, the cool thing is a lot of that is sort of hidden from the user, and so it makes using Watson Assistant a lot easier for programmers or line of business people, for sure. Sorry, I'm just reading the comment.
No worries.
Interesting one. Rohit was saying that I once built a spam bot with Python to spam my college buddies. Yes, all sorts of use cases for building bots, for sure.
Definitely. So I think the one really cool thing about Assistant, I know that a lot of you guys might be interested in like integrating across different platforms. So the one thing is that you can actually integrate with Slack or Facebook Messenger. So you don't really need to learn any new SDKs. It's all kind of like built in there. So that's also a really neat feature, especially if you're thinking like, how can I kind of build this across multiple different platforms? So if anyone has that, especially with businesses, I know a lot of businesses now use their Facebook as their main business platform, and with a direct integration to kind of build a dynamic bot there, you actually don't even need a web application. You can kind of do all your business interactions there. So so that's really nice.
Yeah, I like that Watson Assistant focuses on conversation, and to me that's so important. You're building intelligent conversations and not necessarily chatbots, not necessarily tied to a platform. And now you can take that conversation to Google Home or to Alexa or to Slack or on your website or on your phone in an app, right? So that is very important. I think that's sort of the way to go. And then you can customize that on the different platforms that you're working with.
Right, definitely.
So there's another question, Pooja. It's the question is, can you use pre-trained models with Watson Assistant?
Yeah, so I think So depending on what you mean by pre-trained models, like what kind of models. So if we're thinking about like natural language processing models, you know, so Watson Assistant is already trained on an NLP model where you can extract like keywords, entities, sentiment. You can extract a lot of that, you know, data from the bot itself and from the conversation you're having. So I think it really depends on what you want to train your model to catch and what use cases are there. I believe that you can, but I think there is like a standard NLP model that Assistant uses. And the way that you train your NLP model is by the creation of intents and entities. So you can actually train it while you're building it. And it's all based on the kind of conversations you and your customers would have. So especially when you go through building Assistant, the recommended types of intent is 5. If you do more than that, you can, you know, you're ensuring a much more stronger conversational flow. There comes a point where you can overtrain your model there, but you want, you know, within the application itself, you're actually training your conversation while you're building your conversation. So It's not like you have to pre-train it before and import it. You have to make sure the dialogue itself matches the use case, and you can train it while you build it. And you can make your bot a lot more stronger as you get more specific about the kind of conversation you're having. So yeah, that's the one really great aspect, is that, you know, you don't need to pre-train it. You can actually train it while you build. So yeah.
Yeah, that's a great point, and I think that answers the question for sure. But you also mentioned webhooks, and so if people do want to bring in a very custom endpoint or service or model of their own that they have spent a lot of time and data and people and resources to train, then Watson Assistant could talk to such a service using something like webhooks.
Definitely. So you can, you know, if you've already built something, you can actually connect it and get that data through the use of webhooks. You can also use webhooks to just get like API data. Webhooks really just make your bot a lot more dynamic. It gives it a lot more hands to use, based more than just what you have at default. But the default stuff is actually very strong. I think my perception with chatbots is that a lot of people try to make them really complicated, and I think that's how you have a really weak conversation, is like if you present too many options and you present too many conversational points, you have to kind of figure out what's the minimal viable, like how do I end this conversation as fast as possible and get the customer or whoever what they need. If you give them too many entryways, there's too many points of failure. So yeah, keeping it minimal.
That's a really good point. So keeping it minimal, keeping it specific. It's not a general. It's building a general or a generic chatbot is a whole different story than building something specific for your use case, for your domain, for the context. And it's important to keep that in mind for sure. There's so much to talk about here. One of the other features that I love with Watson Assistant, because a lot of people in the chat are asking, you know, the ability to be able to customize some of this. And I know there is an expression language you can use inside your chatbot to add little snippets of, I would call them program, right? These little code snippets that can add more logic to your chatbot in addition to what that core NLP model is providing.
Yeah. So within the bot itself, so the way that I think about building the bot, it is a lot of logic and if-else type of, you know, there. So like if you're building a dialogue, you want to, you know, always think about like, if the user says this, what's the response? And if I want to give them multiple response, you can use, you know, multiple responses. Or if you want to gather information, you can use slots where you're actually defining a variable, and you're if somebody gives you this variable, then you want to give them this output. So I think I mentioned this a little bit earlier, but you do want to, when you design a bot, you want to design it especially like an if-else tree, and keep it very specific to your end use case. Because if you get any broader than that, there's a lot more room for errors and a lot of room for, like if you think about it yourself, if you're a customer and you're using a bot, you want a direct answer. You don't want to eventually end up wanting to talk to somebody on the phone, so trying to minimize those gaps there, I think is the key.
Yeah, absolutely.
Yeah, but I think the question was like, are there areas where you can add some code snippets? So I mean, the assistant is really UI based, so there's not really like a place you can add like code snippets, but the way it's designed is it's kind of like a big if-else loop. And that's kind of nice because these days I think low code programming is a big trend as well, and this kind of allows a lot more people to kind of get a stake, especially in designing and developing these bots. So it's not like, especially if you're working in whatever industry you are, it's not like you need to know a ton of programming to build an effective bot. You can build one fairly easily if you have the logic. So yeah.
Yeah, no, absolutely. The whole concept of dialogue as a if-else or as a flow is there, but then also that you can jump from different nodes to different nodes. You can add some dynamic nature there, and with the expression language, it gives you even more power to make it more dynamic than the if-else stuff. There's a lot of machine learning and NLP happening behind the scenes.
Definitely.
To make it look like an if-else thing, but it's definitely more than that.
Yeah.
Yes.
And I think that maybe this, Upkar, but I think we have a lot of different customers that really appreciate that that aspect of Assistant, making it more wholesome and easier to use. So, yeah.
Amazing. So, Pooja, thank you so much for spending this time with us, telling us a little bit more about your talk about Watson Assistant. I definitely agree with you. Chatbots are here to stay. Soon I'll be talking to my fridge, I'm sure. It doesn't happen right now, but it's coming.
Yeah.
So thank you so much.
Of course. And thank you so much for spending this time with me and chatting with me about this. I know, you probably have been doing this, you've been talking to a lot of different people today, so I'm glad I got to spend time with you. And for those of you who didn't get a chance to, check out my lab, definitely check it out. I think the replay will be up as well, right? So folks will be able to watch it afterwards as well. So yeah, we go through building 2 different bots, so make sure you get, you can dive right in and get a hands-on feel of what that'll look like. So yeah. Awesome. All righty.
Thank you.
Thank you. All right. Have a good one.
Bye, Pooja. All right. So let's bring my partner in crime, Matt, back in. Matt, did you have a good nap?
I had some dinner and I came back again. So yeah.
Well, sorry to keep you up late. But it's great to have you back here.
The content has been awesome, right? So, I mean, the speakers I spoke to, that Sean spoke to, that you've spoken to, it's been such a good stream. I mean, that's why I've been sitting here watching it, right, all this time, because it really has been some fantastic information in there, and some great insights to, the practical aspects of AI and data science as well. And, just getting to ask the questions of the speakers and that, get into a little bit more detail was really good.
Yeah, no, I loved how we went in certain talks. We went deep into the weeds, and we talked about specifics of the solution. And then in other talks, we were 50,000 feet high and looking at the landscape and what that looks like. So yeah, no, it's been very interesting. As I'm very happy to be part of this today.
Yeah, it's been great. So we've come to the end, everybody. So thank you very much for coming along to the stream. We've had a fantastic response. It's been really good. All of the talks are up on the website still. They're all on demand. You can still access them. I think they will be there for quite some time, so you can go and check them all out. Maybe you heard a talk today in this track, and you want to actually go and find out some more, so you can go into some more detail. So go back to the conference website, and you can go through all of the talks there, and they're all available for you as well. If this is your first time on Twitch, on the Twitch channel, this is the IBM Developer Twitch channel. We stream on here very regularly. So come along on here. There's various talks about AI. There's talks about things like containerization, all sorts of aspects of things that IBM work on. So come along. We've got a great bunch of developer advocates on here that talk on here as well. And there's also, as well as that, there's a number of other sessions we do. So Upkar, I believe you run the Crowdcast channel for the main IBM developer. So crowdcast.io/IBM developer. And we also have crowdcast.io/IBM developer Europe. And so there's multiple sessions per week on there, again, ranging a whole load of different topics. So go there and check them out as well. So just to wrap up, just want to say thanks to my co-hosts, to Upkar and to Sean, and to all of the speakers that we've had today that have come on and chatted to us, and behind the scenes as well to Spencer, Mike, Jason, and everybody else that's been helping organize and make sure everything runs smoothly. Thank you to all of you as well. And yeah, so good night, good afternoon, and see you around soon.